初めてのお礼の攻撃到達。おめでとう貴族様。
何？体に魔法陣。なんじゃあれは。体に魔法陣を書いておくなんて常に魔力を消耗していくはず。相当なリスクを伴う行為です。
その通りだね。でもそれが彼のやり方のようだね。
あいつは一体。何なんだ。何者な。
生まれたしょうもねえ怒りの化身だ。受け取れ偽魔法騎士。
あの空間魔法を跳ね返した。
威力が倍になってるじゃないの。
何者でもないやつがふざけるな。
バカ上がりの姉は姉ゴレオンだろ。ゴレオン
誰か三兄弟は
実際にゴレオン活用する
で命名されていない。
なんだ、五段活用みたいにゴレオン活用するんだと思ってた。
馬鹿げたことを。
どうも闇団長。
こぞつ
貴様もだ。功績発表に遅刻どころか欠席。
いやもう俺団長だから。
闇目。
なんだ貴様。貴様も。
姉さん、私もついてくから大丈夫っつんところにいた。ちゃんとカホタのおかげじゃない。無沙汰しています。では
ノエルか。
はい。
お前もだ。
何？ちょっと私は関係ないじゃないの。
には見せら
しな
特に
やってますか。
いや
だろう。
マジメ
いかん。ソルのどうして取り乱してはこうだ。
どうしてその気が。
貴様こそなんだ妙な衣装は。
特にその下半身の中の男ナンバーワン黒の
ってねんじゃねえか。
何やってる。
バネサ
こうですよ。黒の
Shot.
Got one. Enemy down. Bandit bus farm. First blood. Fox 3, missile off the rails.
Enemy shields broke.
Round 1. Beginning ring countdown. Good. Inside the next ring.
Just giving my shields a recharge.
Enemy shield broke. Getting attacked by another squad. Putting up some cover. Grenade, heads up. Hey, who invited the third party? Crack the booby seal. Registers are. Crack the booby seal. I'm out of light ammo. Let's go here.
Someone behind me.
Need some help over here.
Left.
Bogey over there. I'm here. So let's get you a
I'll
do-over,
go tap
huh?
you after. Knocking behind you.
Hostile right here.
is the protocol of the internet. So we've already talked about moving data between machines. That was the internet protocol, IP for short. And we took this system and made it reliable using TCP. So now we have a way of reliably sending data back and forth between machines. You can think of this as sort of the bare bones infrastructure that we actually need to build applications. But HTTP is a application layer protocol that's built on top of IP and TCP. This is what we actually have control over. Now there's a lot we could talk about with HTTP, but I'm going to be focusing on the basics because that's really all we need to know. A lot of the really small details aren't super important and they're definitely not worth memorizing. So we'll be really focusing on the big ideas. The single biggest thing about HTTP is that it's a request response protocol. So the client makes a request and the server responds with the response, or RES for short. Now it might make a bit more sense why we were talking about this whole client-server model and about RPCs, because HTTP is just about sending some request to a server, and that request will have information about what we want to execute, what kind of code on the server are we trying to execute, and the server will run that code and then respond with what we were trying to get, or maybe there was an error that occurred or something happened in between. But there are basically two pieces of this communication. The client initiates a request to do this. Now under the hood there is a TCP connection handle, there's the handshake, there's all that. So it's important to know that HTTP is built on TCP and all the overhead and cost that comes with that. But as developers, we don't really see that. There's no state management between the client and the server. Everything needed for the request and the response is handled in that request and response. The client and server don't need to know anything about each other other than what's already included in the request. And I think the quickest way to learn about HTTP is just to show you. So let's go to youtube.com and do a quick demo. The first thing you probably already know is that HTTP is used pretty much every time you search for something or land on a web page. In this case, we actually have HTTPS, which is a variation of HTTP. This is what is commonly used. It's pretty rare to just use the bare bones HTTP nowadays because it's less secure. But you'll see if I take away the S and then press enter, it'll actually it'll redirect us back to HTTPS. Most websites do that by default. But what I want to show you is the network tab. So if you right click anywhere and you see inspect, this is your browser's dev tool. You may already be familiar with this, but you can go to the network tab and then see all requests, all network activity that's going on from the site that you're on. Let's go ahead and search for neat code and see what happens. The actual site isn't super important, so I'm going to cover most of that up here. But here you can see all the list of requests that are going on. And this is probably intimidating if this is your first time using DevTools, but this is the list of requests. So this is like the name of each request. I'm going to kind of close this. Most of these are HTTP requests, and we can sort of filter these by name, status, type, initiator, all these things. I'm going to go ahead and right click and then reveal the protocol. This is kind of what we've been talking about. So this says H3. That stands for HTTP version 3. There are multiple versions of HTTP. I'm not going to go super in depth to that, but HTTP 3 is the most recent version. And now actually looking at one of the requests here, this one results, let's get into the anatomy of an HTTP request. So one component is the headers of a request. Every request has two main components. One is the header and another is the actual body of the request. So there's actually three groups of headers. One is the general header. This includes some really basic stuff like the actual URL that we're making a request to. So when we type, youtube.com into our browser, we're making an HTTP request here. When we searched for neat code, we also made an HTTP request to youtube.com. So that's like the base URL. And we also have a path here. So results with a query of neat code is how we landed on this page. There's a couple more important fields like the request method. So in this case, we made a get request. There's a few more really common request method types, namely post, put, and delete. There's a lot more, but those are the four most commonly used. And we also have status code. So
Someone landed here. Have I? Claddy?
I'm fencing.
Pick up the ammo! The fucker?
My weapons enhanced, ready to dance.
Round 1. Beginning ring countdown.
Laser sight here, level 2.
Attention. First blood.
We aren't all in the ring. Do not.
Extended header mag here, level 2.
1 minute. We have time to strategize.
I could use that. Extended sniper mag here, level 3.
Attention. Evo harvesters.
A useful tool.
Extended light mag here, level 2.
There is a new kill leader.
New kill leader. I'll make sure they don't sneak up on us. 30 seconds, rings close. Enhance the weapon. Magnifique. My weapon's enhanced and ready to dance. Let's get some air. Fence in position. Ten seconds, the ring's just ahead. Let's get some air, Doc.
In progress.
Listen up, the ring's moving. Let's explore that way. I'm here. Bottomless
Deploying an evac tower.
Someone's over here. I'm also down to go to you guys for fighting. What are you guys gonna do?
Let's go here. Allons-y. Tout le monde. An evac tower's deployed over there.
Which one?
Attention. Delivering care package.
Care package coming in. Let's get some air.
Don't see any more, but there is an
Let's go
octane
that
over here.
way. Oui.
Let's go to this one.
Let's get some air, Doc.
Right in front of us.
Might be
Right in
something
front.
good. Attack here. Let's
Nice.
explore that way.
There's two down on that.
Adversary. Hostile right here. Hostile spotted.
To win. Time to bind you.
Reload.
My bambo!
Throwing a grenade. Sending an arc star. The enemy. Sending an arc star.
Let's get some air, Doc.
Doc dynamite. Fence placed. Enemy at that location. Enemy shield cracked.
Recharging my shield.
They went up, they went up. I'm coming to you. Soon.
These bonds aren't easily broken.
Reload.
I took out an enemy. Unnecessary evil. A second squad is attacking
I'm
us.
coming to you. You come up or not?
Planting fences. I shattered an enemy's shield. Shields are depleted. Recharge. Target close.
Are they? They're up.
Grenade coming in.
I've got some hits on me. Doc's coming to you. Just giving my shields a recharge.
Enemy right here. Come on.
One's one on me. One on me.
I'm getting shot at.
Nice work.
The whole squad's been shut down.
Half of the squads have been disqualified.
There's someone. Above us.
Recharging my shield.
Keep fire. Cost no way out.
What?
Enemy shield cracked.
Enemy shield.
Shields are depleted. Recharging.
Doc's coming to you.
Evac tower out.
Walk out to the left a little bit.
Taking fire.
I killed one, I killed one.
Enemy down. Got my head on your feet. Lifeline's got your back. Fence in position. Grenade coming in.
Okay. Sheebar.
200, green in this case. You can kind of tell that this was a successful request also because the page actually loaded with the list of videos. But that's the main idea here. We're kind of familiar with this concept of a header by now. It's used to kind of give information about the request itself. How do we know where this request even needs to go? Well, it's going to this URL. What kind of method are we using? We're using get because we're trying to retrieve some information. Post would, on the other hand, be used to update the server. But we also have two more groups of headers, the request header and the response header. As the name implies, the request header is what the requester, the client, is actually going to set. You can see the authority is, the base URL that we sort of talked about, the method, get, the path, which we specify as the client. We decide what we're going to look for, what kind of information we're trying to get, except there's several more fields here. We won't be covering all of them, but you can take a look yourself, and you definitely don't need to memorize all these. We're kind of covering what you really need to know anyway. Another few are user agent. So this kind of says multiple browsers, but in my case, I'm using Chrome. And there's also accept. This is the data format that you're actually going to accept. In this case, we're getting an HTML page. You can tell that from the response here, doc type HTML. HTML. This is basically the HTML page that we're viewing after we type, something into the search bar. But going back to the headers, that's the request header. That's what the requester will set. Now the response also is going to set some information. So the response header will say, what content type was actually returned. The request header gave some options of what content, but ultimately the response includes some HTML. That's what text HTML means. So now let's actually review some of the things we talked about and go a little bit more in depth. So we know every request has to go to some URL, for example, youtube.com. Suppose that this is an API. This would be referred to as the API route. So this URL defines a route. Now this route could actually serve multiple HTTP methods. We could make a GET request to this route, and this would be its own endpoint. That's the term that's used to define, API, functionality with HTTPS. So this would be referred to as an endpoint. This is its own endpoint. This is the GET endpoint for this URL or this route. We could also have another endpoint using a different HTTP method. So we have some different functionality defined for the post method. So with GET at youtube.com, maybe, the server is going to return the HTML page for YouTube. Maybe post, though, would do something else. I don't know, maybe it creates a user account or something to this exact same URL. We're using a different HTTP method, and that is going to do some different functionality. So this is going to be its own separate endpoint. That's what it's called if you're wondering about the terminology. So what exactly is the significance of these HTTP methods? Well, there's actually not a lot to it. I mean, the names themselves are pretty self-explanatory. I think GET, you typically use GET to retrieve some information. So if we're getting, the YouTube homepage, that would be one thing, or maybe listing a bunch of videos as we did earlier by typing in some query like neatcode. Now, if you really wanted to, you could use an HTTP GET endpoint to create data. We could use GET to maybe create an account if we really wanted to and pass that information in the URL, maybe, the password and username in the URL itself, though we probably wouldn't want to.
Hang tight!
Not figure out where the fuck this guy is going.
Didn't think this thing could get more powerful. It did.
Attention. First blood.
Enhanced. Ah, now that's a beauty. Let's glide.
Extended heavy mag deal. Level 2.
Round 1. Beginning ring countdown.
Looks like we're in the next ring. Good.
Just giving my shields a recharge.
Some blockers. Got me. Nice shot, though.
One down. Taking fire, fellas.
On your feet. Land's got your back.
Some good news. We're in the next ring.
Charging my shield.
I can buy you in a second.
Enemy taken out.
Good job. Contact. Hey, I'm getting shot. Enemy shield. They'll never shoot through this.
Fancy another?
Bring up here.
Enemy shields broke.
He's Giga one.
One down.
Let's get some air.
Like what? Waste of time. Literally wasting my time.
Watch it, airstrike.
Hostile spotted.
Watch it, airstrike.
Where am I going?
Another squad coming in.
Are you serious?
Recharging my shields.
Contact with target. I'm taking a distracted enemy shield. Taking contact with enemy.
Almost killed one.
There's another
got one.
Enemy.
Hand cover's gone. Hand cover. Giving my shield to recharge.
Halo's up. Get inside and get right. Kill down.
But everybody. Sure, just play with this guy.
Putting up some hand cover.
Rest is on the right.
Charging my shields.
To have the password in the URL, that's not very safe. If somebody were to inspect the URL, they would see that information. But we would rather use a post request, and that's exactly what post is for actually creating information. So creating a user account or creating a comment or uploading a video, doing some kind of creation on the server is what a post request is for. And the restriction with get requests, actually, we talked about how the anatomy of an HTTP response, it has a header and also it has a body. Well, actually, get requests don't have bodies. So if we wanted to create an account, we could not pass that information into the body. Get requests don't really have bodies. They only have headers. Everything we pass in has to be in the header. That's why we have to include any extra information in the URL of the request with a get request. But post requests and the rest of these HTTP methods don't really have that restriction. They have a body, which we can pass additional information in. They don't really have bodies.
Wasn't looking real pretty now.
Breathe easy. I'm coming in.
Heating up. Hold on.
Haha! Here comes Gibraltar! Air's getting shot!
That way.
I'm down.
He has verbals.
Give me my shot!
They only have headers. Everything we pass in has to be in the header. That's why we have to include any extra information in the URL of the request with a get request. But post requests and the rest of these HTTP methods don't really have that restriction. They have a body, which we can pass additional information into. So going back to the network tab, I found a random post request that's being made. I think this is for some kind of analytics data for YouTube. It's API/stats.
Getting shot at.
Countdown.
And then, this long string. But heading over to the payload tab, this is the body of the request. So there's a bunch of parameters here and some actual data here that you can see. Not super readable, but this is the idea. This is a way for us to pass any type of data we want in the body. Like we could pass in what kind of account we're creating for leaving a comment. That could be passed here. Basically any type of form submission, anything like that. It's very flexible. So put requests are pretty similar to post requests. The main difference being that put is basically an update. So you can think of these HTTP methods as being sort of CRUD, where CRUD stands for create, read, update, delete. So with that, post would be creating, get would be reading, put would be updating, and then delete is of course deleting. There's a few other differences between the HTTP methods. The most significant being that these work a little bit differently with caching. Get we would expect to be idempotent. If we're reading some resource, we don't expect that resource to change. So get is typically idempotent. It's more cacheable. With post, we're creating a resource on the server. So this is definitely not cacheable. It's definitely not idempotent. After the first time that we issue a post request, it will continue to do some action on the server side. So this is not idempotent. Delete usually is idempotent, so it's more cacheable. But this stuff isn't super significant. I don't think you really need to know it. We also talked about status codes. That's essentially for the client knowing how the request was actually handled. Like maybe we made a request to youtube.com, but for some reason the server is having a problem and it can't fulfill the request. We would get some error code for us as clients, as users, to know what went wrong. Was it a server problem that happened? Or maybe we made a request that was invalid. Like maybe in the youtube.com search bar we use some special characters that we're not supposed to, some star or something. And then with that invalid string, the server, tries to parse it, but it says, this is invalid. I'm not going to respond to this type of request. And it would send that information to the client. Like you made a mistake. This is not my fault. This is because you gave me an invalid string. And so I can't do this. So the client should know, was it my fault or was it the server's fault? Or, what exactly happened? Maybe the request and the response was perfectly valid. How do we know that? That's why we have status codes. This is part of the HTTP protocol. And as you can assume, this would be pretty helpful for developers. We don't need this at the TCP level, but at the HTTP level, this is very useful for us, though this isn't actually required. If we wanted to, we could send very unhelpful status codes, and some people do, but that's not good API design. You definitely don't need to memorize the exact status codes, but I think, knowing that 200 is a successful response. So, status code 200, which I think we saw earlier. This codes. This is part of the what I make like the not post request. It will you knowing how the request was actually handled. Like maybe we made a request to youtube.com, but for some reason the server is having a problem and it can't fulfill the request. We would get some error code for us as clients, as users, to know what went wrong. Was it a server problem that happened? Or maybe we made a request that was invalid. Like maybe in the youtube.com search bar we use some special characters that we're not supposed to, some star or something. And then with that invalid string, the server tries to parse it, but it says, this is invalid. I'm not going to respond to this type of request, and it would send that information to the client. Like you made a mistake. This is not my fault. This is because you gave me an invalid string, and so I can't do.
Yelling is good for focus.
Landing on the sniper.
Let's go over there.
I'm gonna try to move over there.
He's gonna die. One of us is gonna die.
Taking damage over here. Dome shield out. Give me my
I've
shield.
enhanced my Enemy's shield.
Good one.
Competitor down. Achtung. Getting hit.
Inside the next ring.
40 HP on one.
Refueling my shield.
Other guy's 40 HP, I think. Something like that, I guess. I don't know. Probably should be of that. Just gonna do what I would say.
Refueling my shield. Shield. Competitor down.
Healing. How would you open that? Give me healing.
I'm down.
Did I tell you to die? Got back our teammate's banner.
My team played that like shit.
So the client should know, was it my fault or was it the server's fault, or what exactly happened? Maybe the request and the response was perfectly valid. How do we know that? That's why we have status codes. This is part of the HTTP protocol, and as you can assume, this would be pretty helpful for developers. We don't need this at the TCP level, but at the HTTP level, this is very useful for us, though this isn't actually required. If we wanted to, we could send very unhelpful status codes, and some people do, but that's not good API design. You definitely don't need to memorize the exact status codes, but I think, knowing that 200 is a successful response. So, status code 200, which I think we saw earlier, is okay. Basically, that means the request was okay. There's another status code 201, which basically means a resource was created. So not only was the request okay, which we know from it being a 200 level code, but whatever resource we were trying to create, maybe we were adding a comment to a video, it was created successfully. You can assume that this would probably be used for a post request rather than a get request. And then a couple more that we sort of talked about: client error code. 400 would be for a bad request, sort of what we talked about with like an invalid string. 401 would be for unauthorized. For example, we're trying to delete a video that's owned by some other user. We're unauthorized to do that. Maybe we're not the creators of that video, so we can't delete the video. Of course, this would be the status code for that. We could also use bad request if we wanted to, really, but this is just a bit more specific. And there are other codes: 404 for a resource not found. You've probably seen that in your browser before. There's also 500 errors, which are usually more rare. The most common would be something like 500, which is an internal service error, or 502, which is a bad gateway, or 503, which is just the service is unavailable. But at the very least, I hope this gives you a high-level overview of what HTTP is all about. It's really for us developers being able to execute some code remotely and then get a response, just like we're executing a function as a part of our own code base. The last thing I want to quickly cover is SSL/TLS. So this is where the HTTPS actually comes in, that last character, which actually reminds me we didn't talk about what HTTP stands for, because to be honest, it's not super important. It stands for Hypertext Transfer Protocol, and the last character S stands for secure, or it could just be HTTP with SSL. The relationship between SSL and TLS is that SSL stands for secure socket layer. It came before TLS, but people still use the term SSL even though it's outdated at this point, and TLS is much more widely used. TLS stands for transport layer security, and we'll only be talking about this at a high level because it's not super important for system design. The main idea is that HTTP is not necessarily secured against something called man-in-the-middle attack, MITM for short. Basically, if we're sending data, we know we have IP, we have TCP, and now we have HTTP, and adding the S to make it secure. Because if we are sending data, just like sending mail in maybe a cardboard box, where that box is transparent, where you can see, maybe we have, a bag of money in here or something like that, right, in the box. If we're sending boxes that are transparent, anybody who sees the box in transit can
Enemy spotted.
I've enhanced my weapon.
Lucky for you, I've got some extra supplies here.
I've enhanced my weapon.
Let's take a fight.
Actually, someone here?
Round one.
Clown there, lucky me.
First blood.
If we don't get our asses in the ring, it's gonna be a bad day.
Attention.
Should we get the cache of these or not?
My weapon is enhanced. That'd be an enemy.
A flock wouldn't escape now. Speed up.
Cheers, Biggie. Can I?
Attention. There is a new kill leader.
G'day, enemy here. Joker's shooting at me. Broke. Down.
We are already inside
What the
ring.
gay home?
Just us
What?
left. Reloading.
I just died to 3 different people at the same time.
Really?
Yeah, you can craft me. Or even when away, he might die. Yeah, no. I just go craft and res here.
Delivering care package.
They're like a literal AI.
Got back our teammate mana.
Defuse all.
Eliminated.
They're shooting at me. Let's kickstart this fight. Refueling my shields. Shield.
This guy sucks. I suck more.
They can see exactly what's inside and then open it up and take it. So that's where SSL and TLS comes in. If we're sending information on a site, we want that information to be encrypted. So from the client, if we enter our password 1234, for example, and then send it to the server, anybody in the middle of that HTTP request can see it. And we won't go into exactly how that might happen, but the idea is that networks are not very reliable or secure. Anything could happen. You could be at a coffee shop using public Wi-Fi, and those HTTP requests could be monitored, and someone could see that your password is 1234 in the middle. That's a man-in-the-middle attack. SSL and TLS basically will encrypt anything that you send over for example, and then send it to the server. Any enter a site, we want that information to be encrypted. So from the client, if we enter our password 1234, for example, and then send it to the server, anybody in the middle of that HTTP request can see it. And we won't go into exactly how that might happen, but the idea is that networks are not very reliable or secure. Requests could be monitored, and someone could see that your password is 1234 in the middle. That's a man-in-the-middle attack. SSL and TLS basically will encrypt anything that you send over HTTP. So if our password is 1234, this will actually be encrypted to be some kind of hash or something. Let's say it's XYZ. So even though our password is really 1234, that will become some other string like XYZ, and that will be sent to the server, and the server will be able to decrypt it and then understand that the real password is 1234, and then use that. And if for some reason it was sending this data back, it would encrypt it and turn it into XYZ. That's at a very, very high level, because I think we've already spent enough time talking about the most important parts of HTTP, and most people just take the S for granted. It just adds security. For example, if you were on a site like this, Never SSL, at the top left of your browser, you'll see something like this is not secure. That doesn't necessarily mean you're going to get a virus or something from the website. It just means that any data you send to this site, like your password, for example, you should be really careful about that, because if somebody is eavesdropping in the middle of the connection between your browser and the server of Never SSL, they will be able to see everything. But in this case, I'm not going to be entering any data anyway, so this site, the fact that it's not secure isn't really a huge deal. And the warning message here kind of implies as much. So having gone through all this talk about networking and protocols, we finally arrived at a solution, HTTPS, which is reliable and is easy for us programmers to use, and it's also secure, and we can use it just like we're executing functions locally. It just happens that it's happening over a network on a different machine. But using these concepts, we can build very, very powerful applications.
This enhanced weapon will yield superior results. Placing gas trap. Alternator here.
First blood.
I've enhanced my weapon.
Beginning ring.
Not all of us are inside the ring. Not all of us are worthy of continuing either.
My weapon's enhanced. Take the upgrade where you can.
I've enhanced my weapon.
Oh, you're fucking kidding me.
I need optics for an SMG.
I need light ammo.
Evo harvester.
Back to the cache.
Location of the next light arsenal here.
Extended sniper mag here. Gold.
Holy, no backpacks.
front of me.
Let's steer that way.
Alright. I'm down to fight though.
I'm good too. I'm gonna try to get the cash first.
Alright.
We're already in the next ring. Don't get comfortable. Locked up. Reloading.
One's behind us also. In here, in here.
Taking shots here.
Crack.
Trade engaged.
Thanks.
Recharging my shield. Victor, rival here.
Nice.
Subject down.
Get that today?
No.
I'm coming to you.
Attention. Delivering care.
Where is he? Where is he?
Inside. Where is
He's
this
right
comp?
Enemy shield broken.
Got him.
Comp's like it's fucking on drugs, bro.
Bro just got one clip totally.
I don't like the way this guy comps or whatever.
Adding another gas trap.
Instantly says, can you finish?
Another team.
Where?
Adding another gas trap.
I thought I heard one. I thought I heard somebody jump by me.
Am I right, I think.
Yeah, yeah, yeah.
Focused on this spot.
Right on me.
Yeah, on me. Good one.
Getting shot at. Competitor down. Chow chow. Move there.
Hide him far.
Way
I'm
up.
shooting on them.
Oh shit.
Data soon to follow.
Popping a
Double,
Phoenix
super.
kit.
My wall, I think.
Hold up here.
Practice subject.
Not my wall.
Refueling my shields.
Guy crawled all the way back. Can we push?
Wait, yeah, you jump forward.
You got the res off. This guy's one.
Oh, they jumped out.
Killed another one. Are these guys doing anything?
I hit one.
Shields.
What the fuck?
On me.
Reloading.
Broke their shields.
Knocked.
New kills avoided.
Deploying a variable.
Getting shot at. Broke their shields.
Okay, down
The last one. Subtracted.
Holy, these kids are bad, bro.
I swear my team's not doing anything.
Day 2 on roller and they're getting absolutely
I'm
deleted.
healing up.
Raising an activate. We will not let off the gas.
Where are you going?
Yeah, gosh.
Time to push max level to its breaking point.
Thanks.
This upgrade feels good.
Zipline over there.
Yeah, I was thinking that.
Attention. The kill leader has been eliminated.
Use this nitro gauge.
Wait, in front of me.
Competitor spotted there.
Oh, on us.
Yeah, on us.
And waiting.
I'm going up.
Go there.
This building.
Competitor spotted there. They're shooting at me.
Got one.
Competitor down.
Alright, I'm dropping.
Get down. Speed up.
Side, I think.
He's right there.
On me.
Adding another gas trap.
Top squad says we need to hold.
I'll take it after.
Or
Refueling my shields.
Respawn beacon here.
Healing.
Yeah, you just went that squad by yourself.
We are far from it.
They were actually terrible.
Level 3.
You say Abu was terrible. Abu is just
The ring is distant. 45 seconds before closure.
I've enhanced my weapon.
Oh yeah, we definitely gotta go. Wanna go through tunnel?
This enhanced weapon will yield superior results.
Why are you screaming?
It's my son.
Oh.
We're all outside of the ring.
We gotta go. Ring is far. You guys good?
Care package being
Out. Care package falling. Should we risk it? Boost is now to engage.
We should inspect that area. Another variable for the lab rats.
Enemy sighted. Far.
Taking shots here.
Oh shit.
Firing.
Don't worry about me.
You're fighting somebody.
Yeah, they are. You wanna push that?
Charging shields.
Got on the ramp.
Got a replicator incoming.
Come on here. Elite.
Laying down jammers.
We're being attacked by 2 different squads.
Oh,
Firing on
two different
subjects.
squads.
Ring closes in a minute, but we're near.
Recharging shields.
He's almost cracked.
45 seconds until ring close, mga kapatid.
Another squad coming from my right.
We've got a competitor here.
Taking fire. Cracked a subject. Recharging shields.
Recharging my shield. Up. An airstrike.
Hey, give me
Oh,
ulti.
wow.
Keep an eye
Yeah.
on the timer. Just 30
You
to
wasted
go.
his give you all. I don't know.
Do you guys want to come to me? Come to me, and then I'm just gonna queue behind them.
Fine with whatever.
Taking shots
They're
here.
shooting at me.
Let's go here.
Yeah.
I have shattered a subject's shield.
Ring close in 10. We're nearly there.
Knife brigade down. Speed up.
Recharging my shield. Don't worry about me.
movement in progress.
Dying out.
Incoming care package. Let's see who gets there first.
Uh-oh.
Inside this building.
My weapon's in hand. Take the upgrade where you can.
You said inside?
Inside this building.
Oh yeah. No, these kids are terrible. Why is everybody camping?
Bro.
Rally up here.
Oh shit.
Almost killed one. 160, 160.
Alright.
Low. Push him.
Knocked.
Minus one opponent. Refueling my shields.
He's shot. Knocked.
Gas trap deployed.
Armor swap.
Recharging my shield. Don't worry about me.
Reloading.
1 minute until the nearby ring closes.
Oh, team fighting back where we came from. We can hold them.
45 seconds remain before closure.
I'm gonna ring down.
Oh, never mind.
30 and the ring closes.
Oh, they're fighting just on the other side.
Deploying a variable.
Care package there. Activate. Give full gas.
Taking fire.
Don't go there. Reloading.
Placing
Jammer's
independent
launching.
variable.
Hear me.
Refueling my shields. We're already in the ring. Time for a break? Spaß.
Dead.
Competitor down. Ciao, ciao. Refueling my shields.
Enemy killed. Go
Come from
here.
here. Wait, we could climb up on them right here if you want.
Here.
I think there's a team behind us here.
We
too.
should avoid this area.
Subject spotted here.
Round 5. Beginning.
Let's pull up over here.
Wait, I'm backing up to you guys.
Zack, zack. Competitor down. Refueling my shield.
1 minute until the nearby ring closes.
Shitty on them. I might just
Look
push.
out.
Hello, I got going up there.
Charging shields.
Traps in and waiting. We're being attacked.
Back that out.
30 in the ring closes.
One of them, 1 HP.
Shooting at me.
Pretty sure our ass. I think we should just push this.
Recharging my shield.
Competitor down.
I still see everything.
The other one's. Oh, the one. Oh, on us, on us. Oh. Yo, can I get help?
Traded mine.
Come here, come here.
Wait, that means we're
Are we in here?
People depending on you.
Refueling my
Gas
shield.
trap deployed.
Why were they so spread out? Right here.
We're not in here. We're not in here.
damage.
Oh, so both squads shooting at us.
Recharging my shields. 1 sec.
The ring's close. 45 seconds. Death will have to.
No, let me res. Let me res. Let me res.
Not today, Capatid. You've got people depending on you.
I think this res, I'm gonna queue under them. Just lay under.
The ring moves.
That team's coming.
Spotted a subject.
There's a team on the left and a team up.
My strategy.
Yeah, we
Yeah,
can
they're
take
in the middle,
space.
they're in the middle.
We only have 10 seconds. Give full gas. One sec. Competitor down.
Don't push.
Repeat, I am down. Not today, Capatid. You've got people depending on you. Recharging my shield. One sec.
Yo, ult them. You should ult them and keep them in there. Unless you already used it.
Can't see that height team.
Delivering Arcstar.
Needed high.
Smash an opponent's shield.
Cracked them on high. One shot on high.
He ulted out. He ulted out.
High guy or
He's
what?
in storm.
Down a subject.
Enemy shield broken.
But yeah, they're dead. Last squad's dead.
High, high. Dropped. It's not a good angle. I'm gonna queue up soon. Nice. Shoot. I. Okay.
Y'all down a queue.
Time for a new rank.
Nah, my boy wants to play. But GG's.
Hey, GG's.
So now let's talk a bit about the limitations of HTTP and about another protocol that can kind of fill in the gaps of HTTP, which is WebSockets. But there's also a lot of application layer protocols. We're not going to be talking too much about all of these because I don't think it's super important, but you've almost certainly heard of some of these. FTP is file transfer protocol. By default, it runs on port 21. As the name implies, it's for transferring large files between computers. There's SMTP, which stands for secure mail transfer protocol. It runs on port 25, I believe, by default. These ports, by the way, aren't super important. I'm just kind of mentioning it because we know HTTP by default runs on port 80. The rest of these also have their own default ports. But SMTP is optimized for sending emails. SSH is to remotely connect to another machine and run a CLI on that machine. WebRTC is for video and audio streaming. The interesting thing is that all of these are actually built on TCP. Reliability is important for these protocols. WebRTC, though, since it's optimized for video and audio streaming, this is actually built on UDP. So TCP is definitely the more common transport layer protocol, but UDP also has its use cases. It's all about the trade-offs. And now we'll be moving on to the trade-offs of WebSockets and the differences with it between HTTP. So let's first look at the problem that we're trying to solve. Let's say that we are trying to build a chat application. So right now I'm on Twitch. We're just watching some random streamer, and here we have the chat. So you can see that users are typing, their messages. It doesn't really matter what they are. There's some text. Each user is able to send messages in the chat, and of course we are seeing messages in real time. As the messages come in, we are seeing them from all of these users. So how would we implement this? So from our browser, as the client, we can send requests and we get responses back. With HTTP, we can load twitch.tv, we can load the web page, we can load the list of streamers, we can get a lot of information. HTTP is satisfactory for pretty much everything we need to do. But when it comes to reading chat, how are we going to do it with HTTP? At time, let's say 12 p.m., we could send an HTTP request and get a list of all the chat messages at that time. Now maybe at 12:01 p.m., we could send another message and then get all the messages at that point in time that were sent, in between 12 and 12:01. We could keep sending HTTP requests like this to update us with all the newest chat messages. This is called polling. This can be implemented with HTTP. But the problem is, how do we time these intervals? Probably 1 minute is too long to wait. That means we have to wait 60 seconds before seeing the newest messages. Maybe we can poll every 1 second. That would probably be good enough.
Oh, nice. That's nice.
Back again, huh? You're so very welcome.
Hey, batteries.
No, hello?
Yo,
Yo,
I need
what's up?
batteries.
Do you want me to go with you?
No, you don't need to. I need batteries, then I
Okay.
gotta go get Mullen.
Okay, I'm gonna go farm Hornet drivers.
Fuck. Okay, alright.
Alright, text me when you're ready.
Okay, I should not bring this or this. I'll go to the, oh, I can, yep. No, you're good, bro. Deadass just need batteries. You got this, you got this. Oh. Fight this guy for the batteries. Somebody took the thing too, bro. Bro, I want to kill this guy so bad, but I don't know how blown I would be. I think I got like 6 batteries.
Always a pleasure.
Wait, is your name Shitass? Oh my god. That works so good. I usually find iron spiders in medicine.
Everyone's gonna be as nice as I am.
And this would probably work in most cases with HTTP, but it's less optimized. You can see this way, us as clients, we have to create a new connection, a new HTTP connection, which we know is built on top of TCP, which is somewhat expensive, and we have to create a new connection every time we want, the newest chat messages. A better way to solve this problem is with a better protocol. Better in terms of that protocol is designed to solve this problem. It's called WebSockets. What we first do is called the WebSocket handshake, which basically the client will actually send an HTTP request, and that request is to establish a WebSocket connection. So after that HTTP request, the server will usually respond with a status code of 101, which basically means it's taking this connection and upgrading it to a WebSocket connection. So that's the WebSocket handshake. Not super important to memorize, but the important thing is that after that handshake, there is a persistent connection established between the client and the server. So there is a connection. It's not like HTTP, where with HTTP we send a request, get a response back, send another request, get another response back. That's kind of how it is with HTTP. But with WebSockets, there's just a connection established, and we can send information in both directions. With HTTP, usually the client initiates some request, and then the server responds with what the client needs. With WebSockets, the client is the one initiating the connection, but once the connection is established, data can move in either direction. Like we could send from the client, like maybe as a user, I'm typing a message, that message goes to the server. Maybe I send another message and a third message. 3 messages were sent, the server didn't have to respond with anything, but then maybe I don't.
Let's go to Trapper's Glade. A harvester has been reported in the area. It has a queen guard in it. But if you've got the guts and the guns, there's plenty of good loot for the taking.
Just one mullet, bro.
down there.
Friendly. Trying to get some Mullen. Try loading with nothing. And make sure that I get at least some Mullen. Yeah, shred.
Type anything for a few minutes, and then the server starts responding. Every time there's a new message, like some other user on the other side of the world is typing in, some ABC message, and every time that happens, the server is going to push that information to the client. As the client, we don't have to poll, we don't have to keep checking, does it have a new message? We don't have to do that. Every time there's a new message, we immediately receive that from the server. The server pushes that information to us. And we could also, as users, send information to the server at the same time that that's happening. It's not a big deal. So this is bi-directional communication. This is something that HTTP doesn't really do out of the box. Well, at least not until HTTP version 2, which introduced streaming, which kind of makes WebSockets obsolete, actually. But to avoid confusing you, we won't go super in-depth into that because WebSockets are very prevalent to this day, and most people, I assume, don't even know that HTTP 2 actually makes WebSockets obsolete. So I think in a real interview, WebSockets are perfectly fine. I would just feel irresponsible if I didn't kind of mention this caveat. But now going back to our Twitch, HTTP doesn't really do out of the box. Well, at least not until HTTP version 2, which introduced streaming, which kind of makes WebSockets obsolete, actually. But to avoid confusing you, we won't go super in-depth into that because WebSockets are very prevalent to this day, and most people, I assume, don't even know that HTTP 2 actually makes WebSockets obsolete.
Let's go to Trapper's
This
Glade.
one here. Lots.
This is Apollo. Gate still standing, Raider. You'll find the unfinished structures scattered around the valley. Look for construction signs and cones. My previous crew came under heavy fire before they could finish up.
fucking hatch, bro. Get out of here. Should I get me through? What is there, Mullen? On half of it? Good enough.
There is no room here for petty squabbles.
These rewards suck dick. It's nowhere near. Surely their materials end. Materials worth 2k. Okay. Okay. 2k. This is only 3k. 6k. 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 8k.
Welcome back.
So I think in a real interview, WebSockets are perfectly fine. I would just feel irresponsible if I didn't kind of mention this caveat. But now going back to our Twitch example, and I'm going to go ahead and open up the network tab again and refresh so that we get our data here. So this is a bit hard to read, but what I'm going to do over here is in the filter window over here, I'm going to type in WS for WebSockets. And here you can see that we have a connection right here. This is the name. It's the chat or our Twitch streamer that we're watching here. This is the chat connection. And guess what? Which protocol is it using? Not HTTP. It's using WebSocket because this is kind of exactly the problem WebSockets is for real-time chat communication. So here you can see it responded with a status of 101. That is from the initial HTTP request that was made to twitch.tv with a GET request to establish that WebSocket connection. And it responded with a status of 101. It was switching protocols. It's upgrading this to be a WebSocket connection. And then after that's done, we can go to the messages tab here. And here you can see the actual interesting stuff. We can, scroll through here and get the messages in real time. Every time we get a new message, this is some metadata. I think it's which user did this message come from. But if we scroll all the way, eventually we get here. This is the message that somebody typed in. Let's just go to the most updated one real quick so that we can find it in the chat here. Somebody's saying, what is the number in the middle of Zarya's? I'm just going to copy that, make this window a little bit more readable. I'm going to control F and see, yep, this is the message that somebody just typed. We got it in our WebSocket connection. The benefit of this is we don't have to make a request to the server every few seconds, for example, to check was there a new message. Anytime there's a new message, we are immediately pushed that in real time. Every time we type a message here, other users are seeing that in real time. This is less expensive from a networking perspective. We don't have to create a new connection every single time. We just have to do that WebSocket handshake. We establish a connection. We can send data in both directions. So now if you're designing an application that needs some kind of real-time data streaming or bi-directional communication, aka a full duplex connection, that basically means we can send data both directions. WebSockets is what you would use. So this is really, really useful for creating any type of chatting or real-time data, like something like a live feed, like your Twitter feed, for example. That could be implemented with polling. Like if you check every few seconds, is there a new tweet? That would be perfectly fine to implement with polling. But for something like Twitch chat, we probably don't want to use polling. If we have hundreds of messages coming in a minute, we want to see those messages in real time. The order of those messages might also matter. So WebSockets is better for that. The downside is that there is a state established between the client and the server. Maybe this connection could actually break at some point and then the server would continue to send data. But in general, what we covered, the problems that WebSockets solve is what you should really be focusing on. The conceptual difference between the client initiating every request, receiving a single response for every request, whereas WebSockets, we can just keep communicating in both directions.
Hello. Yo, they have like shortcuts now. It's sick. You can like right click on something and it's pretty nice.
Yeah.
But I wish they made it so that if you click the keyboard shortcut, it doesn't ask for confirmation.
Yeah.
Alright, you want to do Light Stella?
Yep.
Okay. I'm bringing up Benny.
Good.
So now that we finally built up an understanding of how information is sent...
Hasn't been that long, has it?
I don't know, like a couple of days.
It's not that long.
Bro, it feels like pretty long.
True.
We used to play Hello.
Yeah. No, it hasn't been that long. We literally played Val like 2 days ago with Dan.
Oh, that's true.
Although no one was talking.
Oh, I remember that. Everyone's mic was cooked, bro.
I was like, what the fuck? They made a change. Night raids and close scrutiny only have
yeah, it's fucking lit.
Loadouts, yeah. The bot already aggroed above us.
Okay.
That's on us. I'm just gonna get inside.
It's a gigabot. I heard a shield above us as well.
Yeah, it normally is. Is this an Anvil 3? Oh, I picked up an Anvil 3 in our service.
Yo, how the fuck that shit spread?
Don't see anything up here. Although there's a firefly on us.
I'm gonna gonna jump up. There's a team on bridge. And they're shooting downwards.
They buffed the fucking fire? Shit is spreading hella far. Bridge.
Oh, bridge.
Cracked. It should be low. One. Oh.
Over there.
I died at the spot actually. Fuck.
That guy's so low. He's also gooped.
I'm one. He's gooped?
Okay,
I was getting shot with like an anvil.
He's gooped. Yeah, he has a kinetic bomb.
Okay, let's win the far range fight then.
I'm just gonna push this. You don't have to combo. Oh fuck, I'm not pushing shit, bro.
Bridge again. Crossing.
I see him.
Crossed. I'm gonna go TSA.
They're both there then.
Fuck, there's a comms team.
There's a comms team?
I think so.
They're both gooped and they're sitting in the thing.
I think it's comms, yeah, comms. You can look. I'm holding this comms team right now.
Oh, I'm getting fried.
Well, I'm looking. Wait, are you in? Okay.
From across. I think lobby, I'm not sure.
I don't see anything lobby. I killed one under.
Floor?
Come. This guy's moving,
Nice.
but I have to kill this shredder.
Yeah.
That hit me?
Yep.
I don't know where his teammate went. Oh, it's both.
Getting naded from above.
Dropped.
Oh, there's a fucking sticky.
Dropped. Yeah, you ran into me with it. I don't know. Shred heal. I don't see. I think you're good.
He's down.
Oh, wait. Res. I have healing.
He's one far side. He's in his voice, got him up. They're low. 1 HP.
Bye, buddy.
You guys are dirty fucking smelly niggers.
Nigger.
What? I'm streaming, by the way.
Dude, why is that guy yelling expletives, bro?
I'm streaming, by the way. Just showing right now. It's weird that these guys are all fucking. This guy's free.
Wait, guy right here.
Down there.
Okay. I can't see that guy.
I'm pushing this.
Pushing? Okay.
Yeah.
Getting shot from bridge. It's not great.
He died.
Okay, I'm going back to my spot.
He died from a different team. Going back.
Trying to loot. Exposed to dark. These guys are free too! I'm gonna run out of shoulder charges then.
I have 2.
I have 2. Oh, they fixed the barricades.
Yeah.
Nice.
Yeah, get off that thing, bitch.
No,
Go back
take
up.
dark.
We should go back up, yeah. I mean, Loki should not even be staying here. Oh, wait. Does your guy have heavy? I need heavy, actually.
No. They're both light.
Hey, I'm
I have 7 total bullets.
Dude, I only have the shotgun one.
What?
Across the bridge is low.
I see it.
Dead, one dead.
Should go now.
I don't know where his teammate is.
I'm
Far?
just going, bro. Close.
I don't
know where he is. Close. Almost cracked. I don't know. I'm gonna crawl back. If you have a defib, I have...
Oh, there's a team across too, this is so fucked.
It's fine. Or this guy healed. He defibbed.
Yeah, this is fucked.
Okay.
They're falling back. I'm gonna defib.
Oh, I see them. They're up pillar. He's just nading. Pushing.
Dead.
Nice.
I think we push. We have to push.
Okay. On you. Nice.
Got him.
Bridge. I cracked this guy, but... pushing. This guy's cracked. On the right. Oh, freeze! Oh. Go right!
Yeah, this is so fucked. Goddamn free kits.
We could have
mother load.
We could have reset there. We didn't have to push the second guy.
Yeah.
So I probably should just kept running down.
Wanna play with him?
Yeah, sure.
Yeah, what's good?
What's good?
Not much, just hopped on.
Nice. We're doing light loadouts right now. Like, Benny and Bill. Okay.
I'm down a little bit of warm up.
Still have util and everything, just lighter weapons.
Yep, I'll bring an anvil.
Sounds good.
Always welcome here.
I think your mic's a bit low, Darren, or loss.
I don't know how to fix that.
Is your mic close?
Yeah.
Okay.
You're still bringing medium shields, or are you guys bringing greens?
I bring medium. I have a lot of medium.
Oh, is this better?
Yeah, slightly.
Uh oh, fuck.
Maintenance is short-staffed. If you would like quicker, we are not coming.
Hello?
Are you still bringing snaps? I'm okay.
Legit, like, my kit is a normal goop kit, except for the weapon.
Okay.
Everything except for the weapon.
Especially at the application layer, whether we're using HTTP or WebSockets or a different protocol, we have a way of creating APIs. It stands for Application Programming Interface, and that's a very, very general term. These APIs just used very loosely. It's pretty loosely defined. It's really just any type of programming interface. So for example, in a web browser, there's this concept of local storage. It's basically a way of storing information in a browser persistently, but it's specific to a single machine. For example, when you go on youtube.com, you can toggle whether you want to use the light theme or the dark theme, and that information is usually stored in your browser in local storage. And to access local storage, there's an API. And in this context, API just means your interface that we use to access local storage. It's pretty simple. We basically read and write some local storage. But that technically is an API. If you create an object-oriented programming, for that object, you define some interface like the functions that are used or the methods that are used to access the data of your object. That is technically an API because it's a programming interface. Now, most commonly, API is used to indicate some kind of external service, like an HTTP API. And that's mainly what we mean when we talk about API in this course. When we're designing APIs, we're talking about API paradigms, how to build APIs, different ways of doing the same thing. That's what we're talking about, some type of API that's going to serve user requests. And I want to focus on 3 of the most common modern paradigms for this. By far, the most popular and the most important, I think, for you to know is REST APIs. More recently, GraphQL APIs were introduced. GraphQL was actually created by Facebook. I think at the very least, you should be aware of GraphQL, even though it's a lot less common and less important than REST, but it will solve some of the issues that can come up with REST APIs. And lastly, we're going to be talking about gRPC. And gRPC,
what's it called? Controversial opinion. I think they should just get rid of all matchmaking. Just make it
yeah.
random every game.
I agree with that.
If you don't want a PvP, just don't play Stella, and on the other maps, fucking figure it out. You want to go?
I guess.
You got.
I guess the good thing about that is that like, in high aggression lobbies, people usually have goop. I feel like the PvE players would not bring that much good goop.
Yeah. They want it. They 100% want it. But that's why they like. That's why they like PvE, because once they get into the PvE lobbies, it's like the only lobby where they will.
Yeah, there's a lobby team. Or sorry, metro team. They might zip up. I'm watching right now. They're coming the first floor. They're coming first floor. I'm not gonna fry. They're in first floor.
Think we can barricade stairs or let them come
Yeah,
up?
it's barricaded.
Oh, it's already barricaded. I'll keep watching Metro, but I'm here. There's also a team coming up. There's a team zipping up.
Okay, I'm gonna shoot the zip team.
Only one made it up.
Dead?
Yep.
Wait, one more.
Oh, one more did make it up. Ooh.
He's low, he's low. I might zip on this. I'm snapping on this.
Oh, never mind.
Oh, nice. Darn on him. Darn, you're also muted, I think. I'm not sure. I can't hear you. They're pushing stairs, maybe?
Someone might be breaching.
Getting fried. I killed his teammate though.
I think.
Yeah, I was muted, sorry.
Oh, I can hear you now. They defib. They defib. Second floor.
I can't help you guys right now.
His teammate is looting! What the fuck? I'm dating this guy.
I'm pretty sure they're free. Oh, yeah, they're probably free.
These teams are all free, by the way. You guys over here are both free.
TSA, 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 TSA.
Yeah.
I'm trying to climb in a second.
I'm breaching this door.
What?! You breaching?
That's me, that's me. Is TSA breaching?
Not yet, but they were.
Is that Dart trying to shoot us?
I think that guy climbed out of first floor, by the way.
Oh, that's TSA trying to shoot us.
Yeah, TSA's throwing a bunch of grenades.
Killed one first floor.
Nice.
Oh my lord. So many grenades.
I can look at your TSA and see one. You guys suck, TSA. Can't see that guy.
Wow.
One's behind this pillar.
Yeah, one's on desk.
Are these guys freeze?
One of them's got an anvil. He could have looted at TSA. Their utility was very free.
Shooting on them again. One's fleshed. We killed one.
I'm breaching the shit.
I'm trying to nade that. I think it's gonna be a good nade. It's a bad nade. We serious?
Third tries the charm. There we go.
Division?
Is it in if I
Did you
push
breach
this?
or?
I can't see anything back there.
I mean, I can hold you.
They fell back.
Over here. They got the res off?
Yeah, they got the res off. They got the res off.
Watch ass fucking.
See, I don't
Are they
know
getting
where
third in? They might be getting third in.
Okay, you guys look at that. I'm gonna.
Yeah, they're getting third in.
They're leaving Metro. Zipping up. Can you guys look? Come back.
Yeah, I'm
I
coming
killed
back.
one here. I
I'm
killed
coming
one
back.
here. One zipped up, cracked. Oh, one's up already. I killed one bottom floor. He's first floor dead. I think he's gonna try to fall.
He's flashed, that guy over here.
Okay, I can look. Yeah, he's dead.
Got him.
I'm gonna finish the minute.
There's another one on that pillar, though. There's another one on that pillar.
I'm snapping at him.
I see him.
How am I not hitting on this?
He's falling.
He's jumping.
Second floor. Got his
That dude. He literally fell down and you jumped right on him.
Yeah, bro. Wait for your kit, bro. You're getting that shot back.
There's another one, Metro. I scared him back though, don't you worry.
Was that free?
I got was free.
Fighting is chilled out TSA, so...
Second floor? Comms?
That was me.
That was Ethan.
Can be in dark, technically, right?
Yep. Doesn't seem like it. There's people in Atrium.
Still TSA, yeah. No, TSA, right?
I don't think TSA. I didn't hear any TSA. I hear comms.
Oh, maybe that's what I'm hearing.
Yeah, they're like right across this door.
When I say over here, you.
Yeah, I'm staying center, just It's probably that same.
He tries to come.
Oh, what the? Where did this guy come from? I'm good, but...
Yeah, there's a team TSA.
One's on top of the metal detector. Oh, he's fell back. There's a team under in comms on me.
There's still a guy Metro too.
As long as they don't
Power side.
Getting gas. They're dying something.
There.
Under me. My side, I think.
I'm getting closer to TSA.
I shot one of them. They know where they're
Yeah, I shot one, double doors.
I don't know why this guy keeps shouting the angle. Just fucking burning through his meds. They're dying. TSA. That's comms, actually.
I think it's comms. I think I heard comms. There's still TSA though.
Yeah, there are guys Metro Assembly side. They're like sitting in that corner behind the elevator.
Yeah, they're waiting in the
They're not.
I'm pretty sure. I don't think they have snaps.
They sound like free kids.
Your guys or what?
The people in comm, yeah. They're healing underneath me.
I actually wonder if those guys went down, so they may have. Because I'm not seeing nothing. That or they're real patient.
I might just throw this in comms, I feel like.
You mean third? Didn't they finish already?
No, they're fighting. They open the door. They're out.
I'm looking. I don't have. I might have hit him once. Just one.
One dead.
Just one. You can just fit him, bro. Oh, teammates here. Cracked. Shot. These guys have to be freeze. Just bad. Damn, did you stay up there?
Yeah, I'm still up here. I'm watching Metro. Do you need me to come?
Oh, dark. Cracked him. He doesn't have a good gun.
Oh,
It was shot.
yeah, this guy's got a Pharaoh, the guy that just shot me.
My molly.
They're running back dark.
They're in dark?
Yeah, one is. One's dark, they're one pillar right next to you, Nut. He just shot me with his Pharaoh. He just shot me again. He's missing.
I'm gonna smoke.
There.
I'm just looking.
Over there.
Oh, two on me.
I'm coming.
Two. Two are,
A raider. Here.
Fitting me if you can shoot this guy. Okay.
There.
I don't have an angle.
There for the freeze. There's one barricade and one left, right. Pharaoh. Pushing you.
Oh my god, how's that guy not dead?
They didn't freeze. They weren't freeze. This guy had a Berletto.
Yeah, I had a Berletto.
Okay, I'm down for goops now. Gooped. Goop kits.
That guy had a Stitcher 4.
Oh, I guess they weren't free. I want them out of Berletta too.
Alright, 1 sec, I gotta go get a sweatshirt.
Yep.
Come on through. Try not to lose it, will you? You look like you're thinking real hard.
What are you guys bringing?
Bobcat Anvil.
Ready. Stitch.
Okay.
I think. Oh, I have.
I'm gonna go Volcano Anvil.
It's all you.
They were using
Yeah,
HTTP
you
or
are
WebSockets
so
or
quiet, Darren, by the way.
Oh, I moved it away for that one. But I don't know.
No worries. I mean, I can hear you. Good enough.
different protocol, we have a way of creating APIs. It stands for Application Programming Interface, and that's a very, very general term. These APIs just used very loosely. It's pretty loosely defined. It's really just any type of programming interface. So for example, in a web browser, there's this concept of local storage. It's basically a way of storing information in a browser persistently, but it's specific to a single machine. For example, when you go on youtube.com, you can toggle whether you want to use the light theme or the dark theme, and that information is usually stored in your browser in local storage. And to access local storage, there's an API. And in this context, API just means, the interface that we use to access local storage. It's pretty simple. We basically read and write from local storage, but that, technically is an API. If you create an object in object-oriented programming, for that object, you define some interface like the functions that are used or the methods that are used to access the data of your object. That is technically an API because it's a programming interface. Now, most commonly, API is used to indicate some kind of external service, like an HTTP API. And that's mainly what we mean when we talk about API in this course. When we're designing APIs or talking about API paradigms, how to build APIs, different ways of doing the same thing, that's what we're talking about, some type of API that's going to serve user requests. And I want to focus on 3 of the most common modern paradigms for this. By far, the most popular and the most important, I think, for you to know is REST APIs. More recently, GraphQL APIs were introduced. GraphQL was actually created by Facebook. I think at the very least, you should be aware of GraphQL, even though it's a lot less common and less important than REST, but it does solve some of the issues that can come up with REST APIs. And lastly, we're going to be talking about gRPC. And gRPC APIs also have their trade-offs. That's really the important thing you should be focusing on. What are the pros and cons of each of these? You don't necessarily have to be an expert. You don't have to have developed a dozen APIs with each of these paradigms, but at the very least, I'd like you to be able to discuss 1 or 2 trade-offs for each of these. So what are REST APIs? Well, first of all, REST is an acronym. It stands for Representational State Transfer. It's not a protocol. REST APIs are built on top of HTTP typically, but that doesn't mean REST is actually a protocol that's built on top of HTTP. It's more a set of loose restrictions that we apply to HTTP APIs, and when these restrictions or guidelines are applied, we get what's called a REST API. Now, what are these restrictions, or you could also call them standardizations, because that's really what REST is about. It's about creating standardized APIs that everybody can recognize and be familiar with, that are easy to use, and have some other benefits like being able to scale them. I will say that REST is used very commonly. Nowadays, HTTP APIs are synonymous with REST. People don't even know what exactly REST means. A lot of people think REST is the same as HTTP. It's not the case, but you will see a lot of these terms that we talk about misused. It does somewhat make sense that this is synonymous with HTTP because, for the most part, there's a good chance you've exclusively interacted with REST APIs and nothing else. Now, the biggest thing about REST APIs is that they are stateless. It's called representational state transfer because
Assembly.
I'm gonna go up to height on here.
Okay.
See anyone?
Oh yeah.
Bro.
Right. Okay.
I don't see anything.
Okay.
Air medical or loading.
I'm gonna cross over to you guys then.
Oh, guys, right in front.
Like in those things?
Yeah.
I'm showstopper again?
Over there.
Right there.
Showstopper.
Oh no. I need you guys to freeze. Pushing you! I can't help you. I'm shooting you, I think. Crack the other guy.
I didn't bring stims.
I think he's dead. Or he's dead.
There's all 3?
Yeah, it's all 3.
Okay.
That's 3.
Oh, okay. Do it real quick. I think you guys are freeze. Yeah, they're free.
They're freeze.
Yeah.
Freeze.
I heard a shield loaded.
Oh,
Yeah.
yeah, down from lobby, or from loading.
I'm gonna watch your guys' flank.
Dead.
Like, I'm gonna push flank.
I'm dead. They're gonna push him.
Killed one.
Killed
I
one.
killed
Pushing you,
I
him.
killed one.
Sniping.
Oh,
2
my
on him.
lord.
I think he cracked one.
Yeah.
Raider, over here.
One's left side and one's in the middle.
There.
One's pushing.
A capsule
Right behind
delivery
him.
terminal.
I think it's
there.
hard.
Yeah.
Left to right. Where's right?
They're both there. Fuck.
I shouldn't have taken so much damage.
That trigger grenade kind of fucked us both.
Yeah. I tried to hide from it, but it just didn't.
Hiding my body.
control? I think I'm gonna bring a Tempest. Also, I fucking picked up blaze grenades, or light impact grenades on my guy.
Good to see you, champ.
I was tossing those instead of my blaze grenade.
Oh,
Actually,
not
fucked.
fire.
Not very fire.
Don't skimp on firepower. Solid choice if you want versatility.
What's going on here? When we send requests back and forth from the client and the server, we want to send everything that we need to know about that request and that response, because that's what REST is all about. We are making those GET requests, POST requests, all those kind of methods that we talked about with HTTP. Remember, REST is built on top of HTTP. It very closely aligns with HTTP. With responses, we are getting those status codes like 404 or maybe 201 something. But one of kind of the standards that we apply is that this has to be stateless. First of all, what's an example of actually having state? Well, suppose we have an endpoint like this, and this is a GET endpoint. We have the domain, youtube.com, and every REST endpoint is associated with something called a resource. A resource is a state. Well, suppose we have an endpoint like this, and this is a GET endpoint. We have the domain, youtube.com, and every REST endpoint is associated with something called a resource. A resource is a noun. It's a thing. In this case, we have videos. A video on YouTube is a resource. We could also here have had a user or listening for that video. We have a video ID. Let's just use ID for short here. And then for that video, we want another resource. Actually, we don't care about the video itself. This is actually how we would get a particular video, just a single video. We would get the ID of that video. And from this endpoint, let's say we get the video. Now for that video, maybe we want all of the comments. So we have another endpoint over here with comments. And this would actually give us an entire list of all of the comments. Now getting back to my point about state here, let's say we actually want to list a bunch of videos. We're on the YouTube homepage and we want to list by default, let's say this returns 10 videos. And then let's say we actually want 10 more videos. We scroll down or maybe we go to the next page. Remember when there wasn't a news feed and we actually had to go navigate page by page? Let's say we have to do that. There's two ways we could implement that with our client-server architecture here. The server could actually have some information for every single user. Maybe the server has some code. It's storing a session for every single user server side. This isn't a client-side session, but on the server, it's keeping track of every single user. The server knows that I just saw 10 videos. Now I'm asking for 10 more videos. So it's going to remember that and it's going to show me 10 new videos that's not a part of the original set. This is just a very high-level example. The point is that this is stateful. This is not stateless. We want REST APIs to be stateless. That's the whole point of REST APIs. Now another REST now keeping track of every single user. The server knows that I just saw 10 videos. Now I'm asking for 10 more videos. So it's going to remember that and it's going to show me 10 new videos that's not a part of the original set. This is just a very high-level example. The point is that this is stateful. This is not stateless. We want REST APIs to be stateless. That's the whole point of REST APIs. Now another way to make this...
Yeah, they like change the map when you're on the select destination place.
Oh,
yeah,
yeah.
they did. Looks nice.
It's like a lot darker, right? Or saturated.
Yeah, it's like disorienting for some reason.
Yeah.
Stateless. For the server to not have to know anything about every user, the server should not have to manage any state related to this. Technically, the server could access a database. Maybe there's a database over here. The server can access that, and there is some data written to the server about the user or something like...
Just go lobby.
Yeah, I'm done. Is it this way?
It's either.
Oh, it's that
That's
way.
the dark. Is it rise? I thought people saw here.
I'm not sure if oh, never mind. Okay, I'll breach. Looks clear.
I want to play range, drive temp.
Yeah, I want to switch which door is closed here.
Just close both, no?
Close them both? Okay. Yeah, that works too.
Lobby seems clearish. Is that
anything decent? You just calmed in voice, bro. Like,
on me, I'm right behind this wall. He has a Tempest. Two of them. One bridge.
I see one. I can fry bridge. Bridge might die.
I'm stuck
bridge
on
died.
this fucking desk.
Over there.
Should we cross? Should we cross?
I cracked the other guy.
I'm pushing.
What? I fell. Give me a second. Coming with you now.
I killed two.
Oh, okay.
I killed two. Right, I heard a defib.
I heard a defib, yeah. I got shot from across.
They're both in this corner. Oh my goodness. One's dead. They're getting attacked by a different team.
Can you crawl in? Crawl in.
Yeah, I'm trying to. Yeah, one's looking down. I think he's free. Yeah, they're free. They're all free.
I need help.
I'm with you. I cracked up.
I'm body blocking stairs if anyone comes down.
Put a blaze grenade up there.
Yeah, do it. They're free.
I think you might die to my thing, bro.
I got the defib.
I got it.
Okay.
Thank you, sir.
Running up. I killed him. Killed one. Pushing me.
First team either ran
Died for
or...
free. Grenading. Gas grenading him. Free. These guys are free. Just stay down here and play together. Someone put up a barricade?
I got the defib.
Someone put up a barricade? Oh, pushing you. Right here.
Over here.
Yo, pushing you.
Over here.
I'm safe for defib.
I'll ping. Pushing. Oh, two.
Nice.
No more. I don't see any more.
Where's my defib? What the fuck? Revive!
I hate when it does that. Alright. Ring around the defib, Rosie.
If you're gonna look for crawlers, you should go around to the zip. That's the only way they fall off.
I'm looking for third right now.
I don't see third. Look for dark side? Dark side maybe. I'm gonna look for crawlers up here.
Hey, let me tell you something. Please, let me tell you something.
I'm gonna barricade dark.
I think we're okay up here. I forgot barricades.
I heard snap maybe?
Snap, yeah.
I'm over here. If they cross on you, it's really good. For me, at least. I just don't have meds. Are you sure on snap? Do you see anything?
Oh, I think it's assembly. Okay. Assembly. There's bodies down here.
I'm loading.
And meds and shit.
So, one of these teams is free as fuck.
Yeah.
Okay, I got one of the...
Why are the guys...
I got one goop and
I can bring someone med.
I got one goop and one free. I'm gonna
Here.
I got goop.
next
I
to
got my
you,
goop.
Oh, you got it.
Yeah.
Okay.
There's a free unlooted. Someone switch with me? I have a Tempest. I have 2 Tempests.
Yeah, I need to give away this. I have 2 Tempests as well.
Okay.
I think
we just have a bunch of Tempests.
I got it. Those guys all 3 had Tempests, yeah.
Alright. That's... really weird, no? First spot? Under us?
Did anyone
Under us Metro. Pretty sure. Under us Metro.
I'm making a stash.
What? How do you have that much stuff?
I have my
Under us Metro. Under you guys Metro.
Wait.
They're looking. I don't know if he has a snap open or he's getting mullet.
I'm here.
I'm looking. I don't see anything.
I'm gonna go get space lobby and put up a...
Yeah, put up some barricades.
TSA going dark. TSA going dark right now.
Okay. I don't really know where to play.
They already crossed the dark.
Yeah, I saw that.
They're in dark right now.
I see it.
Okay, that door is barricaded, so they either have to jump or...
Look first floor. I'm gonna look for this.
Hold on, I'm switching attachments. Fuck the comp 3, bro.
They're gonna go zip.
They are? Nice.
Not anymore. Not anymore.
Nice.
They came from TSA, yeah?
Correct.
Yeah, TSA. Yeah.
I'm gonna breach TSA door and try to get eggs from this side.
So this team is green now.
Let me know if anybody crosses on me.
I'm watching Metro.
I'm watching dark.
Yeah, they saw me.
I fucked up their jolt. They seem like free kits. I'm not gonna lie.
Walking up a little bit.
I was trying to suppress.
I don't see anything.
I'm gonna cross.
Yeah, you got it. I'm holding this side.
There.
I can't. I don't have LOS on.
They might push me here. I'm healing.
Here, do I need to come?
I shit on one. Shit on two. You should. Or no, I shit on one. I shit on one. You should come though.
Okay, okay.
I'm coming over.
I got gas grenade. I'm gonna spam nades.
One is literal one shot, by the way. Oh, I'm one shot.
I'm going in.
Wait, you're in my trailblazer.
Shit.
Oh.
I have good eggs. I have good. Oh. Pushing. Nice.
Dead. I got killed too.
I'll dead, I think.
I ain't gonna lie, I thought I was safe from your trailblazers.
Could be in first floor. Could be in floor 4.
I might be an idiot.
I'm gonna push down and look for a thirst.
Looking. They're on your barricade, I think. No?
What? Which barricade?
I can't really see actually.
Over there.
Yeah, never mind.
I ain't gonna lie, that dude was a free kit with a kinetic converter on him.
TSA.
Okay. I'm running back. I'm running back dark.
I completely shit on one. I'm gonna walk up the right side. You said those guys are free kits, yeah?
Yeah.
One's double doors.
There.
At all. Fuck, they could be in lobby too. I really don't. Is that yours?
Yeah.
Just close the door.
Yeah, I don't know. They could be in lobby.
I'm gonna try to clear it right now.
One's across the metal detector on me.
I don't see anything here. He didn't shoot a single bullet. I have no idea what those guys have.
Neither do
I
I.
don't see anything
They could
lobby.
be.
That's mine.
I don't see anything lobby.
I'm gonna take space TSA.
Yeah, we need a heal, bro.
Oh yeah. Thank you,
I
sir.
think they're in the hallways. Oh no, they're across near spawn up here.
There.
Or is that a different team? Could be a different team. Like down there.
Over there.
Yeah.
Where? I see. Will you push?
I'm watching for thirds.
Nut, I think there's another guy. Oh my god.
I was getting
An
shot by
insider.
somebody else, by the way.
Oh.
Like, not a third. There's somebody on us.
Okay, coming.
I'm gonna.
There's one guy down this hall somewhere. I don't know where. Here or something. Who's in here?
Oh, I heard a shield somewhere near me.
I don't know. Is that you, TSA? Or?
No, that was me here. I think he ran. The shield sounded like down, like seatball or some shit.
Tell me these guys aren't free. Free.
Freeze?
Freeze.
Oh, it might be in our lobby.
Yeah, could be.
Yeah, in our lobby,
Agreed.
Ride one. What the fuck? He's on fire, he's on fire.
Taking desk. I'm gonna take desk. I see one pushing up. I fried him. I killed one. Far.
Oh,
across?
Showstopper.
Behind this. Look. He's stuck.
I have nades.
You should push that guy.
Dead one, I'm pushing.
Lobby.
I'm pushing.
You guys got it. I'm healing.
What happened to my snap? Fuck.
He's far, Zamboni. He's cracked. He's running. Did we both just jump past him? That's wild.
Wait, was that you shooting, Darwin?
I killed him. I killed the guy. You guys are chasing.
Do you have any shield recharge? I only have 5 surge.
I have 1.
I'll trade you some. I'll trade you a surge for a normal.
Oh, actually, no. I have actually. Here, okay. I'm dropping this shows on this guy.
I'm gonna go look for that. Yeah, TSA, I think.
Yeah, okay.
Yeah, TSA for sure. They think they know we're here. They went to the hallway.
Oh, this is
I can't play here.
Dude,
wait, across on my right, bro.
Oh my god, yeah.
Kill that guy.
I think we fall back if possible. Okay, never mind. TSA right now. Challenge.
Too dark. Come help me, dark. We should wipe this guy.
I'll hold this guy.
2v, one's cracked and then 2v3. One guy. I think that guy's the crack guy. In there. You should push him. You with all that. Deep right.
It's a full team on TSA, just heads up.
Come res.
Killed.
Nice. That team's wiped. It's just TSA next. They're looking. Come dark.
I'm coming. I can showstopper if they push.
Wait, I have AoE, if you want to come... Not pushing. Okay.
Oh, and there's a team jumping comms.
Oh, TSA.
There's
two teams here,
two teams.
Where are the teams?
One's below us, second floor. One's TSA.
I'm shading onto them.
Okay.
They just came out double door, one's desk.
I see desk. I might try desk. Can't hit that guy? Bullets? I'm running out of bullets, actually. Fuck me.
What do you need?
No, I'm gonna blaze. Give me a sec. I'm gonna blaze grenade desk. Can we kill the guy desk? Look desk.
Okay. I'm coming with you.
You ran into the thing.
Yeah, the other two are both double. Oh, he ran back double door.
I'm gonna kill one. I killed one. Kill two, I think.
Killed one.
Two dead. With you.
Three dead.
Comms. Look comms next. I think these guys are free. I saw one go like in the middle. I need medium guy, by the way.
I have medium.
I saw one jump like here.
Down there.
I don't know.
Really?
I might just loot.
Do you have any bandages? I need bandages.
Drop away. It's bandages.
I hear movement. Oh, I'm in this room.
These guys free?
Yeah, they're free.
What ammo do you need? Not.
I need medium. I'm just gonna come loot this guy's.
I have a lot of whites.
I dropped two stacks of medium right there.
Medium ammo. Here.
Where's the other team?
They were under us. I have no idea.
Okay.
They ran. I like destroyed one guy running here.
Okay.
Did you guys loot all three of those guys in TSA?
The A-trim guys are not looted at all.
Okay.
These guys, Kettle 4, not bad, I guess. Triggers, not bad. Well, not bad. Where are these guns? What is happening?
Here, someone look at this guy. I'm on. Darren, shit ton of medium and some heals. 4 shield rechargers.
Oh, thank God, I only have 1 shield recharger left.
I'm fat. Get rid of this Rattler. Rattler 4 if someone wants it. There's big dollars right there.
Sure. I'm encumbered now, by the way.
Yeah, I'm gonna leave.
Me too.
I just don't have enough space, yeah.
Let me go grab
door. Door,
Where?
where's that?
Comms, maybe?
Yeah.
I'm gonna drop second look right now.
I don't see anyone on door. No one on this right side.
There's no one in lobby.
There's a dead body right there, not.
Yeah, that's just the, somebody looted him. looted him while we were... I'm pretty sure the team under us looted this guy and then fucking...
Savage. Oh. Oh, you just swapped shields. I was like, what the fuck just happened? Thought that was Darren for a second. Shot or something. I am actually also gonna do that. That's a good idea.
There should be nobody in this lobby now, right?
I think so, yeah. I think it's clean.
Actually, no, there's probably one team. The fucking team that looted this guy.
Yeah.
What extract do we see over here? This is me.
Big door.
Wait, big door, big door.
This is me. This is me.
Oh, okay. I'm dropping. Yeah.
Okay.
Yeah, I want to loot batteries real quick.
Okay, I'm down. Is that you shielding?
Not me.
That was me, yeah.
Okay.
I'm gonna go across it.
Well, you should take this one. This one has more batteries.
Okay, you go across it. The healing just does not have enough fucking space, bro. This is so ass. I'm not gonna lie. Is that you guys?
I think so, yeah. Oh, it's just gonna rape me.
Could be interesting. Here.
Oh, it's actually gonna kill me.
Sensors.
What was it? The shredder?
Yeah, wait, don't come yet, don't come yet. I'm gonna close it.
Do you not have a stick?
I'm unbelievably over encumbered.
Oh, we can go to Seatbelt actually. Seatbelt is probably faster.
Thank you, sir.
Bro.
Okay.
What?
Oh, bro, it's trying to shoot you through the window.
Wait, there's somebody here? Or
No, it's trying to hit us through the window.
Time to kill it.
Yeah, I'm here.
If you guys want sensors, the breach thing.
I would take sensors.
It has 6. It has 6 in it. 6 sensors in the close left one.
I only need sensors. I'm doing batteries.
An arc orbiter is on
I'm going to go call.
Darren, you saw one of those other battery things I left.
10 minutes.
What do you mean you left?
On the far side of that room.
Like on the floor?
No, the thing you breached.
Like you dropped it on the floor after breaching it?
No, I just didn't breach it.
You can check it, I guess.
It's fine. You can just keep them.
Oh wait, I have
will take
space.
sensors.
No, I'm saying I didn't get them. I didn't even get them.
Did you guys finish looting?
Now,
No.
yeah, this one's looted.
There's batteries up here. Do you want them?
Up here.
Where?
This computer.
I'll take it.
Oh, hi Kurt, get in the I need fucking wires, bro. I forgot about that.
Trade. Also, the fried motherboards actually give you if you wait until topside, they give you what do they give you?
Yeah, electrical components, right?
Yeah, it's actually pretty good.
Oh, that's pretty nice.
Yeah, you get a fuck ton of them too.
Coming.
Seatbelt is open now, by the way.
Okay.
Sorry, one sec. I am now over encumbered too. If you want to hit the button, I'm heading that way.
I hit it. It's open.
Yeah, I'm heading there. Oh, it's open?
Yeah, it's open.
Oh.
Like a minute.
I'll make it.
Jeez. Service. Oh my fucking games. Oh, your batteries. Maybe keep this? It's a Tempest 1. So I can bring it.
Okay. Whenever we're ready.
There's 3 batteries in here. I'm not gonna lie, the Tempest feels better than the Bobcat. And Lobby.
I like the Tempest. You can also
Strictly
multi-kill
lobby.
with it.
Yeah, it's just the...
I'm typing.
Yeah. I just hate how the Bobcat is like worthless mid-range. It's not worthless, but like, you can't kill anyone mid-range.
Tempest is great because you don't have to rely on kinetics.
Yeah. I just like
Like
the bullet capacity.
Yeah, a padded Bobcat is great, but not just not the same as the kinetic Bobcat.
Shit, this is the craziest loadout ever. I think I need at least... It's not bad.
You've got coin, I've got weapons. Deal. You've got nothing better to do?
That this technically is rest. We are allowed to store persistent data in a database. Stateless does not mean we don't store anything. It just means that from the perspective of the server, there is no state being stored in the server itself. There's definitely going to be some state in the browser. In the browser, we definitely have some cookies. Almost always, we will have some session storage on the browser side. We're not going super in depth to kind of these concepts, but they are a way of managing state and information for a particular user. But this is all stored on the actual browser, on your actual machine. It's not stored on a server. Now, this information is sent to the server, but it's not stored there. So to solve this problem of fetching videos, we would use something that's very, very common in REST APIs and good APIs in general. It's called pagination. So instead of keeping track of how many videos we've already seen for every single user on the server, we actually send that information, we paginate that information in every individual request. The request itself should have all the information we need. Now, one way, if we're using a GET request, we don't necessarily have a body in the request, so we would send the pagination information in the URL typically itself. We could use a query parameter. A question mark here is a query parameter, so we're adding a parameter to this URL. Just like how earlier we had the ID, this is called a URL parameter. Just like with function parameters, we're passing in some value here. This is not going to be literally the string ID. It's going to be some, video ID. It could be XYZ, something crazy, but it identifies a video, and then that's how we get it. This is a URL parameter. We have something else called query parameter.
Is it?
Sure.
No.
I hate when that happens.
I don't see
Yeah,
anything yet.
TSA.
There are a million arc on you guys, by the way.
I know.
I'm not gonna show myself. You guys got it.
Oh, there are actually a million. What the fuck?
Yeah. 20 in TSA push. Gonna have to hold this up too, actually. Door closed, I see one.
Security gate. Over there.
They're good, they're good, they're good, they're good.
Yeah.
I'm gonna fry the desk guy. Alright, I got fried.
Ooh.
One on my right.
I'm gonna set up a...
It's a TSA desk and guy on my right. Can't see this desk guy.
Jesus.
Desk guy went right too, I think.
I'm gonna try and nade the guy to your right. Naded him?
Ooh, yeah, watch from dark. The guy dark.
Try again. He fell back.
They can't push. This fight is bad for us, no? We don't have enough meds.
Yeah.
Yeah, I agree. The guy dark is frying us.
I keyed down to go home.
What?
I am quite low on meds.
Can go take a metro fight. I'm sure there's somebody waiting metro though.
Yeah.
I got the elephant obelisk in the trash can.
Let's go. Let's fire.
I don't even know what that is.
I don't know.
It's one of the new like forgotten relics or whatever.
It's yeah, it's like the boat. It's the golden one.
Are we going metro?
I'm down.
They set up barricades on the.
These guys are just gonna wait till we get third party, or wait till we get pushed and then third party.
You wanna go? We should go now.
Yep.
Okay. Are we going, guys?
Yeah.
Ethan. Okay.
I'm ahead of you.
What are we doing? Are we hatching or are we hitting this?
I think just call it. And fight.
On the other side.
I'll take
Yeah, I
this
think.
one.
Comms. I think they slid down my side.
Yeah, they are. They're there.
Coming, coming.
No, you can stay. You can stay over there.
I just heard
Sure.
barricade.
Okay.
Just look if they.
Okay.
Sounds like they're up. But I don't know. They got it over here.
Do ya?
The train getting called.
We're setting up pulse mines for their party, I think.
No, he's playing the guitar. They're taunting us.
We can just go. You wanna go?
Guys, give me something.
Yeah, I'll smoke for you.
I think Ethan should call it.
Yeah, they're not pushing. They were and the recorder.
I think they thought we were baiting
Pushing.
Chilling.
Need more guns? Smart choice.
It's just another way of having a variable in a URL, just a different format. So in this case, query parameters have a question mark. We have two parameters. One is for limit. It tells us how many videos to fetch. Let's say limit is equal to 10. And then we could have another parameter. This is getting long, so I'm going to erase it, which is offset. And that's going to tell us where to actually start. So for our first request, we would say maybe the offset is 0. We want to start at the first video, and now we want 10 videos. Assume I also have that limit equals 10 here as well. Now, if we want the next 10 videos, we don't want the server to have to remember we already saw 10 videos. We want 10 more. So we send that in the request itself. Instead of the offset being 0, we say the offset is 10, and we also want 10 videos. So the offset is going to tell us skip the first 10 videos we already saw. Show me the next 10 videos. We're limiting this to 10. We could limit it to 100 if we really wanted to. But the point is we can send this stateful information in the request. It doesn't have to be persisted on the server. The main reason we do this, right? Why jump through all these hoops? Who cares? Well, the main reason we do this is what if you have more than one server? What if you actually have 3 servers here? When you, as a client, make a request, it could go through a load balancer, which we haven't talked a lot about yet, but this load balancer is going to route requests to one of the servers. Now, it could be possible that one of the servers does have the session information of a
Okay. Actually, wait, no, 1 second again, almost didn't.
Alright.
Refresh my shield.
user. For me, for example, I make a request to this server. This server knows how many videos I've already seen. Now I want 10 more videos. What if the
barricades. Keep forgetting I love the healing.
What extra spots do you get with the healing? Just meds?
Mm-hmm.
Yeah.
3 med slots, I think.
Which is useful, but not useful if we win everything.
Yeah.
Next time I make a request, it actually goes to one of these other servers. That
Oh,
I can
throw in like
it's stateless. None of the servers have any state. Now they could be talking to a single
Isn't there stray
servers
herbals?
may be inconsistent with each other. They may not all have the session information for me as a user, but the database usually does have everything. But we're not gonna get super in depth to that just yet. But when we
problem was the teams we were killing didn't have that many herbals last game, so not too bad, I guess. 16 slots? Yeah, I guess you lose 2 slots. You lose 2 slots total.
But it's a lot less weight, right?
It's a lot less weight. I think for Stella, the cloud is actually OP though. I don't know if they're up. Can't tell. Of course, we have the fucking God Arc on us. Snap? Oh, that's you.
Off me.
Yeah. I'm trying to shoot the back motor. Wait,
Yo, bottom floor already.
there's a team over here too. TSA, I fried one.
There's a team on 2nd floor already on us.
We're really separated. I'm gonna try to come to you guys now.
Yeah. Yeah, I think so.
I think I make it. Oh, I dropped all the way. That's smart.
Fire cracked one.
I can look over here. I have good
Okay,
angles
I
to
don't
take
think they're
photo.
pushing anytime soon.
No, they're not.
I can fry one.
Okay.
Alright,
Are they getting breached? Oh, they're breaching.
Sure on one. Dude, this fucking... Someone shoot the back motors?
One's cracked, one's fried.
He ran back first.
Anyone have vision on TSA? Where did TSA go? Oh, they just broke the, I think one's on my right. Not sure, no idea.
One's desk.
Do you hit how many
Missed
goes
both my
back?
shots.
I'm just really afraid these guys on the first floor are gonna zip up. Snap up.
No way. I can just hold for that. You guys can look the other way.
Okay.
He's back double door.
Okay. There's one desk as well.
Yeah.
They're first floor right now.
That guy's
Right,
gotta be weak. Yeah.
I don't see these guys first floor anymore. Oh, they're double first floor looking at me with anvils. Okay.
One of them has a turn to
Alright.
Here, barricade.
Yeah, they might be. Yeah, they're breaching.
Breaching what?
Second floor? Or third floor?
I think it's on me. Yeah.
Okay, I think so too.
I'm gonna go look
Yep.
at that then. Yeah, I see it, I see it. I shit on one.
Nice.
They're behind the... Did they breach? I'm gonna trigger nade that. I think you breached. Can you breach? Breach.
They breached.
It's already open. They just smoked. They just smoked.
They probably backed up.
They have a barricade.
The guy close had to...
Trailblazer. Another one. That hit me? Pushing.
Oh no. It's not good.
They're both so weak. They're both incredibly weak.
You killed one?
Yep. Last one's in the...
Yeah. That call.
Live ping. He's one shot. He's running back to TSA.
Here, first floor has a team.
Yeah, I know. Come back.
Oh, yeah. They're pushing.
Zip.
I'm dead in here.
I got you.
Res.
Sure.
This is flop right
me.
They're gonna ape us.
Oh.
This team's probably on us, by the way.
Probably, yeah. Go down.
Is it possible to breach or no?
Yeah, I can breach.
Wow.
Third floor.
I couldn't close the door.
This one.
Really hitting every shot.
Good lord.
He's pushed down
door.
buzzers.
Cool.
Okay. They're where we came from.
Yeah. This is really hard. Might be dead.
Out first pillar.
I'm dead. They're pushing you. Here.
There.
And they zip down on you. Left and right. Go left. Go left and you.
Over there.
Try liping.
Over there. There.
Liping.
A raider.
There's two pushing you.
Box.
It's impossible. Wait, it's not... Oh my god, it's a TSA team that's LOSing us from above.
Yep.
Bro. The TSA team is smart, I guess. They let the other team go down for free.
Yeah.
Yeah. And then we just die. Although, if they only have anvils, they can't kill the ones that are down there.
Do you guys want to play Dam or Buried?
Cool, die there.
Yeah, I'm cool with whatever.
Alright, bring up Bettina.
I was considering that, but I decided not to.
Doors
No such thing as too many guns. Don't waste it. Time's yours to waste.
We make it so that these servers do not need to store any state information. We allow ourselves to scale horizontally. We can add as many servers as we want with a RESTful API. With that type of architecture, we are allowed to horizontally scale this. That's the big benefit of REST APIs. Now that covers mainly what we need to know about REST APIs. The type on which list, none of the servers have work. But if we request, it actually goes to want 10 make a request to this server and others. If in the request, it doesn't have to be persisted on the server. The main reason we do this, right? Why jump through all these hoops? Who cares? Well, the main reason we do this is what if you have more than one server? What if you actually have 3 servers here? When you, as a client, make a request, it could go through a load balancer, which we haven't talked a lot about yet, but this load balancer is going to route requests to one of the servers. Now, it could be possible that one of the servers does have the session information of a user. For me, for example, I make a request to this server knows how many videos I've already seen. Now I want 10 more videos. What if the next time I make a request, it actually goes to one of these other servers? That wouldn't work. But if we change this to be a REST API where it's stateless, none of the servers have any state. Now they could be talking to a central database, which has all the data. These servers may be inconsistent with each other. They may not all have the session information for me as a user, but the database usually does have everything. But we're not gonna get super in-depth to that just yet. But when we make it so that these servers do not need to store any state information, we allow ourselves to scale horizontally. We can add as many servers as we want with a RESTful API. With that type of architecture, we are allowed to horizontally scale this. That's the big benefit of REST APIs. Now that covers mainly what we need to know about REST APIs. The rest we already kind of talked about when we talked about HTTP, like the status codes, like 400 for client error, 500 for server error. These codes are very important for REST APIs. That's kind of how we communicate whether a request is good or bad. Like I mentioned, REST APIs add the restriction of every request, every endpoint needs to be related to some resource, and we don't have verbs in these resource names. Like we don't have this and call it get videos, for example, or post a video, or create a video, or upload a video. We don't add verbs to HTTP endpoints because the HTTP method, like get or post or delete or any of those, is what we use for the verb. What action are we taking on this resource? We'll talk a bit more about this when we actually talk about designing good APIs and following some of the best practices. Now, by far the most common data format for REST APIs is JSON. JSON is a very popular data format. It stands for JavaScript Object Notation because it looks very similar to JavaScript objects, but it's not exactly the same. A little bit confusing in my opinion. But the benefit of JSON is that it's very, very human readable. So like this is a JSON object, for example. It's basically a bunch of key value pairs where every key is a string. So in this case, we have the first name of somebody and then their name is John. So this is the key, this is the value. It's very flexible because we can have these primitive data types like strings, booleans, integers, doubles if we wanted to. We can also nest objects as well. Like we have a key here address, but that's its own nested object, and that object has some key value pairs as well. We can also have arrays. Phone numbers here is not an object, it's actually a list of objects which correspond to a phone number. The home phone number, this is an office phone number, and we can also have null values. So big benefit here is that it's very, very readable, but performance-wise, we can actually do better, as we'll see when we talk about gRPC. Okay, now let's move on and talk at least a little bit about GraphQL and gRPC. GraphQL APIs are relatively new. I think back in 2015, they became public. They were created at Facebook, and there are really 2 main motivations behind GraphQL APIs. First of all, GraphQL is not a protocol. It's actually built on top of HTTP, but it only uses HTTP post requests because as we're going to talk about, we need to send data in a body, and we know that GET requests do not have bodies, so we need to send it in a HTTP post request. So all that talk about protocols was not useless because it does come up. These important points of which method use does come up. So GraphQL uses post request, and in the body of that request, we include a query which basically tells us exactly which resources we want from the server. Now, before we get too far into the solution, let's actually talk a bit about the problem. As we create a really big application, we are going to be accessing a lot of resources. If we do this with REST APIs, we will have some endpoints for videos and comments and users and a lot of stuff. So with all these resources and all these requests that we're sending from the client to the server, there's going to be a couple problems that arise. One is going to be overfetching. So when we make requests and we want some user information, for example, we want to list a bunch of comments, right? We have like 5 comments that we want to show, and for each of those comments, we want to have a little card like this where we have the profile picture of the person, we have their username, and then we have the actual comment that they made. This is the comment body. So for this comment here, we just want the user profile and the username. But a user will have a lot of information tied to them. An individual user will have a lot of information on YouTube, like how long has their account existed, what year was it made, maybe 2020, or a bunch of information that is related to a user, but we don't need it here. Right now, we just care about a certain user and what profile picture they have and what's their username. That's all we care about. We don't care about all.
Good spot. Oh, great spot. I'll take hallway.
No way. I'm gonna barricade the little jump in spot.
Sure.
if you're hallway, can you see the forest?
Can I what?
Can you see the forest?
Oh yeah, I can.
Okay.
This is the most right I can see though.
Raider, by the bunker.
That's hella far.
No, is it? It's on the mountain, bro.
Raider.
Oh. Okay.
Start shooting whenever.
Yeah, I'm gonna get closer.
They're kind of just looking. I'm pretty sure they saw me running on the roof.
Okay. Falling back. I want to be exposed to northwest.
I don't even know what they're doing. Oh, they're waiting. They're waiting the third party.
Let's see. Was that you shooting him?
Yeah, that was.
Okay.
Okay, I lost eyes on them.
Over there.
Never mind, I still see one. 3 men. They're walking up now. You guys should come.
Okay, coming.
Yeah, I'm coming to the front door.
Are they going to like the building? Oh, I see. Okay.
Raider.
Start shooting.
Okay, yeah.
Missing? Missing badly. Okay.
I don't have LOS.
Neither do I.
Fuck, I look, you need a... Lightweight stock on the Renegade socks!
Should we just snap up?
Yeah, I feel like we're hella exposed to other people down.
Down there. Raider. There.
Cracked 1. Cracked 2. Or almost cracked 2.
Oh my goodness, my guy didn't want to snap.
Down there.
Alright, they went left, like here.
Okay.
There by that building.
I see one.
I'm smoking. It's a bad smoke. I'm gonna get shot by.
Cracked one.
I'm one, you. I mean, if we're up here, we can't even,
Throwing nades, maybe? I don't know.
Can't actually fight this.
Did I hear a door?
Could be under us, yeah.
I might have heard a door.
It's not very good. I also don't have the meds to keep telling us, I don't think. I should have waited to shoot.
Oh, he's peeking on us.
You guys look at this, I'm gonna hold behind
Down
us.
there.
Okay.
Oh, that's on us.
Oh my god.
One's coming in.
Like where?
One made it to lobby.
Two are on that.
What if you drop and then, what if you double drop on this guy and you're just fucking... Is the guy in lobby hurt?
Yeah.
He is?
Both 2 in lobby now. 2 in lobby and one of them is giga hurt.
I look-y...
And the other one is just cracked.
Oh. Okay, well... There's one guy stuck, yeah? He didn't make it in?
Yeah.
I don't know if he's still there or not. I don't see him peeking at all or nothing.
He might have made it.
He was on that thing.
Down there.
There's a flamethrower.
Yo, uh-oh! Never mind. That was the art falling. Still alive?
I'm not sure.
I don't think he's stuck anymore.
Yeah, I agree with that.
Okay, they can go up your middle and they can go up the left side. I'm talking about.
they're inside the door.
I mean, but they don't really have any good push on us, right?
Unless they have snaps.
Yeah, but even if they snap.
Yeah, even if snap, it's...
If they wouldn't snap, yeah. Nobody else here in trios. I think this is the first time I played trios in news. Are they doing the pro?
Yeah.
No, we are.
Oh, you guys are.
Ethan is.
If you die, I'm fucking.
Hello, Arc did just spawn in right there.
Down there.
Oh, are they fighting inside? Maybe Arc.
We're fake fighting. It doesn't sound like.
I think the arc... Wait. They're lobby then.
Oh yeah, they're under us. They're under us where this thing's shooting.
I think I'm gonna drop to second floor and suss it out.
Okay.
They gotta be down there.
Yeah. They're first floor.
All these Arc are shooting
I can drop
down.
the first one. Oh, I fell.
Careful. Careful.
Should I snap back up, or what are we trying to do?
I think you can stop back up. Heal up.
I think so. At least heal up, yeah.
I'm just taking space on second floor.
Anybody have a shitter bandage? I'm actually out of
I
bandages.
do not.
Oh my goodness.
Kick a height.
Yeah, he's jumping down. He fell.
Died. Two died.
Can you drop down?
No. Two died. Come on.
Oh, I'm coming.
That was hilarious.
Holy fuck, guys.
Uh-oh.
I think those were Bobcats too.
I heard another snap, by the way.
That was me.
I don't know where they... What? Did you find them, man?
No.
There's two dead bodies there. Found one. Lucky.
I got the other.
Okay, perfect. I'll watch for thirds. These were... Where did they come from? Like, turret?
All the way up, yeah.
And then they jumped down?
Yeah.
What the fuck?
I think they fell down as the...
Do you think this was the lobby team?
I have no idea.
Awesome. Still alive?
You guys have meds?
I looted shield retarders. I'm low on whites.
Do you have any extra whites?
2 only here. Do you need
No,
herbals?
that's fine. No. I got more than that. It's fine.
Yeah, that guy didn't have. He just had shield rechargers.
Yeah. I guess it was the team that we were fighting then. Otherwise, why would they be low in meds?
That's true. Okay, in that case, I think I'm gonna go elevator and go suss it out.
Raider flare. There.
Okay. I dropped 2 then. I dropped the first and suss it out.
I think he left already.
I hear a shield load. Or is that one of you guys?
It's not me. It's not me.
I heard a shield.
From where?
I don't know. South? West? Oh, on. Oh, fuck. I might die. Dead here. I killed one. I killed one.
Okay, yeah.
Other guy's low. Other guy's low. Other guy. Jump up. Jump up. You should push. You should push.
I'm coming to you.
I'm barriered. I'm barriered. I'm dismantling.
I redowned. Oh no. Two. They're gonna re-deef him. They're gonna re-deef. You shit on them. You shit on them. I see them. You shit down them, I think.
Yeah.
I'll go to him for res. One dropped. Dude, these guys need to fucking on that. I'll drop it on that. You guys were broke. Oh, a bunch of white ones, though.
Yeah, I got whites.
Do you have an extra close range we're not using?
You want a Kanto 3?
Oh, I love the Kanto 3. Do you want a Renegade?
Yeah, I'll take it.
Right.
Oh, Jesus Christ, that was you not. That scared the shit out of me.
I'm gonna stay low ground if you guys are up there.
Yeah, sure.
Oh, you can do something off of damage. Oh, that was probably the late team that spawned in, actually. 17 minutes. I hear it shooting. You hear that?
Yeah, that's us. Killing the snitch.
Down there.
So many wasps. I need a hornet.
I need a probe. I don't know if you guys see a probe falling.
There's a probe way over there.
Oh wait, that's actually... There's also
Wait,
fighting a
should we not go to
hydroponic.
that? Yeah,
Not too far.
I'm gonna go to that.
Oh, brother. I hit this thing.
NT. I aimed for it and I missed it, but...
I'm so bad at doing like the snap hook, like slow descent drop down thing. I need to do it more.
I don't see anything here.
It's probably domes, right? Almost got
It's
it.
us.
It was
Yeah,
probably them shooting arc. Completely cut Nice.
Just leave.
I'm down.
Because it seems a little dead. Side extract open? Yeah, it is.
No, it's a sideways probe. I'm not gonna lie, the standing probes are OP as fuck.
Yeah, I agree. I got like 5 arc circuitry every time. Yeah, I'm gonna trade back. Thank you.
No problem.
I'm gonna call in snap to height. I'll watch like west. I'll watch. Oh, they still. Damn, they're like shooting arc.
Are they really?
I think they're farming arc parts. You're shooting like arc that's far away.
Oh, you know what it is? That fucking new trial thing is.
Oh.
The start of it is to kill Ark in the swamp.
One of the guys that shot me second, downed me, was a did Seekers.
Oh yeah.
He was a what?
Was a Hornet.
I'm gonna get this Hornet driver actually.
He had Seeker grenades.
Oh yeah.
I think you can start typing.
Typing.
Yep.
Typing. Dude, yeah, lightweight renegade just did not hit. She was so ass.
Did you have a comp on it?
Did not. Maybe that's what it
That's
was.
probably why. I think you need, if you have lightweight stock, then you have to have a comp.
Gotta put a comp on it.
I think meta is stable 3 with silencer or lightweight with comp.
I like the silencer, honestly. I don't like the way the renegade sounds.
Yeah, I agree. But it sounds sick with the comp on it. It's like very metallic.
Yeah.
Very industrial. Alright, GG guys. I'll probably be on later tonight if you guys are playing, but...
Yeah.
Will probably...
I'm probably gonna hop for the night. But yeah, GG's.
Yeah.
GG's.
Yeah, there's some good raids.
Yep. I should probably not. I could do this though. I should show that.
What is it? Take good care of that.
There's no way I'm gonna do this, right? Such a feels bad though. Fuck. Eighteen, 1940. $66K. This game is so expensive to play.
The other things that are included.
Fine. Lab versus XLG. I'm pretty sure Lab just shit on them now. That's been what has happened.
私に向かって攻撃するとはいい度胸だな。ルベン。
私の名はロッサだ。ルベンではない。それに貴様のような凶暴なものなど知らん。
知らぬか。ならば容赦はせん。
Oh shit.
サガンダホ50編成金国。そのまま生き絶えるがいい。
終わり。
めで。
まさか。
せめて私のこの炎で殺してやろう。
なんだこの感覚は。体がこのものを知って恐れ。もう
二度と仲間をやらせやしねえ。
じゃあな、遅くの姉ちゃん。
私は人間を殺すんだろう。私
On the way in, happy way up short. Got to find something here.
Yeah, a little surprised that Neon's been pretty much irrelevant to this. A couple of opportunities, a big couple of misses. Rose, however, dives in and out of the smoke boy down to 2v2. Spike knocked down.
Oh, yo, you cannot have him heating up. I promise you, you cannot have him heating up.
We're waiting to this extent.
Games that roast you for standing still. In the Madagascar game, leave.
City away cross. City on man. City, Molly City. Give me bomb. City on man. Come hold. Okay, I'm coming with you.
Let's go. I can go.
I'm picking City with you.
I'll just plant here, guys.
Get outside. Yeah. No, okay, it shouldn't be safe. I'll clear it anyway, Blade, but... No one side. Nothing. Shut the fuck up, you fucking baldy.
By the way, it's planted for you.
Oh! Alright. That's what it takes, apparently. That's what it takes, apparently.
These guys, when they're comm videos and they're like comfy and they know they're being recorded,
Completely wrong direction.
it's just so dumb what I hear.
Folks, it is no secret that duping in Arc Raiders right now is a humongous problem, alongside obviously just cheating across the board. It's a massive problem. It's pushed already so many people away. Tfue, Ninja, which is very unfortunate to see, to be honest. No matter what, cheating is always going to be in games, but there are without a doubt games that are far superior when it comes to cheating than others. I'd say Valorant, I would say League of Legends, I'd say Riot altogether. Their Vanguard anti-cheat is incredible. But anyway, I digress. In today's update, Embark announced as part of their ongoing efforts against fair play that they're continuing to expand the de novo anti-cheat to more players. Now, I don't even know what that means. I guess they gave the anti-cheat to some players off rip and didn't to other. Now, something that has been severely hurting the game lately is the duplication endgame loop, which with the aggressive amount of
This is the wildest watch party conversation you'll ever see, where Yinsu crossed every boundary to troll and humiliate FNS. And if you think calling him tech support was bad, just watch, because that was somehow the least savage thing she said all stream.
Wait, so why is this pause so long? Anyone know?
I mean, your tech support, you should know.
That's just racist! My sub count just went down. I don't even know how that's possible.
There is no way your virgin ass chat doesn't love boots. It's maybe because they've
Whoa! We can just use that word now? No, you don't even understand. My mods all each other. No, it's just weird because they don't do their jobs.
Selena. I'm telling your girlfriend.
That's fine. She knows. She witnesses it.
Oh wait, what do you mean?
No, not in real life. Oh my god, Mr. Fallen is gonna shove his fist up Moster's ass tonight. I
Yeah,
promise
and
you.
he's gonna love it. I hope his fist feels better than mine. Have you never been fisted? I swear you played against Billy Billy twice.
This is the
What's going on over here, huh? What are you doing?
I don't know, bro. Somebody's ratting down here.
Nah, if you're trying to leave, you can leave. I'm over here killing rats. Like this one over here.
Well, I'm definitely not a rat, and I've got a free kid, so...
Oh, you can leave.
Hit me, you can. I'm not losing nothing.
Nah, I'm not killing you. I'm not killing you. I'm killing rats. Like this bum right here.
Right on. Well, good luck, bro. Thank you.
GG's, brother. Yo, what kind of timing are you on? You a rat?
Hello there.
Let's see if the other guy pushes.
Good dog shit. No,
You said I'm what? You said I'm what?
You heard me.
Yeah, and you're a rat, bum.
You're dog shit. Fuck, nigga.
Someone's gotta do it, chat. I'm the right man for the job. Little stinks. Yo, the only issue with this, I'm probably not getting any loot. That's okay. Killing a rat is like finding a Bobcat 4, you know what I mean?
Enemy imposter.
My first word is fire.
You know, that one's actually not even that bad.
Fire.
I actually kind of like that one.
Interesting reaction.
Y'all like that one?
I do. John's reaction's a little interesting for me, but...
You know what? I'm gonna counter his fire, and I'm gonna say snow.
Wow. Don't mind that. Don't mind that at all, actually.
Interesting reaction from Lewis.
They just follow the wave because I'm the GOAT. For my first word, I'm gonna say battle. Wait, no, but I'm talking about specific battle. I realize now. Can I say another word or just no?
There's a lot of battles in anime.
This is true.
I need to fact check myself right now. For my next word, I'm gonna say fist.
What do you think?
I think I want like a clarification as to what exactly you're talking about, but it makes sense to me.
I don't think that's a bad word at all. For my next word, I'm gonna say head.
I like that. Do you want to like specify what part?
I'm explaining at the end.
Okay. That's smart. I like that approach. For my second word, that helps with my first word a little bit. I'm gonna say ones.
Ones?
Like run the ones.
Run the ones. Interesting.
My last word is stance.
Okay.
I like that.
That's a good one.
I like that.
I think I'm pretty clear on my first two words, so I'm gonna try to go niche. I'm just gonna say mark.
Fuck. Well, my last word then kind of sucks. I was gonna say pot.
You say what?
Pot.
Pot?
Pot.
Like a pot?
Like a pot of water, perhaps.
What do you mean by pot?
A hot pot of water.
A hot?
Some might say boiling.
I don't think I get it.
Wait, are you serious right now? You don't get it?
No.
Do you not get it?
I get it!
I get it.
You know, I think I know what it is. You talking about Todoroki?
No.
Oh yeah?
Guys, I'm being fucking griefed. Like this is disgusting. What's happening here is disgusting. It's just a loss. It's just a loss. Like it's a complete loss. Like
What do you mean by battle?
I think it's probably like the most iconic battle of season 1.
Oh, okay. I mean, it was a pretty big battle in season 1.
I'm so sorry, Lewis. I could give you a hint.
No, fuck you. Just vote me.
3, 2, 1.
Yeah.
You said fire. Like, what does that even mean, bro? I don't know, bro. Like Toto?
It's Akaza. I know your heart dropped when I said Todoroki.
I don't want to play this game anymore.
Enemy imposter.
My
No era amor, eso fue lo que dijiste tú. No era amor, no era amor, pero a mí sí me partió en dos. No era amor.
The key is right there. You ready? We're gonna grab this on 3, and we're gonna break for it, okay? She's behind me. She's behind me. Weave. Don't look back, y'all. Don't look back, y'all. Don't look back, y'all. Look back. Yo, sis!
Oh shit!
Hey,
Hey, yo, my man, can I borrow $5? We low on gas, and I forgot my wallet at home.
Yeah, it's 40. It's all I got, so fill her up.
Oh, man, thanks. Hey, yo. Can I borrow that phone?
Come on, man. Phone's my life. My entire business depends on it, so no, you can't borrow my phone.
It's gonna be the phone, or it's gonna be something else?
You're fucking with me, right? Like, this is Kassan's trying to put my feet to the fire or something?
Told you, don't know no Kassan.
Look, it's $500. No phone. It's final offer.
Have a nice day, bitch.
Yo, best agent in Miami. What's up, boy?
I want my money back.
What the fuck are you talking about?
You know, with your shitty gangbanger image, you make someone wait in the park for an hour and then send your homeboys out there to rob them.
Well, you got robbed?
Don't play dumb.
Hey, watch him out. What the guy look like?
And he was in a green Cutlass, Kassan.
Let's take a ride, all right? That's the car, right? Come on. There you go.
Oh, KT!
What it do, homie? All good, baby. All right. Hey, Carl, I got a friend I want you to meet, though.
Oh,
Yo,
yeah?
Jason, get your ass over here, nigga.
Oh, who this? Your accountant?
Y'all two met each other already. Somewhere. Where was it?
Oh, yeah, Palm Beach.
Palm Beach. That's right. Get a man back his role.
I know it's with you, KT.
That's bullshit.
Oh, man. That's cool.
This is short $40. The gas money.
Dude, that was a gift.
Get a man back the fucking cheese, or me and the boys gonna go Giancarlo Stanton on your Cutlass.
Like that, man?
Like that. And this time you're gonna hand it to him like a man. Can you do that?
All right, brother.
There you go.
Man.
Oh, wow. No.
Don't worry about it.
No, he had Butterfingers. That wasn't on me.
Don't worry about it. You got it?
He got his money.
Hey, don't worry about it, my man. All right.
Right? All right.
Nice drive back to Palm Beach, bitch.
Oh, I'm a bitch. You my man, Leonard? I'm a bitch. Oh, man, what the fuck, man? Hey, yo, my man, can I borrow $5? We low on gas, and I forgot my wallet at home.
Yeah,
Oh, people, me. They're ziplining.
Come down.
He's group walking. We found one.
Coming.
Come to me. On me. Get him. Knock that guy out. Knock him out. No, the other guy you just slid past. Get him.
Yeah, I'm trying to get him. Oh, he took himself out. Ah, nothing. Oh, wait. Ooh. Yeah,
Let's go, baby. Let's go.
Let me goop.
Come on. It's like bugging out. Hold on. Holy shit. Let's go, baby. Oh, people, me. They're ziplining.
I caught you staring at my ass when I gave you the car.
I see nicer asses on the regular.
Oh, let go of me!
Sorry about that. I didn't mean for that to happen.
You have no idea who I am, do you?
You are Astrid Hesserer.
What's your name?
John Nolan.
Badge number?
25253. If you want to lodge a complaint, that is your right.
You arrested a woman today, Astrid Hesserer. She's the baby mom of the leader of Southern Front. According to intelligence, you've been greenlit by Southern Front.
Greenlit? Means they put a hit on you.
Nolan, cover!
Look who's awake. I did not intend to disrespect Astrid, okay? Or you, okay? And I would be happy to apologize.
Too late for that now. The only way this ends is with you dead.
Oh, he's dumber than I thought. What's my rank? The 2 bars? Oh, for crying out loud. And a badge that says captain?
No.
You are surrounded by the LAPD. Step out of the vehicle with your hands in the air.
Okay! Hands on your head. Interlace your fingers. Eyes front, don't move.
We both know I won't live to stand trial.
Yes, you will. Because the woman you killed taught us it's not our job to punish you. Just to see to it that you are.
No, I'm playing. I'm on a Tempest 4, but I want to team up. I've been killed by duos and solos the last 4 games in a row. Bro. That's has to literally. There's no way that isn't stream snipers, bro. There's no way. There's literally no way. Like, I just got shot at by 4 snipers, bro. Who is it, bro? Who is it? Who is it, bro? Who is it? I need to know. Who is it? I don't know who you are. Are you stream sniping?
Wait, I know.
J Beam. J Beam. Yeah, Killdoy. What's up, J Beam?
Teammates,
I don't have any teammates. I mean, what the fuck, bro? Like, oh, thank you, bro. That J Beam? Who's this?
Yeah, it says.
Oh, I appreciate you, bro. Am I in fucking duos right now? I gotta be in squad fills, bro. I swear to you. I swear I gotta be in squad fills. I have to be. I'm in squad fills. Is this squad fills? This has to be squad fills. I can't lie. This has to be squad fills. There's no way this isn't squad fills. Oh my god, I was in squad. Nah, I'm playing. I'm on a Tempest 4, but I want to team up. I've been killed by duos and solos the last.
Oh shit! A rat!
Yo, can we talk? Can we talk? Yo.
Go loco.
Catch me, bro. It's slow. Come on.
It looks like you got some money. Let me get some.
I ain't gonna give you a dime, but you can earn it.
How? That's why you should have a car.
You don't enjoy the walk?
No.
Well, here we are. Well, little man, my name is Oscar, and you are?
Andre.
Andre, okay. Well, Andre, here you go.
A dusty $5, and you live in a house like this?
Well, it wasn't like this when my wife and I first bought it.
Chance, I?
Well, no, she has a different house now. Well, I got some grass cut if you want to make some more money.
Nah, I'm good.
All right, well, you be careful. Andre, what are you doing here?
I just need a place to hang.
Come on inside. So you want to tell me what happened?
It was a kid at school.
What was his name?
I can't remember. Do you have anything to drink?
Now, you want to tell me what really happened? Was it your mom? Your dad?
This is the wildest watch party conversation you'll ever see, where Yinsu crossed every boundary to troll.
Included with a user resource. So with a REST API, if we have 5 comments, for each of those comments, we want to get user information for the creator of that comment. We're going to end up fetching a lot of data that's not necessary. If only there was a better way for us to somehow specify that we only want the profile picture or we only want the username for that person. We don't want all the extra information. I guess what we could technically do with a REST API is add custom logic on our server to only get the exact fields that we want. But with this, we're gonna have to be making a lot of server-side changes every time we come across a similar problem like this with overfetching. With GraphQL, we can do exactly that, though. For every single resource, we can specify exactly which fields of that resource we want, and then only those fields are going to be returned to the client. So what happens is the client gets only the data that it actually needs, exactly what it needs. So with this, we basically save some performance costs. We can send less data over the network, and then our application will be faster. We won't be fetching unnecessary data. So this is the main problem that we can solve with GraphQL, and GraphQL APIs are very, very flexible. Another problem, though, is underfetching, or having to make multiple requests for a comment section. Like we have 5 comments, and for each of those comments, we want the user information and we want the actual comment information itself. We want the body of that comment, and we have a bunch of these. Now, let's say we list a bunch of comments, right? First, we have to get the video, and then we have to list all the comments for that video. And then with each of those comments, we have to get the user profile picture and the username. So we have to make a bunch of consecutive requests. Wouldn't it be easier if we could group all of these in a single request and get all of the information that we need in a single request? Well, that's another problem that GraphQL solves for us. We actually have just a single endpoint with GraphQL, but there are 2 operations that we can do for GraphQL endpoints. One operation is query, aka doing reading, any type of read operation where we don't modify any data on the server. The other operation is a mutation. This is basically anytime we need to mutate data or update data on the server, whether it's a delete or an update or a post, like we're actually just creating a resource on the server, that would all fall under mutation. So in our case, when we want to get the videos, get the comments, and get the user information for each of those comments, we could do that in a single query. So I think these are really the only high-level points that you should keep in mind when it comes to GraphQL, unless of course you want to dive in further and actually develop some GraphQL APIs yourself. One last thing I'll mention before we get into a quick demo is that for GraphQL endpoints, they are built on HTTP post. Post requests are not idempotent with HTTP, so the downside is that we can't cache GraphQL requests as well as we can, or as precisely as we can with HTTP or with REST APIs. But now let's take a look at a quick demo. GraphQL comes with pretty good tooling. This is actually GraphQL Explorer, and this is the SpaceX GraphQL API. This is just an example that I found. With GraphQL APIs, this is how a request is. Even though it's built on top of HTTP, we don't really see that portion. We don't see the HTTP aspect. We just see the query and the response. So here you can see we have a bunch of resources that we can query from SpaceX. We can get the launches pass and limit that to 10. So you can see we do have some type of pagination capability with GraphQL. And so as we kind of check these, I'm going to uncheck a few of them. Rocket here, I'm going to uncheck that, and that kind of took away the entire rocket. We can bring it back, and then for an individual rocket, we can get even more precise. You can see here, we're asking for a rocket. This query here is basically telling the GraphQL endpoint which resources do we want. We want the past 10 launches, we're limiting that. And then for each launch, we have some fields like the mission name, and we have the launch site, and a launch site could have some other information. For rocket here, I'm just going to uncheck everything except first stage. So here, I'm just going to go ahead and uncheck everything. For rocket, all we have is first stage, but here we get an error. We need to specify some subfields. So we can click on cores, and then we get some more fields here. Maybe we don't care about the reuse count, so we just keep status, and we don't care about the flight either. So we can pick exactly what we want. Maybe we don't need the extra data like missions. Maybe we do need the missions, and we need the extra information like flight number. And in addition to all of this, we also need the ships. We can get exactly what we want. We don't need to build, multiple REST API endpoints for each of these things. We just have a single endpoint here where we can query exactly what we need. There's also mutation endpoints. They are structured the same way.
Enemy sighted. Far.
In our building. Cracked one.
Setting a fence. Enemy here.
Attention.
Come block the door.
Beginning ring countdown.
This guy is literally brain dead.
Me, your squad, your mother. It's still you who lost.
In terms of the query, but they would actually be updating data on the server. We're keeping things at a pretty high level, so we're not getting super in-depth into the syntax of this, but you can kind of tell that this syntax is pretty similar to JSON in the way that it's nested and that it's pretty flexible and open-ended. But unlike REST APIs, GraphQL actually does have a schema. Like here, this is the schema of the endpoint. We have launch pads available to us, but we can't just specify some arbitrary thing. We can't here ask for like a Tesla. This is SpaceX, so there's no Tesla field here, and we can't just manually add that. We have a schema that we have to follow. We can only choose what's available here. That's a difference from REST APIs, which operate typically on JSON, which is very flexible. We can pass anything into the body and get anything in the response. Now, gRPC is another way of creating APIs. It's also built on HTTP, but it's actually built on top of HTTP 2. We sort of talked about how there's multiple versions of HTTP. We started out at 1.0 and 1.1, and then we got to 2, and then recently we got to 3. These are high-level versions of HTTP. We won't be going in depth into each of these. You don't really need to know it, but mainly I want to mention that gRPC is built on HTTP 2 because it needs certain features of HTTP 2. But unfortunately, gRPC cannot be used natively from a browser. If you want to make requests from a browser using gRPC, you need a proxy. So typically gRPC web is what's used. There are other proxies. The reason that's the case, we can't use it directly from a browser, is that gRPC needs some fine-grained control over HTTP 2, which browsers typically do not provide. So that's already a pretty big downside of gRPC. You can use it from a browser, but it's not as easy to do so. So typically gRPC is used for server-to-server communication. So if you had multiple servers here and they want to communicate with each other, that's what gRPC is for. And the reason it's beneficial is because performance-wise, it is objectively faster and more efficient than REST APIs. And the biggest reason for that is instead of sending raw JSON, which JSON is just a string, we're just sending a string of characters when we send JSON with REST APIs. The benefit of gRPC is that it actually sends information in something called protocol buffers. These are essentially schema objects. Protocol buffers provide schema. REST APIs do not necessarily give schemas. JSON is not a schema, but protocol buffers, you can define a schema, exactly the type of data that a RPC endpoint will return. And these data objects are serialized into a binary format. So when we send data with gRPC, we are sending a smaller amount of data than we would be when we're sending REST APIs. And this is what makes gRPC just objectively faster than REST in almost all cases. And it's not only faster, gRPC is actually very, very powerful. Since it's built on HTTP 2, it actually provides a lot of stuff that you need other protocols for, like streaming. We can do a one-way streaming. We could be streaming data from the client to the server. We could also stream data from the server to the client. We could also do bi-directional streaming. Does this remind you of anything? Maybe WebSockets? It should, because this is exactly what WebSockets can accomplish for us. Two-way communication, bi-directional communication. gRPC can actually do that. gRPC, like I said, is not a protocol, but we did kind of mention earlier that HTTP 2 sort of makes WebSockets obsolete. This can get really, really confusing because, we learned about WebSockets, but all of a sudden HTTP 2 can do the exact same thing. Well, first of all, I want you to know that the vast majority of people do not actually know these facts that I'm teaching you. Most engineers don't know this, but I feel I should be responsible and tell you what's technically correct, but at the same time tell you what you actually need to know. This is technically correct, but you don't necessarily need to know that HTTP 2 makes this obsolete. It's more about the trade-offs and understanding what we can accomplish with each technology. And when it comes to gRPC, it's very, very powerful and it's very fast. So what's the downside? Well, it's newer. It was created in 2016. It was actually created by Google and open source. The downside is that there's a lot less tooling around gRPC. It's a lot newer. It's a lot less standardized, and it's definitely more difficult. Protocol buffers, while they are much faster, when it comes to development, they have schemas. Schemas can be kind of annoying. And with gRPC, you definitely need good tooling. We already talked about how it's difficult to use from a browser. If you're building an equivalent API, using gRPC would certainly take you less time than just using REST. REST is a lot more popular. It's a lot easier, and in general, just has a lot more community support. Also, with gRPC, even though it's built on top of HTTP, we know HTTP does have status code. So, with a request and response, we know what happened, whether it was good or bad. With gRPC, we don't have that. We actually have error messages. gRPC does not really make use of the status codes of HTTP. You actually have to have your own custom error handling based on those error messages that you define server side. You have to handle that client side.
Attention. First blood. Round one.
Beginning ring. I've enhanced my weapon. Boosters activate. Level 2. Please examine your maps. I have found the next location of the ring. Eco harvesters are now backpacking. Level 1. Level 2. Optics here. Med range. Dips. Someone is the new kill leader. Gibt Vollgas. Another we picked me up. Seconds and the ring closes. Keep coming. Warning. Ring movement in progress. Not to be pernickety dears, but the ring's on the move, and we're not inside her yet. Care package being delivered. Care package falling. Should we risk it? I've enhanced my weapon. Care package over there. Care package over there. Here's the big noisy bird. We'll spread out. Do I intimidate you? No. Ich bin ganz harmlos.
Fighting even worse.
There's a new kill leader. The weight of success. I leveled up. Choosing an upgrade is the only choice. I've locked in an upgrade. Refueling my shields. I've spotted an enemy. Watch out, darlings. Body nearby. Opponent hit. Reloading. Enemies that way. Enemy over there, acting
I can come to you.
suspicious.
These guys are far.
Ignore what I said.
Beginning ring countdown.
Or if you want to come to me, Trevor.
We're inside the ring. I'm positive.
Replicator being
What are you
delivered.
guys gonna do? Should I come to you or?
Enemy inside there. It's raining replicators.
There's 2 squads here now. This side.
Weapons at hand. Quite the feat of science.
Let's steer that way.
I think they're fighting. I see it through my head.
Enemy over there.
Team's trying to evac out. Entire team evac out.
Tossing a grenade. Just stopping up my shields.
Got that guy.
Competitor down. Ciao, ciao.
Attention. The champion has been eliminated.
Pick me up. Well, the champion's been dropped like disproven serum.
Care package.
One of the evacs went this way.
Enemy here. Supplies coming in. Sending thermite grenade. We're in the top half. Pals. Please examine your map. We will not let off the gas.
My time.
Find your car keys.
We're 2.
They're my out. I downed an adversary.
On my side too. Oh, where?
I am so strong.
That box res on me. Back one.
They're trying to portal out.
Down. I'm down. Here come down.
Good running.
Hold on. Let me help you. Playing with fences.
Champion eliminated.
Ugh. Chance buffing out damage. Enemy very close.
Round 3. Beginning ring countdown.
Outside. Shot up from another squad. Just stopping off my shields. Grenade deployed.
Attention. Delivery replicator.
Incoming. Do not stop. Use the sniper gate.
There's one guy on the right.
Reload.
Start angling him out.
Shields recharging. Walk the enemy. The ring's our neighbor, pals. We've got a minute to find her. Enemy shield is kaput.
Back one on the right.
Pick me up, taking us to new heights, new team. I see somebody. Tossing thermite.
My building.
there.
Gone. Fucking gone. You guys on down?
So slow. Use this knife brigade. We've got another squad coming. Reloading.
Fence placed. Calm, dears. We're already inside the next ring.
Charging shields. We've got another squad alive. Enemy shield is kaput. Another enemy shield broken.
These guys.
Enemy in sight.
Okay, okay.
Refueling my shields.
Pulling the trigger.
Reloading. Knife brigade. Get full gas.
One shot here.
All up here. Full gas.
They're on my
Charging
head.
shields.
You look.
Singularity deployed.
I am down.
Tossing thermite. Oh, it's so scratched here.
I'm healing.
They can be dead.
Are those dead bodies or?
No. They live.
There is a lot.
45 seconds. Never need far at all.
That's house.
Refueling my shields.
Let's close up. I spotted an enemy.
30 and the ring closes.
Clear package over there. Up here. Infinite ammo.
Knife brigade. Get full gas.
I spotted an enemy. 10 seconds. Rings close. One of my fence circuits up there. Heavy ammo here.
Numpty spotted. Reloading. Enemy shield is kaput.
Being shot at. Shields recharging.
Smash an opponent's shield.
You guys are fucked. Can't go ahead.
We will not let off the gas. We've got another.
I'm dead too. Fuck. Knock. No. Yeah, you. There's two teams. There's one on the right side. There's one above you.
A few more meters is over. It's 3 minutes to go. Hold on. Let me help you. I'm in trouble.
Knocking, cow. Knocking the right side. Just knocking on you. I'm bleeding out.
Uh-oh.
Just that fuckers. You need. Chicken died. I shouldn't have said I should have said Dance Box Store is late. I'm pretty sure I just fucked his like decision making there.
However you decide. So these were a lot of the technical trade-offs. I'm going to talk a bit about the developer experience, and we'll take a look at an example right now. So here's an example from the public Google Docs. This is an example of a protocol buffer schema. A message is basically a keyword which defines a schema. This schema is called a search request. It has 3 fields. One is the query field, and these fields are actually ordered. As you can see, query is the first field, page number is the second field, the third field is results per page. Because this is going to be serialized and then deserialized into like a binary format with zeros and ones, it's not going to be human readable. So we do need to put the ordering of each of these fields, because once it's deserialized, it will basically turn into an object in your programming language of choice. You know, you could be using any of these supported programming languages, Python, Go, Java, anything like that. And this protocol buffer will be converted into an object in your language. And this is Proto 3 syntax. It's the most current version, and all of this would go inside of a .roto file. Now to actually create a gRPC API, a .roto file. Now, .roto file, you could define some messages, but you would define a service. In this case, we have a greeter service, and we would create an endpoint, which we call an RPC, a remote procedure call, and this is the name of that RPC, say hello. It will be passed in some request, but that request, remember, has a schema. gRPC is all about the schemas, so this will accept a hello request, which in this case is a very simple object. A hello request just has one field, which is a string, and it's called the name, and this RPC endpoint will respond with a hello reply, and a hello reply is also a very simple message in this case, but you can sort of see the power of this. When we pass in a request, we have a schema, a specified schema that we are to follow, and when we get a response, we're also getting something with a schema associated with it. We know exactly what we should expect with a response. And then, of course, for this endpoint, we would implement our own custom logic, not in the proto file itself, but in your language of choice, like Java or Python. If you want to learn more in depth, I recommend following the docs or creating your own gRPC API. But at a high level, I don't think you're expected to have worked every single technology, every single API paradigm, everything that we're going to discuss in the rest of this course. But the last thing I want to note here is that from a programmer's perspective, with REST, we were talking about resources. We were talking about videos and comments. There were not verbs associated with those resources. The HTTP method, whether it was get or post or delete, that indicated what action we were taking on a resource. With the gRPC here, you can see that every RPC, every endpoint has a action associated with it. A remote procedure call, an RPC is an action that we're taking. This is a function. Say hello is just a function that we're executing on another machine. So with RPC, we do have the verbs, the action that we're taking. It's not just a resource. We don't have those HTTP verbs, even though this is built on top of HTTP. We kind of don't care about those verbs anymore or the status codes. We're programming this in a way as if we're just calling functions locally, but these functions are actually executing on different computers. So that was definitely a lot that we covered. I want to emphasize that REST APIs are by far the most common and most important that you'll need to know, but I would recommend knowing at least a couple things about GraphQL APIs and gRPC APIs, because these are definitely growing paradigms that have their own trade-offs.
First blood? Man, imagine passing out before even taking a sip.
It's a long ride to the next ring.
You're gonna carry me then, bro.
Weapons enhanced. Now let's leave a mark on the world.
The ring closes in a minute, and we are far from it. Los jetzt.
Now my weapons enhanced. Just like me. Extended light mag here. Level 2. 45 seconds and rings far. Fire up the afterburn.
So slow. Use this nitro gauge.
Ow!
Reloading.
Taking fire. Cracked shields on that bandit.
Ow! What the fuck? There's like 3 pumps. Also, my pumps aren't hitting, bro. Like, what the fuck? It's hitting for like 5 damage. Do they need a fucking ADS there? Didn't even crack the guy, I don't think.
Taking fire. Alert 5. Valkyrie on standby, ready for burn. Burn is a go. I like this.
Schema REST API going in. So we just have a single endpoint here where we can query exactly what we need. There's also mutation endpoints. They are structured the same way in terms of the query, but they would actually be updating data on the server. We're keeping things at a pretty high level, so we're not getting super in-depth into the syntax of this, but you can kind of tell that this syntax is pretty similar to JSON in the way that it's nested and that it's pretty flexible and open-ended. But unlike REST APIs, GraphQL actually does have a schema. Like here, this is the schema of the endpoint. We have launchpads available to us, but we can't just specify some arbitrary thing. We can't here ask for like a Tesla. This is SpaceX, so there's no Tesla field here, and we can't just manually add that. We have a schema that we have to follow. We can only choose what's available here. That's a difference from REST APIs, which operate typically on JSON, which is very flexible. We can pass anything into the body and get anything in the response. Now, gRPC is another way of creating APIs. It's also built on HTTP, but it's actually built on top of HTTP 2. We sort of talked about how there's multiple versions of HTTP. We started out at 1.0 and 1.1, and then we got to 2, and then recently we got to 3. These are high-level versions of HTTP. We won't be going in depth into each of these. You don't really need to know it, but mainly I want to mention that gRPC is built on HTTP 2 because it needs certain features of HTTP 2. But unfortunately, gRPC cannot be used natively from a browser. If you want to make requests from a browser using gRPC, you need a proxy. So typically gRPC web is what's used. There are other proxies. The reason that's the case, we can't use it directly from a browser, is that gRPC needs some fine-grained control over HTTP 2, which browsers typically do not provide. So that's already a pretty big downside of gRPC. You can use it from a browser, but it's
From the other side. Just a sec. Healing up. Beginning ring countdown. I'm healing up. Attention, delivering replicator.
Replicator's coming down. I'm healing.
Extra supplies here. I'll share. Survey beacon out there. install. Ring's close. We only have 10 seconds. Gebt Vollgas. 1 sec. Healing up. Ring's closing and we're all in the danger zone. I've upgraded myself. Überraschung. Care package being delivered. Incoming care package. Hold up. Healing. I got an enhanced weapon and a smile on my face. One sec. Healing up. My weapon's enhanced. Take the upgrade where you can. Charging up my shields. Laser sight here. Level 3. Reloading. Enemy shield broken. Ring countdown. Not all of us are in the ring. That's a risky move. We got another squad. Mayday, mayday. Attention, delivering rep. Not today, Captain. Got people depending on you. Charging up my shield. Firing. Reloading. Padlock to bandit. Refueling my shields. Reloading. Got your hands like a champ. Buffing up damage. Getting shot at. Firing. We're already in the ring. Package. I'm down. Repeat. I am down.
You'll be alright. The same thing happened to two of my aunties, and they're fine. Mostly.
Refueling my shields. Got ourselves a bandit out there.
already in the next ring. Don't get comfortable. Luck dies. Winners don't.
Replicator incoming. Rival there, way in the distance. Bogey spotted out there.
I'm not sure if that team killed them and then left or not.
Nice. Safe to touch down. We're already in the next ring. Reloading.
R301 here.
Could go back to the road.
We've got another squad coming. Okay, they're shooting at me. Charging shields.
Got one. Toss and frag. Toss and frag. Fox 3, missile up the
High key, I think this is a good spot.
Moving here.
fire. Charging up my shields.
Enemy shield broken. Firing. Reloading.
Refueling my shields.
Firing.
Only 2 enemy squads left. So we've got our second and third places. Opponent's shield. Competitor down.
He's gonna go res.
Fox 3, I got radar lock.
Refueling my shields. We're already in the ring. Time for a break. Spaß. Do not stop. Use the sniper page. Refueling my shields. Crush an opponent's shield.
Recharging shields. Don't worry about me.
Bogey in sight. Taking fire. Charging up my shields.
You can play right under
Shield
them.
core here.
It's not bad.
Level 2.
Beginning ring countdown.
Reloading.
Taking fire.
Here's a nitro gate. Steer clear of here.
45 seconds. Help, I'm down.
Not today, Kevin. Look out.
We got another squad. Mayday, mayday. I'm grounded.
Not today, Kevin.
These different cross I have.
Got people depending on
posted. Rival right
Charging
here.
shields.
There's a thing on the ground here.
Listen, rival activity this way.
You take it.
Shield core heat. Never mind.
I've been hit.
Pull over here.
Firing.
Rings close. We only have 10 seconds.
Enemy spotted.
Gebt
Over there.
Vollgas.
Fox 3 marking missile. Reloading. Enemy. Good. There. Under fire. Recharging my shield. 1 sec.
Curling Falconade.
We're gonna have to drop. We're gonna have to drop.
Taking shots here. Recharging my
This
shield.
Monitoring this area.
It's good. It's good.
Grenade. Got it.
Thermite out.
Here come the jammers.
Competitor down. This will kickstart something interesting. The peak
One try here. One try here.
Opponent near.
Charging away.
This is time right. Second.
Not as easy to do so. So typically gRPC is
Win this. You win this. Yeah, I mean, if they just look over that way, I think I should just.
used for server-to-server communication. So if you had multiple servers here and they want to communicate with each other, that's what gRPC is for. And the reason it's beneficial is because performance-wise, it is objectively faster and more efficient than REST APIs. And the biggest reason for that is instead of sending raw JSON, but JSON is just a string, we're just sending a string of characters when we send JSON with REST APIs. The benefit of gRPC is that it actually sends information in something called protocol buffers. These are essentially schema objects. Protocol buffers provide schema. REST APIs do not necessarily give schemas. JSON is not a schema, but protocol buffers, you can define a schema, exactly the type of data that a RPC endpoint will return. And these data objects are serialized into a binary format. So when we send data with gRPC, we are sending a smaller amount of data than we would be when we're sending REST APIs. And this is what makes gRPC just objectively faster than REST in almost all cases. And it's not only faster, gRPC is actually very, very powerful. Since it's built on HTTP2, it actually provides a lot of stuff that you need other protocols for, like streaming. We can do a one-way streaming. We could be streaming data from the client to the server. We could also stream data from the server to the client. We could also do bi-directional streaming. Does this remind you of anything? Maybe WebSockets? It should, because this is exactly what WebSockets can accomplish for us. You know, two-way communication, bi-directional communication. gRPC can actually do that. gRPC, like I said, is not a protocol, but we did kind of mention earlier that HTTP2 sort of makes WebSockets obsolete. This can get really, really confusing because, you know, we learned about WebSockets, but all of a sudden HTTP2 can do the exact same thing. Well, first of all, I want you to know that the vast majority of people do not actually know these facts that I'm teaching you. Most engineers don't know this, but I feel I should be responsible and tell you what's technically correct, but at the same time tell you what you actually need to know. This is technically correct, but you don't necessarily need to know that HTTP2 makes this obsolete. It's more about the trade-offs and understanding what we can accomplish with each technology. And when it comes to gRPC, it's very, very powerful and it's very fast. So what's the downside? Well, it's newer. It was created in 2016. It was actually created by Google and open source. The downside is that there's a lot less tooling around gRPC. It's a lot newer. It's a lot less standardized, and it's definitely more difficult. Protocol buffers, while they are much faster, when it comes to development, they have schemas. Schemas can be kind of annoying. And with gRPC, you definitely need good tooling. We already talked about how it's difficult to use from a browser. If you're building an equivalent API, using gRPC would certainly take you less time than just using REST. REST is a lot more popular. It's a lot easier, and in general, just has a lot more community support. Also, with gRPC, even though it's built on top of HTTP, we know HTTP does have status code. So, you know, with a request and response, we know what happened, whether it was good or bad. With gRPC, we don't have that. We actually have error messages. gRPC does not really make use of the status codes of HTTP. You actually have to have your own custom error handling based on those error messages that you define server side. You have to handle that client side however you decide. So these were a lot of the technical trade-offs. I'm going to talk a bit about the developer experience, and we'll take a look at an example right now. So here's an example from the public Google Docs. This is an example of a protocol buffer schema. A message is basically a keyword which defines a schema. This schema is called a search request. It has 3 fields. One is the query field, and these fields are actually ordered. As you can see, query is the first field, page number is the second field, the third field is results per page. Because this is going to be serialized and then deserialized into like a binary format with zeros and ones, it's not going to be human readable. So we do need to put the ordering of each of these fields, because once it's deserialized, it will basically turn into an object in your programming language of choice.
Let's check out that way.
Let's do that way. You out of my tailpipe.
Enemy shield cracked. Good, brothers. I've been down.
So slow. Use the sniper gate.
reviving.
Smash the opponent's shield. Competitor down.
Do not revive me now. Stop this hostile close.
Beginning ring countdown. Attention. Delivering our stuff.
Contact with target.
Ah, first blood. Some aren't made for this. 1 full minute and the ring is close.
Let's go this way.
Let's go. I don't like stalling.
Hostile right here.
You could be using any of these supported programming languages, Python, Go, Java, anything like that, and this protocol buffer will be converted into an object in your language. And this is Proto 3 syntax, it's the most current version, and all of this would go inside of a .proto file. Now to actually create a gRPC API, you would, again, in a .proto file, you could define some messages, but you would define a service. In this case, we have a greeter service, and we would create an endpoint, which we call an RPC, a remote procedure call, and this is the name of that RPC, say hello. It will be passed in some request, but that request, remember, has a schema. gRPC is all about the schemas, so this will accept a hello request, which in this case is a very simple object. A hello request just has one field, which is a string, and it's called the name, and this RPC endpoint will respond with a hello reply, which RPC create, and all of this would go and call in some request. But that request, remember, has a schema. gRPC is all about the schemas, so this will accept a hello request, which in this case is a very simple object. A hello request just has one field, which is a string, and it's called the name. And this RPC endpoint will respond with a hello reply, and a hello reply is also a very simple message in this case. But you can sort of see the power of this. When we pass in a request, we have a schema, a specified schema that we are to follow, and when we get a response, we're also getting something with a schema associated with it. We know exactly what we should expect with a response. And then, of course, for this endpoint, we would implement our own custom logic, not in the proto file itself, but in your language of choice, like Java or Python. If you want to learn more in depth, I recommend following the docs or creating your own gRPC API. But at a high level, I don't think you're expected to have worked every single technology, every single API paradigm, everything that we're going to discuss in the rest of this course. But the last thing I want to note here is that from a programmer's perspective, with REST, we were talking about
Here comes Gibraltar!
Care package on high.
Care package there. A short care package there. A short run for me.
Careful, no kill leader. My weapon has been enhanced, marking our surroundings.
Extra supplies here. Gotta love that.
Marking our surroundings. There are unscotty to be found in this direction.
We've got an evil harvester here. Anyone?
Someone just landed in front of you.
Opening fire.
I've leveled up. Taking fire. I've chosen an upgrade. Taking a moment to heal.
Enemy shield kaput.
Watch out, I'm opening this guy. Shield up. Heads up, we got an airstrike on. Gotta heal, taking a knee.
Marking our surroundings. A leaf to our enemy. Let us follow it.
My strategy takes us here. Ultimate accelerant here.
Bless me with sight. A leaf to our enemy. Let us.
At least to our enemy.
Round
Let
2.
us follow it.
Beginning ring countdown.
Next ring is in close. Check your map.
Competitor there. Opponent there. Attention. Delivering replicator. Got a replicator incoming. The champion has been eliminated. Follow me
Our
there.
champion has
Lost
fallen.
kids, don't make me drag you. We've got an evil harvester here. Anyone?
Reloading.
I'm healing. An aggregate. Gibt Vollgas.
Trust in me, old father. A trail to Scotty. Let us catch them unaware. Scanning the area.
Taking fire, brothers. Enemy ship.
Flag out. This will kickstart something interesting.
I have fallen.
Competitor down. You don't stop. Use the aggregate.
This way.
Rezzing
Let's
here.
go.
Get him up.
Did I tell you to die? Get off your knees.
Wait now.
Contact the target.
Setting up an evac tower. Shooting at me.
I got you, brother.
Charging shield.
Scanning the area.
Snapping opponent's shield. This thing catch up to us. It's done. I am never done.
Just one try there. Dude, just one home touches.
You tried, you died.
Resources. We were talking about videos and comments. There were not verbs associated with those resources. The HTTP method, whether it was get or post or delete, that indicated what action we were taking on a resource. With the gRPC here, you can see that every RPC, every endpoint has a action associated with it. A remote procedure call, an RPC is an action that we're taking. This is a function. Say hello is just a function that we're executing on another machine. So with RPC, we do have the verbs, the action that we're taking. It's not just a resource. We don't have those HTTP verbs, even though this is built on top of HTTP. We kind of don't care about those verbs anymore or the status codes. We're programming this in a way as if we're just calling.
Safe. Response. Spell to.
Attention. First blood.
Oh, someone got the party started.
Round 1. Beginning ring countdown.
Ring's close. One more minute.
Attention. Evo harvesters are online.
I have an extended sniper mag here. Level
Ring's
2.
close. 45 seconds on the clock. Today's coming up aces. Lucky for you, I've got some extra
I have
supplies
almost
here.
exhausted my ammo. I must find more. As only 30 seconds remain. Safety is an arrow shot away. Yes, this upgrade will do nicely. Optics here.
Deploying me knuckle
Mid-range.
cluster. Tick-tock, 10 seconds. Guess the ring's close. Weapons enhanced and ready to dance. Nothing up my sleeves and extra supplies. Shield battery here. Backpack here. Level 2. Listen up. The ring's moving and we're serving them a knuckle sandwich.
I need another Mozambique. I wish to dual wield.
Weapons enhanced and ready to dance. I bet it does.
Package being delivered.
Care package on high. Favor from the gods.
Serving them a knuckle sandwich. Head that way, eh? Struth, enemy here. Keeping me people focused over there. Looting here. Joker here.
Reckon we set up a defense there.
Stay.
Bro.
Look to your map.
Backpack here. Level 2.
Dibs. I have enhanced my weapon. Glory awaits.
Attention. There is a new kill leader.
Be aware of the new kill leader.
Boom. Next ring location on your map.
Let's go that way.
Knuckle cluster out. Extended light mag here. Level 1. Got me eye on an enemy nearby.
Your side, your side, your side. No. You were going a good side. I was just aiming at the from your side.
What do you say?
Good side.
Juke's so close. Send it on my decoy. Barrage here to save the day. That was better in my mind. Recharging me shield. One sec, healing up. shield cracked. Bingo! Hit that joker. Get back. Knuckle clusters bothering.
The fight is not even. Multiple squads attack.
Bingo. Hold on to your code pieces. Subtle loads dropping.
Recharging my shields.
Right going long. Cracked an enemy shield. Reloading. They're shooting at me. Juicing the shield.
Replicator delivered.
Blessings upon us. Our replicator descends.
Faking him out with a decoy.
Clown there. Last Reload.
Knuckle cluster.
I downed a hostile.
Another squad's joining the fight. Airstrike incoming. 1 minute until close. Rings nearby.
There's a team in the tower.
We got an amp here. Power booster.
I am selecting, marking our surroundings.
45 seconds. Range's not too far. I'm okay with that. Being shot at. Rings near with 30 on the clock. Let's move.
Taking a moment to recharge my shields. Marking our surroundings.
Alright, enemy down. Ten seconds. The ring is basically knocking on the door. One sec, healing up.
All father
Broke that enemy shield.
What is that?
Our shield crack is light up.
Shields are recharged. Another bloody squad's attacking us.
Taking a moment to recharge my shields.
Yep.
Deploying me knuckle cluster. Revive me
They
later.
fucking below you.
Drop, drop.
Relax. I got everything under control. Deploying me knuckle cluster. Juicing
Thank
the
you.
shields.
Recharging my shields.
Avoid this spot. Shots fired and they're hitting me. Knuckle cluster out.
Team on our right.
One more team. Get back, get back. Back up.
Give him my shield to recharge. I'm down.
Another team. Yeah, why not?
Why fucking now?
You can keep trying, but I've seen.
So next I want to talk about the basics of API design. We know a few API paradigms, which basically allow us to control the interface of our API, the surface area, or you could also call it the API contract, which basically describes how we're going to use a particular API. We have some service, for example, this could be the Twitter API or the Reddit API or the YouTube API, anything. There's some functionality of an application. Let's assume this is Twitter. We want to do certain things with
Look at how things change, 'cause now you're the train and I'm tied to the track. You've awoken me. Gave you all of me, and now honestly I've got nothing left, 'cause I loved you dangerously. No more than
with this. We want to maybe create a tweet or delete a tweet or edit a tweet. Well, you can't actually edit a tweet on Twitter, at least not until recently, so we're just going to assume that we can't do that. Or you want to see a list of tweets, like for your home feed, or you want to like a tweet or retweet something, right? You can do all these things on Twitter. Now, the API design portion is only about the actual surface area of the API.
Do you want to go head to head? Weapon in
Down another. Scanning the area.
You baby.
Got a competitor.
I've got a hostile.
He's coming. It's another team.
Scanning the area. Recharging my shields.
Opening fucking smash. We've got another squad coming.
Fried 2 of them. Might be pushable. elbow myself, and I'm on my way.
I downed the hostile.
Flag out.
Marking our surroundings.
Smash an opponent's shield.
Very soon, I think.
Taking a knee. Catching up.
We are inside the ring. Calling upon nature's strength. There are people. I have fallen.
I cracked that guy.
Pushing around.
Pushing right side. Right side.
Nice, one
Right side
left,
last.
baby. Good trap.
API, how we're going to interact with Twitter, what we are going to do, what actions are we going to take, creating, reading, updating. That's basically CRUD. Pretty much most actions are going to be within the scope of CRUD, creating, reading, updating, and deleting some resources or entities. Entities are things. Entities are nouns. In this case, a tweet is an entity. It's a thing that we're going to be interacting with. It's a resource. And the verb create is mainly going to be handled. I'm going to be focusing on REST, so it's mainly
Why is
going to be handled with the actual verbs like get, post, put, delete, stuff like that. But if you were doing this with an RPC framework like gRPC, the verb itself would actually be included in the endpoint. But again, the important thing about API design is we do not care at all about the implementation details of the API. We only care about the surface area, what we are actually interacting with as users. API design is pretty similar to just coding in general, right? Like creating functions, and each of those functions, has some input, output. We don't care about the implementation of that function, but we care about what are the parameters or arguments that go into a function, and what do we get back after we create a tweet. We expect to get a tweet in response to that, or maybe some error code telling us why it didn't work. But the reason API design is a really important topic in the real world is because with publicly facing APIs, we can't change stuff. Like let's say we have a method or an endpoint for creating a tweet. Let's say it looks something like this. If we want to create a tweet, we have to give the user ID of the person creating the tweet and the actual text content of that tweet itself. So that's like our endpoint for creating a tweet. Now if we implemented this with a REST API, which is how Twitter and actually the vast majority of public APIs are implemented with REST, this is an example of what it could look like. It would be a post request because we're creating a resource on the server, passing in a few parameters here, but those aren't going to be included in the endpoint definition. This endpoint could accept, a body, and that body itself could have some key value pairs. Let's assume it's JSON because that's the most popular. It can have a few key value pairs, the user ID, and then the ID of that user, the content, which would map to, the actual string text of that tweet that we're creating. So it really is just like, object-oriented programming or just creating an interface.
Me and Surgical are in call, so I don't know if he's... Yo, Surgical, turn your game chat on.
Surgical, lock the fuck in.
Oh yeah, because this is a terrible loadout. Okay.
I've enhanced my weapon. Enhanced. Nothing a bit of elbow grease couldn't do.
Oh my dude.
First blood. First blood. Some aren't made for this.
Are they fighting over there on the other side of it?
Yeah, I think so.
Whatever.
Yeah. Next thing's fun.
Alright.
Pick up the pace.
I'm gonna come up top and then fly over.
The whole squad.
Oh, it's another C though.
Making room for the real competition.
Okay.
Come on, it's drawn, pierced by the earth.
We're about to find out. I think they're... Do what?
He's hiding from like here. Ready to move. I see him in the middle.
Available.
Yep.
Forget it.
Ow!
He might be solo.
I was about to say, I...
Cracked him, cracked him.
Head that way.
Dude, it's just one.
Shotgun arsenal here.
Okay.
I've locked in.
He's trying to run. No, there's three. There's three.
Said there's three! What are we doing?
They're focusing on me. by the earth. None of us are in the ring.
Okay, so how?
Red one.
Yeah, just go. Yeah, you're getting chased, Octane.
Gas geben.
There's another team.
Yeah, nice.
Dude, how are you fighting one and then all of a sudden I'm getting beaten by 3 people?
Brain dead. Commodore is 3. And then he pushed, by the way.
Or an object or a class. It's not super complex, but we have to be really, really careful with this because this is a public API. Let's say these 2 parameters are required for our endpoint, and we want to make some changes to this, right? We want to add some more parameters that you can add to a tweet. If we were just starting out with Twitter and we had this as our public API and all of a sudden we wanted to add some crazy feature like being able to reply to tweets, like let's say this is a tweet and this is a separate tweet. You know, these can exist individually, but maybe this tweet is actually a reply to this other tweet over here. Well, how would we modify our create tweet endpoint? Well, we would have to pass in, let's say, another parameter for the parent tweet possibly, right? And that would be, let's say, parent tweet ID, right? The ID of the parent tweet that this child is a reply to. Well, this is actually okay. This is acceptable because we will make the parent ID optional. It is not required. So what that means if now users want to create a tweet that's a reply, we can use this parameter to the create tweet endpoint. This will be passed in the body. It works perfectly fine. But also at the same time, all the people that are using the original create tweet endpoint, the one that didn't even have parent ID available, that are just passing in 2 parameters, this will still work. The whole point of adding an optional parameter is that it is backwards compatible. The people using the older version will not break. But what if we added parent ID and we made this required? That means all the people using the original endpoint aren't passing this in currently. I mean, they could update their code maybe pretty easily to do this, but if we push these changes to our API, it will break literally 100% of the existing users until they update their requests to pass in another parameter. That's why we have to be very, very careful with API design. It's an important topic. Being backwards compatible is really, really useful. But of course, there are going to be some changes sometimes where we have to introduce new required parameters, or we have to just change and redesign the entire API. In that case, we would not have a backwards compatible API, and that's when versioning comes in. Typically, most APIs will have some type of version associated with it. You know, this is an example where the first thing in our URL path here is the version of the Twitter API. Twitter has, I think, a couple APIs. We have version 1, and this is kind of a common way of doing it. I think Twitter actually doesn't even have the V, they just have the version itself. Stripe, I think.
Planning on the like
Change my mind. Yeah, right with that.
Got all that dead. I was getting shot from the middle
You're not on
turret.
your bike now.
That one on the far team.
First blood. Someone's been a rascal.
Refueling my shields.
Enemy here. Looky here, lads. We're inside the ring. Enemy there. You're there. Oh. Antagonist down. Broke a rival shield. Reloading. Another squad is into the scene. See it through the veil. I'm recharging my shields. Change positive here. Change positive here.
Upgrade available.
Another bloody squad's attacking us. Broke that enemy. Down. Fair income shot though. There, haul ass.
Reloading.
It's like you've done that.
Got back our teammate's banner. We're already in the next ring. Don't get comfortable. Luck dies. Winners don't.
Back in the fight, fellas.
Move there. Opening fire. I'm getting shot at.
Walking up.
Incoming care package. Let's see who gets there first.
Where?
Shields are recharging. RE-45 here. Lifting there.
am down.
That was a guy 45 blushed. There is.
Stay strong, I'm coming. Your party's not done. Shields are recharging.
Refueling my shields. Half are dead. The rest, Feierabend.
I'm taking fire. Bleeding out.
Can't stop. Use the sniper brigade. Buffing out damage. They're shooting at me. I'm getting... That's the last one in the squad. Sad. I wanted a challenge. Got back our teammate's banner. Pressing an actual gate. Gas gaping.
Where are you running?
He's gonna die, I think.
Taking it beat.
What just happened? Did you get third party?
Does have a V, but that's a small detail. But the point is that the version of the API is important because now if we introduce a new version of this API, we will not break the original API. We'll have two versions of the API coexisting at the same time. Now, after a tweet is actually created, that tweet will have some information that we didn't necessarily pass in. A tweet is created server side, and we assume it'll be persisted to some database. But like I said, we don't have to worry about the implementation details. We're just talking about the interface, the API contract. You pass in some parameters that are optional or required. You get back a tweet. Now, the tweet itself could look something like this. This is obviously really simplified. It could have a lot more, but every tweet is going to have some owner or user associated with it. Like the creator, I guess, would have been a better word for user ID here. But there's going to be some unique user who created the tweet. The tweet could also have an ID itself to uniquely identify it because a user is not enough to uniquely identify every tweet. But of course, this tweet ID, for it to be universally unique, it would have to be created server side. But this is an implementation detail that we do not have to.
Okay.
Worry about because when we create the tweet, we do not have to pass in the tweet ID since it is created server side. That's all you really need to know. It's not going to be sent by the client who's actually creating the tweet. But the user ID, though, does have to be sent because only users can create tweets. The content will also be provided by the client, like what's actually included in the tweet. But the timestamp that it was created at, technically, it could be created by the client if we really wanted to. And then on the server, we could validate that this time is reasonable, like it happened, at roughly the time that the request was reached by the server. But probably not a good idea to have this because users should not be the one taking the timestamp at the time that the tweet was created at because it's created on the server side. The server should be the one responsible for this created at time. So we do not pass that in to our endpoint. And the number of likes, of course, is going to be 0 initially. But we also don't pass that in when we're creating a tweet. That will be handled server side. But tweets can be liked and unliked. So that is some additional functionality we have to include into our API. Now, if we wanted to actually get and retrieve or read an individual tweet, obviously when we create a tweet, we get that as a response. But we should also be able to read tweets after they've been created.
Let's go over there. Right there, man. Firing.
Sending up an evac tower.
Knuckle cluster out.
Care package there. A short run for me.
Shields are recharging. Stand back. Knuckle cluster's firing. Juicing me shields.
Round 3. Beginning ring countdown.
Opponent over there. We are inside the next ring. This is our stage.
Here's a nitrogen. Pick up the pace.
Replicator incoming. Now, what to create?
Here's one at this.
This way, perhaps. Deploying
Am I right? Am I right? Here, here.
Another team's heading through there. Competitor
Killed one, I
down.
killed one.
Ciao, ciao.
You can look.
Enemy close.
Crack, crack. Push, push, push. Okay.
Serving him a knuckle sandwich. Juicing me shields.
Reloading.
Handicap shot though.
You do things halfway. Are you satisfied with the result?
Using a Phoenix kit. 10 seconds and the ring's close.
Okay. Down. Repeat, I am down.
Let's go here.
Just gonna hit.
Cool your jets. You're not on your bike now.
I'm recharging my shields. Another squad is in this. For just a moment. Crafting. Drawing back the veins. Shields are recharging.
Can't even crack.
Reloading. Drop the vein. Don't revive me. It ain't safe.
Delivering replicator.
Replicator incoming. Now what to create?
Attention.
Two other squads remain. I am taking fire. One lifting the veil. Shields are recharging.
You trapped him.
45 seconds. Ring is near.
That one is not too far.
I'm taking fire. Need to compose myself. 30 seconds. Your veil will fall.
Judge.
Just gave ring, huh? So I need to not like.
We should be able to read tweets that we ourselves have not created. So we have a very, very similar looking endpoint here. The URL is almost the exact same, but we have one additional parameter. This is a URL parameter. That doesn't mean that the URL is going to be v1/tweet/id. This is a parameter. There's going to be some value that we put here, which is going to be a tweet ID associated with an individual tweet. A get endpoint would be to just read that tweet and all the information associated with it. We could also have had a delete endpoint, which would be responsible for deleting that tweet, but only if we are the actual creators of that tweet. So we would probably have to pass our user ID, and probably some more additional authentication and authorization would go on in the back end. But that's something that's out of the scope of API design typically. Now, what if instead of getting an individual tweet, we actually wanted to list all the tweets for a particular user, just a single user? We want to list all of their tweets. Well, a single user could have a lot of tweets. I mean, some people on Twitter just go crazy. They have thousands and hundreds of thousands of tweets. Pretty insane if you ask me, but it is something we still have to handle. So of course, we don't necessarily want to return every single tweet in a single request. That might crash the user's browser. And it's pretty unlikely that they would want to see thousands and thousands of tweets. So we do what we kind of talked about, which is pagination. It's very, very important in API design to have pagination when you're listing a large amount of data. And it's basically handled with two parameters that we kind of talked about. One is limit. This is sort of the max size, the max number of results you want to be returned by an endpoint call. So for example, we could pass in list all of the tweets for a particular user, but limit it to just 10 tweets. Now, what if that user has 100 tweets? Well, we're only going to see the first 10. Maybe we're sorting it based on chronological order, right? Like based on the created at timestamp, but possibly the user doesn't even have 10 tweets. What if they only have one tweet? They just created their first tweet and we call our endpoint with limit 10. We're only going to see a single tweet. So this is the maximum that we could retrieve. But now suppose we want to see 10 more tweets. We need a second parameter, which I call offset because it's pretty simple. It basically tells us what's our starting point. You know, we could be starting at 0. That would be the beginning, the first 10. If we're starting at 10, that means we want the next 10 after the first 10, or we could be starting at some arbitrary position like 2500. Now, we would definitely be listing a bunch of values using a get endpoint, but the thing about get is that there's
Yelling is good for focus. Follow me there. Los geht's. Don't make me drag you.
No, my audio's broken right now. It just sounds like somebody's landing right above me.
Yeah, that's awesome.
I'm finna drop down.
Round 1.
Kangaroo's not that good.
Countdown.
We're already in the next ring. Don't get comfortable. Luck dies, winners don't. Getting shot at. Competitors pass by here. Achtung, grenade! I'm healing.
First blood. First blood has been taken.
Any shield is cracked. Being shot at. Here's a stick. Recharging my shield.
I hit one for like 104.
Warning. Ring closing. We're inside the next ring. Superior positioning.
Oh, I see two up there.
Hostile flying. Shooting at me. Their end shield is cracked. Recharging my shield, cuzzies.
my shields.
I'm just kind of sitting over here on the zip waiting to take it, but we just need to get them off. They gotta be getting low on shield. God, I'd kill for a dude, what? Dude, he just headshot me.
I've enhanced my weapon.
Kill for a fucking multiplier.
We a tear to give us an edge.
I have them if they zip down.
Enemy there.
Damn. You just shot me through that, dude. That's crazy.
Charging shields. Achtung, grenade.
You didn't really think I could be killed, did you?
The Pete, I am down.
An enemy.
Grenade.
Time to buy.
Singer closing on us.
I'm down.
Oh, dude.
Wait, let me help you get those fangs out of the...
No body for a get. We can't just pass in a bunch of stuff in the body of the get request. We have to take these and put them in the URL itself, either as URL parameters or as query parameters. But there's actually one problem. We can't reuse this endpoint definition because this is already reserved for getting an individual tweet. Given this path and some tweet ID, this should return a single tweet. Or maybe here we could actually have had, multiple tweet IDs. But the point is that this is going to return a tweet. This ID is based on a tweet ID or multiple tweet IDs. But if we want all tweets for a user ID, we should probably create a different endpoint. We're gonna have get as the HTTP method, but we need a different path. So let's try to create one. So this is what an endpoint for actually listing tweets for a particular user could look like. So we have our base path here, version 1.0, and then we have our user's resource. So we're starting at the user level, and then we're getting an ID. Usually we just have ID for short, at least I prefer to, but we could have also written here user ID to be a bit more specific, but typically ID is followed by the resource that it's applied to. So this ID applies to the user. And then after that, for a user, we have resources, aka tweets, and from the tweets, we just want to list them. So this is, what we're passing in, just tweets, or we could just have tweet here as well. But important thing is that this is so long, it takes 2 lines to fit. This is still a part of the original endpoint, and these are the query parameters. By the way, I forgot that this is a get endpoint, but we have a couple query parameters, and these could be optional, or they could be required. It's probably better to have this be optional because the default value, if we don't specify offset, the default value will probably be assumed to just be 0. We're starting at the beginning. If we don't have limit set, that doesn't mean that this should be limitless. That doesn't mean we need 100,000 tweets from a single endpoint call. This will be some default value, something reasonable like 50 or 20, something like that. So if we don't specify anything, it still works, but we can add additional query parameters that are optional so users have more control. Also, before we take a look at the Twitter API docs and a couple other docs to see what real APIs actually look like, I want to discuss a couple things about REST APIs in general. First of all, we've been kind of writing our endpoints like this in coding interviews since, it's more open-ended. Like we could have been using gRPC. It might be better if your interviewer just allows you to kind of interface a endpoint just as a function, like, the way we did with create tweets, and then that could have some parameters like user ID and some other stuff. And for actually defining entities like this, maybe just something like this works. With API design, that's really the big thing. Like, what are the entities that we're actually talking about? We have tweets, we have users. Well, that's actually pretty much it, but we have a lot of relationships between these things. Like users can have tweets, users can like tweets, users can follow each other. We could have gone, pretty in depth into the API design of Twitter, and we definitely would have only scratched the surface. But to kind of simplify this, usually instead of writing out the entire REST endpoint, probably better to just kind of write it out as a function that takes in some parameters like a user ID, stuff like that, and then it returns an entity like a tweet. So we get the kind of input output, and we don't have to worry about the actual implementation details. And also, you probably don't need me to tell you this, but when we make get requests, we probably shouldn't actually create resources in our API. Getting is only for reading. We don't want to create resources with a get request, pretty much as the name implies, but also because get requests are supposed to be item potent and they're assumed to be item potent. That means if we pass in the exact same input parameters to an API call, we will get the exact same result.
One of the guys pushing you.
Taking fire! I'm down!
Competitor down.
This won't hurt. Charging up my shields. Listen, let's move here.
1 second. We got this.
Extra boost! We've got company.
Charging shields.
I think we third party this building.
Pull over here.
Down 2 and they were fucking shit on.
I'm healing.
signal here.
Excellent, excellent.
That dude's over there. Aki, over here.
Good. Got my ultimate ready.
Let's go to Geek.
Shield broken.
Another squad attacking us.
Are these guys fighting? What is my team doing? Oh, I actually. What do you even do?
I'm low on ammo. Level 1.
Attack, attack. One up top, one where we just were. Right here. We got one up top right here.
One shot.
Charging on my shields.
Enemy shield broken.
Oh my fucking god, whole fucking team's right there.
There's another squad.
Thank you.
No problem.
And I know there was a whole fucking team in there, bro. What the fuck is that?
Amigos, let's go here. Amigos, let's go here.
There's two teams. Last reset.
Faster, faster, faster.
Need to recharge my shield.
Just hold that door. Just hold that door. Hold that. No, come here and hold this door.
One team hold it out. I'll hold it.
Respawn beacon down.
Recharging my shield.
Squad arriving.
I do not know what that grenade is came from. So they just broke it.
Another squad.
Cracked an enemy shield. Charging on my shield.
Somebody just pull up. Who's about to pull up? They're here now. On top. I think someone's on top. Right here. You right here? Oh, that's right. Pathfinder's, oh, one bullet from crack.
Enemy shield broken.
Crack. Alright, crack.
Need to recharge my shield.
Refueling my shields.
I'm going on top. I'm on top right now. Pathfinder's cracked. Pathfinder's cracked up top. There's two up top right now.
Where are my bullets going?
Go.
Somebody on this back
Down
side.
that one. They're not getting back up from that.
Enemy shield broken.
Crack.
Yo, cracked.
Crack in there.
Taking fire. Down the other one.
Walk.
Need to recharge my shields.
They're not getting back up from that. Reloading.
On top. Hit. He's 22. He has no white health. Yes, sure, but no white health.
Oh yeah!
Almost got.
Hitting the eject button.
Replicator coming down.
Ready, set, go!
Oh no, but if we can't find him, we gotta go back. We're going from circle.
Reloading.
Catching myself up.
That's the last of them, amigos. Booyah! New kills right here. Okay, what's next?
Ring is close, and we have a minute to reach it. 45 seconds. You could crawl to the ring, but I've enhanced my weapon. So slow. Use the sniper gate. The ring is near. Keep an eye on the timer. Just 30 to go. So slow. Use the sniper gate.
De nada.
No, right in front of us, right in front of us.
My strategy takes us here.
Another team.
Struggle with my R9.
There's actually two new teams.
2v2.
There's two new teams. There's two fucking new teams.
Go! They're shooting at me. Down another one. Don't cut out.
What? I got fucking two-tapped by a mastiff. Fuck! On top right here. We're sitting in this corner right here.
I'm gonna stay down here.
She's sitting right here.
Contact with enemy.
Crack the bad news shield. Taking fire. There goes
Good
another
shit.
enemy shield. And that's all of them. Good job.
Hey, what you doing down here, amiga? This isn't the finish line. Come on, compadre, get up. Come on.
Shields are in rough shape. Need a beat to recharge. Buffing out damage.
Need to recharge my shields.
Right team on
Crack the bad
Care
news
package
shield.
over there.
It's go time. Ha!
Buffing out damage.
Low, one.
Fuck up.
Dead.
He's over there. Shield. Downed another one. That one's out for the count.
Buffing out damage.
Round 3.
Reloading.
Beginning ring countdown. Firing. Enemy shield broken.
Oh my fucking one hurt. One hurt. Oh, they're all fucking one.
Crack the bad dude's shield.
Buffing out damage. One let's go. I don't like stalling.
Follow the tunnel.
That one's out for the count. 45 seconds.
We've got another squad arriving. Put an activate down.
Use a zip line. Use a zip line. Not all the way up, but yeah, there's a full team up there too.
I'm hit! Charging on my shields. Booyah!
It might resonate right in front of us.
Taking
I
fire!
think that's off. I think. Oh, that's rude. One, two, one.
Yo, cracked an enemy shield. Charging on my shields.
I'm good, I'm good.
Disappear, I'm down. Move there. This won't hurt. Hold on.
Go faster!
He's almost cracked. Almost cracked. Fuck, man, I can't even res.
That's crazy, actually.
Peaceful beacon dead. Follow the tunnel. Back on the whole tour.
I'm out of energy on my too.
Firing!
Spotting out there.
Oh no, there's another squad!
Ring is close, and we have a minute to reach it.
Behind us. Oh, I'm going to pull up on a bird.
Zipped in? Oh.
Look out, grenade!
Yeah, on my door, right on my door.
Let me go half.
Just hold that door. On. Oh, fuck. Hold the door, hold it.
Enemy pulling up here.
Amigos, let's go here!
Good night. James looking at the room.
Recharge my shields.
Both crack up there.
This won't hurt. Hold on.
Fuck.
I think I played that really bad.
After the first call, that basically means that taking our very simple example where we're reading an individual tweet, like we pass in the tweet ID and we want to see all the contents of that tweet. If we call that endpoint once, we'll get the tweet. If we call it more times after the first time, it should not give us anything different. The tweet should not change as a result of GET requests. They should be idempotent. The reason that's important is for caching, because by default, GET requests are cached. So if we were misusing the GET request, which we technically could, we could make a GET request and the code on the server side could actually be creating stuff. Given a GET request, we might end up updating some content of the tweet. We could technically do that. There's nothing stopping us from doing that, but it's very, very bad practice. You'll probably never do it. And this is a pretty obvious mistake to avoid, I think, but still definitely worth mentioning because I don't see a lot of people talking about this. Okay, now let's take a quick look at how the Twitter API is actually designed. So these are the Twitter API docs. You can see here I'm looking at Twitter API version 2. There are other versions, as you may have guessed, and there's a lot of stuff here. Like you could read this for a long time. There's a lot of details. We'll just be looking at a couple of functionalities. You can see here under manage tweets, we have a couple endpoints for updating a tweet here. This 2 is just the version. This means we're using Twitter API version 2. And then we have a tweets path. So this would be added to like the base Twitter API, which I think is just API.Twitter. And you can see we don't need to pass in the tweet ID when we're creating one because that will be handled server side. But if we're deleting a tweet, we definitely need to pass in the ID of the tweet that already exists. Taking a look at how to post a tweet, you can see here we have the full endpoint URL. We have additional information about how this endpoint is rate limited. Like we wouldn't want a public user to be able to make a billion requests to this in a second. That could crash the Twitter API. So we have some limit applied to it. In this case, it's 200 requests per 15-minute window. And we have some additional information about the API. Generally, if you're coding a public API, it's very, very important to have good documentation. In many cases, if you add good comments to your code itself, you can generate good public-facing docs that are similar to this for every parameter. In this case, you can see since this is a post request to create a tweet, we will use the body of the request, and it is formatted in JSON. That's the most common because it's very simple and readable. And these are kind of all the options that we could pass into the body. Most of these are optional. Pretty much all of them are, I think, which is pretty good for backwards compatibility. Now, taking a look at the timelines that we can actually create, there are a few. The simplest one, I think, in my opinion, is the actual user timeline. This is for a particular user. We want to see all the tweets that they have created, and you can see it's pretty much exactly like we talked about, where we start with the user's resource, and then for that user ID, we get all of their tweets. Taking a deeper look
Don't fuck around, lots of kills. Yelling is good for focus.
Scanning.
Nobody look.
Pick up the pace. First blood. Round one.
Ring is close, and we have a minute to reach it.
Evo harvesters are now available.
Ring's close, with 45 seconds to burn. I recovered their banner. Let's give them a jump. He's one beacon coming down. 30 and the ring closes.
All right. 10 seconds until the ring closes. It's closed though.
Champion eliminated.
You cheerleader? I don't know. Sounds like too much pressure for them.
Rings moving.
Backpack here. Level 2.
Attention. Delivering care package.
Ooh, new supplies dropping. I could use more stuff. Stick with me. I always find my mark.
Upgrade available.
Let's go there.
My favorite. Upgrade engaged. We're not the first through there.
Setting a tracker. Un momento, per favore.
Enemy, way off.
Bullseye. Enemy tracked.
Broke their shield now. Reloaded.
Okay, they're shooting at me.
Attention. Leader.
Again.
Refueling my shields.
They're getting third party. I don't know how to get this guy.
Opponent wiped out.
Got an enhanced weapon. Ready to use it.
I'm healing. Navigate. Get full gas.
Dog's coming to you. Round 2. Beginning ring countdown. No time to be tired.
Pick it up. Next ring start.
Replicators being delivered.
Replicators coming down.
Track it out.
Navigate. Get full gas.
Recharging my shield. Target spotted. Listen up. The ring be closing in 1 minute. "45 seconds. Ring's close."
Opponent in sight. Far off.
Might be something good that way.
I've enhanced my weapon.
Shooting!
Out. Enemy locations are on your map. Stick with me.
10 seconds and the ring closes. Keep going.
There's a mark out there in the distance. Found an enemy out there. Andiamo. Get in the ring. Roll outside.
Opponent wiped out.
Doc, you're coming with me. Enemy taken out.
Opponent hit. Reloading.
They're flying over.
Do not stop. Use this nitro gauge. Moving here.
Already flashed.
Frag out. Using a phoenix.
Competitor down.
Got one right here.
Move there.
Opponent here. Guns up.
On your feet. Lads, got your back. Round 3. Beginning ring countdown.
Enemy track.
Listen up, I'm getting shot at. Fire it.
Attention. Delivering replicator.
Replicator dropping in. Sending out the tracker now. Have to scan the track.
Let's go this way.
1 minute. Rings far. Keep going. Did I tell you to die? Get off your knees.
Just a screen. 1 second.
Enemy
Watch out,
shield
watch
is kaput. 45 seconds to get to the ring. It will be a long hunt. The horse. We've got it. I'm down. Repeat, I am down.
Broke their shield now. Enemy down. On your feet. Left lands. Target over there.
Grenade.
That's by the right. We're gonna get this. The enemy shield is broken.
Go. Reloading.
The enemy shield is
Down. Refueling my shields.
Hey, the ring is moving and we're all outside. That's not great.
Use the nitro gate.
Gotta get something.
Dog, stay with me. And keep the healing coming.
Do not stop. Use the nitro gate.
This is what happens when you're not focused.
resource, and then for that user ID, we get all of their tweets. Taking a deeper look at this endpoint, you can see, of course, it's a get endpoint. So that means if there are parameters that we want to pass into this endpoint, we can't do that in the request body. We have to do it in the URL. So scrolling down, you can see that we have that single path parameter. This is the ID, but it's a user ID. And the other parameters are query parameters like we talked about. And we sort of talked about limiting the number of tweets that we see. We can see that there's a similar query parameter for that called max results. You can kind of read the description here. It looks like by default, it will display 10 tweets at the maximum if we don't specify any max results, because this is optional. We don't have to specify. And we talked about having an offset for keeping track of where we are. Like we've seen 10 tweets so far. Now we need 10 more, something like that. Instead of using offset, in the real world, it's more common to have a pagination token. This token would be returned by the first request, and it would basically keep track of how many tweets we've already seen. So we would take this pagination token and then pass it into the next request, and then we would get another new token in response. We just keep using the most recent token to get more and more tweets. So we definitely covered a lot so far. I definitely want to encourage you to take a look at some of your favorite websites and take a look at their public APIs if they have any. Most social media sites have some. I think Twitter's is relatively simple, so I wanted to start with this API, but there's actually other APIs like this. Here is the Stripe API. It's very, very good documentation-wise. I think these docs are easier to navigate and read because they're just more put together, but since Stripe is related to payments, it's not something that's easily as understandable as tweets, something that most people are familiar with, like a social media site. You have a lot of things like payment intents and things that you might not immediately understand unless you've actually used Stripe before, but there's some pretty cool things that you can learn. I definitely recommend, reading through some public API docs. Like here, you can see something cool that Stripe did is they have these really large objects. This is a payment intent object. There's a lot of information, and a payment intent is associated with a customer. So what Stripe does, it makes this customer field expandable. What that means is by default, this payment object will return some customer ID, but that customer ID could be expandable. That means when we make that request, we can basically choose to expand the customer object. That means instead of getting the customer ID, we would get the entire customer object. But if we don't need that, we shouldn't expand this. So this kind of gives us similar control that GraphQL does. We can choose multiple resources that we want, or we can choose to not include resources that we don't need. So while we covered a lot, we really only scratched the surface with API design, but I think this definitely gives you a really good foundation of what you should focus on. You want things to be backwards compatible, you want endpoints to be clearly defined, and you don't want endpoints to conflict with each other. You want to provide pagination. These are really the core basics that you should have a good understanding of. Okay, so now let's talk about caching, which is a very, very important concept at all levels of software development. We already talked about how in a single computer we have our CPU, and our CPU reads and writes from our RAM, which is definitely faster than reading and writing from disk. The downside, of course, is that RAM is not persisted, disk is persisted, and of course our
My weapon is enhanced.
Transmit complete.
I'm out of energy. Charging shield.
That enemy shield is broken.
I'm down.
CPU can read and write from its own cache, and that's the fastest. Our CPU can read and write from the cache much faster than it can read and write from RAM. The downside is that our cache can't store a ton of data. It can't store as much data as our RAM can, but it's a lot faster. So this is one example in a single computer, but caching is also used in distributed systems where we have lots of computers. But at its core, caching is essentially this. It's essentially taking a copy of data, which may already exist in RAM, for example. That data is here, but we also copy that data and put a subset of it in our cache because it's faster. We want to lower latency and we want to increase throughput because if it's faster to read and write from the cache, that means we can write more data, we can read more data at a much faster rate than we could with RAM and disk. And also when we're talking about, multiple computers over a network, we can decrease the network cost because we'll be sending less data over, shorter distances. We'll take a look at a few examples of how that's done. So now let's actually take a quick look at neatcode.io and back to our handy dandy network tab. I'm going to show you something pretty cool. So here I've searched for main. We could, undo that. And what I'm going to do is refresh and I'm going to type in main because that's going to filter out the stuff we don't care about. And it's going to leave us here with some JavaScript. I click it. You can see that this is, neatcode.io/main blah, blah, blah.js. So this is actually a JavaScript file that's running in your browser. So this JavaScript file is, the code that I wrote. It gets bundled into a single file. And that's what kind of controls the functionality. Like if I, click sign in over here, it opens up that dialog. I click cancel, it closes it. That's part of what this JavaScript does. Now, the thing about it is that this is static content. What that means is it's going to be the same, unless of course I make some code changes to the site. This JavaScript is going to be the same time. Like if I refresh this, we're getting the exact same JavaScript file here. We're getting the exact same thing. It does not change. If I look at the response, you can see, it's a bunch of JavaScript code. It's not super readable because it's been bundled and all that, but it stays the exact same. We could look at it 100 times, it stays the exact same. So this would be a good use for caching. Since this JavaScript is not changing, we could cache it. We don't have to make an HTTP request like this to get that JavaScript every single time. So actually what our browser could do is we could cache this on our computer so that every time we load neatcode.io, we don't have to make a network call to load this JavaScript. It'll automatically be saved to our computer. And that's exactly what's going on actually, because here you can see when I made that request, what was the size of the request? Well, it was cached. It's this cache. We didn't have to send any data over the network because this was cached. Now I'm going to do in the browser over here, I'm going to click disable cache in the top left over here. So with the cache disabled, now I'm going to refresh one more time and we're going to see what happens. Here you can see it took 265 kilobytes of data. It looks like it took about 0.1 seconds, so not super long, but kilobytes of data. What happens here? You can see, now I'm going to refresh one more time and we're going to see what happens. Here you can see it took 265 in the top left over here. So here you can see it took 265 kilobytes of data. It looks like it took about 0.1 seconds, so not super long, but now I'm going to uncheck disable cache and we're going to refresh one more time. And now you can see that this data was cached. It's already in our cache. Scrolling down, what sort of allows this is actually an HTTP header.
Round 1. Beginning ring countdown. Got an enhanced weapon? And a smile on my face.
Ready to use it. Who got first blood? I was sure it would be me.
Ring is close, and we have a minute to reach it.
Attention. There is a new kill leader.
New kill leader. I don't know. Sounds like too much pressure for them.
45 seconds. You could call it to the ring, but don't degrade yourself.
Sending out the tracker dart. The ring is near. I'm closing in 30. Amici.
I can use that.
Pillows, baby.
Optics here.
Ring closing in 10. It's close. We can cruise over here. We're outside the ring. Move, unless you want to get barbecued.
My weapon is enhanced.
New kill leader appointed.
Someone is a new kill leader. Gebt Vollgas.
Care package being delivered.
We will not let off the gas.
Care package coming down. Attention. There is a new kill leader. Attention. The champion has been eliminated.
The champion is out? Do they give this title to just anyone?
Weapons enhanced. No.
Syringe here. Optics here. Sniper.
Got a lock on our enemy's position.
Care
On your
package
map.
there.
Opening fire. I'm recharging my shield.
Competitor down. Ciao, ciao. Took out a competitor. A nitro gate. Give Vollgas. Hier ist kaputt.
They're shooting at me.
Watching
Only half
over
the
there.
squads are left.
He's a nitro gate. Pick up the pace.
I added the enemy's positions to your map. Non c'è di che. Hey, thanks.
Fox 3, I got radar lock.
Amps here. Bottomless batteries.
Alert 5, Valkyrie on station. We are go for burn.
Bro.
Main engine burn.
So slow. Use this nitro gate. Devotion here.
Reloading.
Nitro gate down. Speed up.
Fox 3, launching missiles.
Ah, we're all over the
Got
map.
another bandit. Nobody panic, but we got bandits out there.
So slow. Use this nitro gate.
Tracker in place. Tracking an enemy.
Reloading. Enemy shield is kaputt.
I tracked him.
Feierabend. The whole squad is out.
Nice kill. Niente male.
Placing a nitro gate. We will not let off the gas.
Kill leader eliminated. Round 2, beginning ring countdown.
Keep this way.
Replicating.
Now stop. Use this nitro gate. Got a replicator incoming.
Got a bogey on my marker. Attention. There is a new kill
Tracking
leader.
an enemy.
Champion eliminated.
Ah, there's a new kill leader. Huh. For now. Tracker set. I'm ready
Almost broken. He's living.
I'm here, so let's get you a do-over, huh?
Charging shields.
Recharging my shield. Cover. Bullseye. Killed an opponent. Opponent right here.
Let's go here. It's broken. Cracked shields on that bandit.
I'm recharging.
Crashing and burning over here.
Shield is kaput. Shield is kaput.
Nice. Tieni duro. Chucking an arc star.
Charging shields. You have to survive to get to the after party. Duck it's up.
Their enemy shield is broken. Took out an enemy. Who's next?
Charging up my shields.
Tracker in place. Let's target down. That squad is permanently benched.
Shield battery here. Extended energy mag here. Gold tier.
Dibs. Got a bandit close by.
So slow. Use this nitro gate.
Let's scope this quadrant. Alert 5, Valkyrie actual. Ready for burn. How copy?
Uh-huh. Found an enemy out there.
Burn is good.
Oh, a lot of teams.
Competitor spotted there.
They're right.
Charging up my shields. Replicator being delivered. Replicator on its way down.
Bullseye. Enemy hit.
Reloading.
Reloading.
Ring is close, and we have a minute to reach it.
Evo cash here.
Head that way.
Charging up my shields.
Tracker set. Ready to gather intel. Opponent found and back. Figure it out. Attenzione. Enemy here. Near ring with 45 to close. Una passeggiata. Enemy tracked. Enemy third party arrived. They're gonna regret this. Firing stinger.
The ring's close, and it's a good thing. Only have cracked shields.
Recharging my shields. Cover me.
Slow ground.
Tracker out. That enemy. Whoop. Getting shot at.
Cracked a bogey's shield. Cracked shields on that bandit.
10 seconds until the ring closes. It's close though.
Let's go ring.
Time to let this stinger do the hunting. Opponent found.
The ring is moving. Let's not get caught outside with the pedestrians.
Charging on my shields.
Left on my left.
Chucking a thermite grenade.
Oh, you're all right.
Cracked a bogey's shield.
Got this.
minutes left. So we've got our second and third places.
Hey, replicator, incoming.
Hold on.
Pick up space.
Take your time. The ring is close and there's a whole minute to play.
Need light ammo. Alert 5. Valkyrie on standby, ready for burn. Dibs.
Perfetto. I need energy ammo.
Care package there. I see a competitor.
Crafting, un momento, per favore.
Alert 5. Valkyrie on station, we are go for burn.
We're near the ring, but only 30 seconds left to get inside.
A final challenge
Fox 3
has
launching
our
missile.
Let's shake them off and take the win. Opponent wiped out.
This guy's up there.
Setting a tracker. Un momento, per favore.
Super low. Oh shit.
You are the Apex champions.
I don't think we talked about this because, there's so many headers, but there's a header for caching. It's called cache control. It can have multiple values, but in this case, it says max age 3600. That basically means that this JavaScript can be cached for at most 60 minutes or aka 3600 seconds. So when we're requesting this JavaScript, we're not making a network request. It takes 8 milliseconds because we're reading from disk. Now, if I disable the cache, of course, and refresh it, it takes longer. It takes 123 milliseconds because we actually had to make a network call. And taking one last look at the HTTP headers, you can actually see that in the response header, there was actually a cache hit. That means that when we looked in our cache for this data already existed in our cache. Okay, so now let's go back to the drawing board and sort of summarize what we talked about and expand a bit upon it. From the perspective of our client, we have our own disk. It's a part of our computer. It's not like a separate database or anything, but we have our own disk storage. We have a persistent storage for our computer. In this case, our disk is actually our cache. Now, we kind of already talked about at the beginning, disk is slower than RAM, which is slower than the CPU cache. So why would we use disk if it's
So this is my outfit.
the slowest of all of them? Well, disk is still much faster than sending data over a network. Sending data over a network takes in the order of 0.1 second up to multiple seconds, like 3 seconds. But reading a disk, especially if it's a small amount of data, is much faster, on the order of milliseconds, as we saw earlier. So what's happening here is we're sending a request to the server, and then we get some JavaScript back. It could be JavaScript, it could be HTML, it could be CSS, it could be some kind of content that's not changing. That's very important. It has to be static content. And then when we retrieve that JavaScript, the client throws it into the cache, and then before the client makes another request for the same data, it's going to check the cache. Does the data already exist? Yes, it does, and it hasn't expired yet. So if it does exist, that's called a cache hit. That means we looked in the cache and the copy of the data was already there. The opposite is a cache miss. I'm sure you can kind of guess what that is. We look in our cache, but that data is not there. Or maybe it's expired. The data is stale. That means the data, the max age of the data would have already expired. So if the data is stale, then we would have to send another request. That would be a cache miss. We'd send another request to the origin server, and then when we get the data back, we throw that data into our disk and save it for later. Now, there's also the concept of a cache ratio. That's basically the total number of hits divided by the number of hits plus the number of misses. So basically, what percentage of our cache reads are actual hits? Like how many times do we look in the cache and actually find what we need? Obviously, we prefer the cache ratio to be higher rather than lower. Now, this is just one example of caching. There are many others. We pretty much try to use caching wherever we possibly can because it speeds things up a lot. It's a pretty simple strategy that can be really powerful, but things can get more complex. Let's take a look at another example. We saw an example of caching from the client's perspective, but what about the server's perspective? If we have a massive amount of data, let's take Twitter, for example. Like every time we create a tweet, our server is going to take it and throw it into a database. So we haven't talked a lot about databases, but for now, let's assume that our database is implemented with disk because that's usually the case. Data for a database is stored on disk, but we're also going to have some type of key value store that's implemented on top of memory. Something like Redis. I know we haven't talked about databases or Redis yet, but Redis is pretty commonly used for caching. It's sort of like a database, but it's implemented with memory. And of course, we know that memory is much faster than disk, but it's not persisted like disk is. And typically, we can't store as much data in memory. So we have this use case of we're going to create tweets, which are going to be stored on disk. And then when a user wants to list some tweets or read an individual tweet, possibly by tweet ID, just to keep things simple, let's say we're getting a tweet by tweet ID. Now, our server, what's it going to do? It wants to do things as
Jumpmaster here. Ah! Yelling is good for focus.
That's an enemy landing nearby. Got to keep an eye on them.
They're shooting at me.
quickly as possible, but there are a lot of tweets. So we could search the database for that particular tweet and then return it. Now that's, the most basic way to do it, but that's pretty slow. We can add caching to this backend solution. We can use a in-memory store like Redis, where what we do is take a subset of the data. So in this case, what our server would try to do is it would first check the in-memory store. Does that tweet exist in the in-memory store? Nope, it doesn't. So then we have a cache miss, but that's okay, because now what we're going to do is read from disk. We're going to get that particular tweet. We're going to return the tweet to the user, but now we're also going to store that tweet in memory. So now the next time somebody asks for that same tweet, we're going to look again. We're going to check memory. We're going to see it's there. That's a cache hit. And presumably people are going to go on Twitter, but not every single tweet needs to be read. I mean, the vast majority of tweets probably aren't read by people. And I'm not just talking about my tweets, but there probably are a smaller number, a small subset of the tweets stored on disk, maybe.
A python, and as you see, he won't bite because he can't eat me, and he doesn't.
Put this on.
No, what are you doing? Use all this.
Don't argue with me, goddammit. Just
maybe by Ariana Grande or somebody like that, really popular tweets, and that subset of tweets can probably fit in memory, or at least a portion of them can. These are the tweets that a lot of people are going to be reading, so a lot of requests are going to come to our server to read that small subset of really, really popular tweets. So even though our in-memory cache is much smaller than our disk, since the vast majority of people read that small portion of really popular tweets, this actually speeds up our server's performance a lot, and also increases our throughput. Maybe reading from disk, we can only read like 1,000 or maybe 10,000 reads per second from disk, but from memory, we can do a lot more, typically 100,000 reads per second from memory. So this is much faster and much more powerful. This can scale much higher. Now, this isn't the complete picture because there's actually several different algorithms we can use in caching that can accomplish different things. First of all, this simple caching strategy that we talked about is actually called write around. So write around caching is basically when we write to our storage, like writing to our server, we actually skip the cache entirely. We just write the data to our primary storage. We skip the cache and write to storage, in this case disk. And then when we want to read, we will make some read request. We'll check our cache. Data's not there initially, right? So we expect there to be a cache miss the first time we try to read some data, and then we'll find it on disk, throw it in the cache, and return it to the user. That's very basic. It's write around cache. It guarantees that there's going to be a significant number of cache misses, but at the same time, we're not going to put anything in the cache unless it's actually being read, because we know there's going to be millions of people creating tweets. We definitely don't need to put a tweet in memory every time it's created, because like I said, the vast majority of tweets, mine included, don't really get a lot of people seeing them. Another caching strategy is write through cache, where we're creating some resource like a tweet, we immediately write it to the cache, and after that we write it to the primary storage like disk in this case. This is even more simple, but it probably depends on the application if we actually want everything to be cached when it's initially created.
First blood. Should have seen that coming. Round one. Beginning.
Good news. We're already in the next ring.
We will not let off the gas.
Barrel stabilizer here. Level 1.
Harvesters are now available.
I've enhanced my weapon.
Shotgun bolt here. Level 3.
New kill leader. Watch for them. Backpack here. Level 3. Oh, dibs.
Going. Follow me there. Los geht's. Don't make me drag you.
In progress. Extended light mag here. Level 2.
Let's go over there.
Heard that.
See.
Reloading. Refueling my shields. Incoming care package. Let's see who gets there first.
Care package over there.
Smash an opponent's shield. Charging shields. Shield is kaput. Reloading.
Frag out.
Tracker out and scanning for enemies. Tracking an enemy. Let the ambush begin.
Arcstar out. Achtung, grenade.
5 HP on.
Frag out.
Charging shields.
I'm coming down. I'm leaving.
One second, we got this.
Okay.
Positions to your map.
I leveled up.
Recharging my shield.
Choosing an upgrade is the only choice. This upgrade feels good.
Opening fire.
Almost broken.
Should find more.
Oh shit. Never mind, you guys over there.
Oh, they're shooting at me. Opening fire. The enemy shield is broken. I'm down.
Seven hands
Oh.
open.
Yeah, he's healing right now. It's only one. And he's pushing.
Frag out.
Repeat, I am down.
Perhaps the better choice for you might have been a wee deal.
And we have another strategy called right back caching, which is sort of a much faster way of doing things when possible, but it can be less reliable and cause some inconsistency. It's a pretty lazy way of doing things. In this example, when we create a tweet, we would throw it into memory. So that would be fast. We would put it in our cache and we would actually skip the disk. So just creating a tweet would be very, very quick. And then we could, respond to the user. Okay, we're done. We didn't even have to, do anything with disk. And the next time somebody reads that tweet, we immediately go to our cache. It's there and then return it. So this is really, really simple. It's basically ignoring the existence of our disk. I wish we could do that, but we can't because we have disk for a reason. It's for persistent storage. So what would happen if our server crashed? Then all the data here would not have been written to disk. So what we do is a sort of lazy way. We take the data and periodically dump it to the disk. So we'll take all the data that was recently written to our cache and then copy it to the disk periodically. This can be fine if you're fine with some amount of data lost, but you probably wouldn't want to do this with Twitter because, let's say you create a bunch of tweets, they're in memory and the server crashes. Well, they never got saved to disk, so we would lose those tweets permanently. We don't want this to happen, so we probably wouldn't use right back caching in this scenario, but there are cases where losing some small amount of data won't be the end of the world. Maybe when it comes to liking and disliking tweets, maybe that's, not as important, so we can use caching for that and make things go a lot faster. We can use right back caching. So this is a very fast strategy, but, it won't work in all cases. It depends on your use case. You have to look at the design of the application. What kind of data loss are you willing to tolerate? Okay, so now let's talk about eviction policies. We need eviction policies policies because, like I said, our memory or our cache is limited in size. We can't store, an infinite amount of data in our cache. So sometimes we reach the limit. Like we fill up our cache. In this example, at least, we filled up our cache, but we want to read some tweet. So we check our cache. The data is not there. Then we check disk. We find the tweet. So then we return it to the user, and then we also write that tweet to memory. But since our cache is full, we have to decide what piece of the cache, what data in the cache are we going to remove? Are we going to remove this portion of the cache? Are we going to remove this portion? Another portion? We have to decide, and we can do it randomly, sure, but probably there are some more intelligent ways of doing things to maximize the cache hit ratio, right? That's what we want to do. We want every request, if possible, to have been cached. We want to never read from disk if we don't have to. Well, there's many different eviction policies to choose from. I'll quickly go over some of the most popular ones. I mean, of course, there's random, usually not the smartest. There is another very simple one called FIFO. You're probably familiar with this if you're familiar with the concept of queues or, those types of data structures. FIFO is first in, first out. So just like a line, like the data that was added to the cache, we added, one piece of data, another piece of data, and more. These have an order that they were added in. And when it's time, like let's say this is our cache and we filled up the cache, we have to choose what to remove. We're going to remove the first one that was added and then add a new piece to the end of it. And we would continuously remove just like that. If we had to remove again, we just remove from the beginning. First in, first out. What was first added to the cache is going to be the first one that gets removed. Now, this probably wouldn't be really useful for Twitter if, the first tweet added was made by, some really popular celebrity, and that tweet is being read by hundreds of thousands of people just because it was the first one added.
Start your engines. Let's go over there. Refueling my shields.
Oh, man.
Spotted. Double timing it. We're inside the ring. Got the position on.
Just run, John. Just run.
Bogey in my crosshairs.
to the cache doesn't mean it should be removed if people are still wanting to read that tweet. So there are better ways than FIFO. A couple of them are called LRU and LFU. So LRU stands for least recently used. So going back to our example, let's say we're adding a few things to our cache. We add 1, 2, 3, and now let's say our cache is full. So which one are we going to remove? Well, it's pretty similar to FIFO, first in, first out, but instead we're going to be removing the one that was least recently used. Let's say that this one was added first, and then this one was added second, and this one was added third, and then none of them were read after that. So this is the order that they were read in as well. So which one of these would we want to remove? Well, this one was the one that was least recently read, so we would remove this one. But let's assume that these are the order that they were added in, but then somebody makes a request to read a tweet, and let's say this is the tweet that they want to read. So what we would do is move this to the end over here. So now this one is the most recently used. So now if we're adding another tweet, let's say we're creating a tweet, we're adding a fourth one here, which one of these are we going to remove? The one that was least recently read, and that's going to be the one all the way at the right. So, we remove this one. So it's a pretty simple algorithm conceptually. In our previous example, where if we had like a really, really popular tweet that's being read a lot, so let's say this is that tweet. So if this tweet is being read a lot, it's going to keep getting pushed to the end over here, meaning it was recently read. So then we're never going to remove from this side. We'd only remove from the beginning the ones that were least recently used. So LRU would definitely be better if there was a single person with a really, really popular tweet. We don't want that tweet to leave our cache. So LRU would be helpful for that. Now there's another popular algorithm called LFU. This is least frequently used. So in that case, you can kind of think of it as a bunch of key value pairs. So our key is going to be, the tweet itself, and then the value of that tweet is going to be the number of times that tweet was read. So how frequently was it used? So, maybe tweet X was used 10 times, tweet Y was used 4 times, and tweet Z was used 12 times. And now maybe we're adding a fourth tweet. So now let's say we want to add tweet A, and initially its read count is going to be 0. That's perfectly fine, but we only have 3 spots, but we have 4 tweets now. So before we actually add this to our cache, we would remove one of these 3. Which one are we going to remove? Well, with LFU, we're going to take the one that's least frequently used. So the one with the smallest count is Y, so we remove Y. This wouldn't be a bad algorithm for Twitter either, actually, because the most popular tweets are going to stay in the cache, but we still allow new tweets that are possibly less popular to be added to the cache. And if those tweets, are read a lot, they will increase in their frequent count, and therefore they won't be evicted. But if this tweet was never read by anybody, it would be the first one that we evict if we wanted to add another tweet to the cache. But overall, I think in Twitter's case, we would probably prefer LRU cache because there could be some really, really popular tweets like this one that has a really, really high frequently used count, but maybe it stopped. Like maybe this was a really popular tweet from a celebrity a year ago and it reached a really, really high cache hit count. But after a while, like maybe after a week or something, nobody really read that tweet again. Well, with LFU, it would stay in our cache because the used count, the cache hit count is so high. So with LFU, we don't even care how recently was this used. We just care about the total count. So probably in Twitter, since tweets get old and people don't read old tweets a lot, we would probably prefer LRU in this case. So while there are a lot of details when it comes to caching, there's so many different implementations of it. At the core, it's pretty simple conceptually. We're trying to speed things up and we're willing to make some trade-offs to achieve that. We're willing to sacrifice some consistency. And while we covered a lot today, we're actually not done with caching. We're going to continue to be discussing it because it's such an important topic.
Nice.
First blood. The race is on now.
This weapon is somehow even more beautiful than before.
Round 1. Beginning ring countdown.
We're all inside the ring. Good.
New kill leader appointed.
Shooting. Reloading.
Kill leader eliminated. Attention. Evo harvesters are online.
Incredible. And I get to keep this after the game, no?
Follow me there. Don't make me drag you.
I could use that.
Champion eliminated. We're already in the next ring. Don't get eyes on an enemy here.
Hostile spotted. Shooting.
Getting shot at. That enemy shield is broken. Grenade. Took out an enemy. I broke an opponent's shield.
Reloading. Incoming care package. Let's see who gets there first.
Upgraded and ready to fight to the death.
Care package over there. Care package over there.
Just giving my shields a recharge.
I'm recharging my shields. Survey beacon there. You can get almost as much intel as I give you.
Here's an aggregate. Pick up the pace. My weapon is in hand.
Tracker dart out.
Kill leader appointed.
Tracker set and ready to gather intel.
New kill leader. Eyes out for him. Of the squads left.
Second place. Enemy locations are on your map. Let's go see what's up over there.
Competitor in sight. Over there.
Extra supplies here. Firepower is key.
Enemy sighted far.
We should scout that area.
Enemy sighted far. Competitor in sight. Over there. Reloading.
shield.
Here's a nitro gauge. Pick up the pace. Opponent here. Competitor spotted there.
Oh, they're shooting at me. I'm recharging my shields.
Enemy way off.
They're gonna regret this. Opponent's shield. Reloading. Shield is broken. I'm recharging my shields.
Renting sucks.
Opponent here.
Tracker out and scanning for enemies.
Firing.
Boom! Tracker set.
Ultimate accelerant here.
Round 2. Beginning ring countdown.
Fighting. Reloading.
Replicator.
I'm spotted. Taking fire.
Che bello. I'm an upgraded sparrow.
Just giving my shields a recharge.
They're shooting at me. Recharging my shields. Cover me.
Do not stop. Use this nitro gauge.
Recharging my shields. Cover me. Setting a tracker. They're shooting at me. Oh, I'm down. Nobody look.
Taking damage. Tossing down my halo.
On your feet. Lapland's got your back.
We're already in the ring. Time for a break. Reloading.
I'm down. Nobody look.
On your feet. Lapland's got your back.
I'm getting shot at. Looks like it's
Tracker scanning.
coming in. Big things in that.
Watch. Opponent there.
Competitor spotted there. Taking fire. Reloading.
Tracker out. A tra poco.
Recharging my shields. Listen up, I'm getting shot at. Up and down. Did I tell you to die? Get off your knees. You follow them now, alright? Recharging my shields.
Setting a tracker. We should avoid that zone.
Do not stop. Use this nitro gauge. Let's kickstart this fight. Eyes up, shield. Ring is close, and we have a minute to reach it.
Sending out a tracker dart.
Target spotted. 45 seconds. You could call to the ring, but don't degrade yourself.
Setting a tracker.
Competitor in sight, over there. Sunday down.
We're near the ring, but only 30 seconds left to get inside. Reloading.
Opponent at a distance. Delivering Arkstar.
Un momento. We gotta heal.
I'm getting shot at. So slow. Use this nitro gauge.
The ring is moving and we're all outside. It's not great.
Buffing out damage. You hear that? There's a care package coming down. Care package over there. Opponent there.
Tracker scanning.
Buffing out damage.
Oh, we should scout that area. Reload. Oh, they're shooting at me. I'm recharging my shields.
Care package over there.
I'm down. Nobody look.
Enemy shield is kaput.
Too slow, too weak. Whatever the case, I got you.
So now let's talk about content delivery networks, or CDNs for short. CDNs are a way that we can cache data close
써야 되나? 적을
이게
전장의 지배자.
뭐야? 힐 감사합니다. 템이 왜 이렇게 됐지? 이거 봐요.
아군 당했습니다.
아무도 아이? 진짜 이게 아닌가 그래요? 뭐야? 다행이다 진짜. 인내가 붙잡았습니다. 하나 없어. 인생 폈다. 배틀린. 이거다. 와, 뭐야, 인생. 뭐야. 이거 한테 먹네. 뭐야, 이거.
뵙겠습니다, 여러분들. 반갑습니다. 안녕히 계세요.
Ranking best cosplays transitions.
Mummy, will you quit calling me Mummy? Oh.
Ranking best cosplays transition.
I missed. Yeah, I made a grave mistake, and I'm so sorry about that. We can still be friends, no?
Yeah, I'm just here for the quest. I'm looking for the medical room.
Oh, all right, right over here.
Oh, hell yeah, thanks, man.
No problem. I'm gonna be honest. I was gonna kill you after I missed the first bullet. I got really nervous, and I would love to be friends. I think it's right over here somewhere, like in here, maybe along the. Oh, you liar! You liar!
3 big balls. Look like we playing tennis. You got a big.
Hey, I need that Bettina. I'm coming for you, bro. Lock in. I'm coming. Wait a second. Gotta put the music on. All right, guys, lock in. I'm coming in. I'm coming in hot. To the next. All right. Lock in. I'm here now. I'm here. To the next. Let's go. Let's go. That's the 360 there. Yeah. Look at this. Oh. Hey, I need that Bettina. I'm coming for you.
Anime imposter. For my first word, I'm gonna say box. Bang.
Already know who it is. I'm gonna say growth.
I like that.
It's important to build your character. I'm gonna go extremely niche from now on, so you don't get the word.
Me too. I like that idea.
I'll say weapon.
Sure. That works in a way that I don't see. For my second word, I'm gonna say family. Now, I want you to not contradict anything that I'm saying, because then it gives it away.
Not contradict?
So, like, don't give, like, the clues that lead to this character. This might just be unfair, though.
I'm gonna say mix. I'm gonna say 6.
Works? It actually does work.
You don't?
Like, I'm being serious. It actually does work.
You don't get it?
For my last word, I'm gonna say axe.
I'm gonna go field.
That is such a good one. It's niche. But like, if you know the character, you get it instantly. You get it.
I'm gonna say fade.
For the cut? Or the...
Sure, both. Sure, honestly.
Guys, listen. Great round. Everybody's words, fantastic. But
I'm ready to vote.
I'm ready to vote as well.
Do you have anything to say? Whoa.
We're gonna drag out the video.
What was your first word?
Bro, really?
My first word was growth.
You just want to figure it out.
Oh my god.
But we know
vote for
it's
me.
you.
Vote for me.
Okay, this technique won't work. 3, 2, 1.
It was me.
You could actually get it with the guesses we gave.
I don't know the word. Gojo.
No, it's Nezuko.
GG's.
Anime imposter. For my first word, I'm gonna say box. Bang.
Already know who it is. I'm gonna say growth.
I like that.
It's important to build your character. I'm gonna go extremely niche from now on, so you don't get the word.
Me too. I like that idea.
I'll say weapon.
Sure. That works in a way that I don't see. For my second word, I'm gonna say family. Now, I want you to not contradict anything that I'm saying, because then it gives it away.
Not contradict?
So, like, don't give, like, the clues that lead to this character. This might just be unfair, though.
I'm gonna say mix. I'm gonna say 6.
Works? It actually does work.
You don't?
Like, I'm being serious. It actually does work.
You don't get it?
For my last word, I'm gonna say axe.
I'm gonna go field.
That is such a good one. It's niche. But like, if you know the character, you get it instantly. You get it.
I'm gonna say fade.
For the cut? Or the...
Sure, both.
Sure.
Honestly.
Guys, listen. Great round. Everybody's words, fantastic. But
I'm ready to vote.
I'm ready to vote as well.
Do you have anything to say?
Whoa. We're gonna drag out the video.
What was your first word?
Bro, really?
My first word was growth.
You just want to figure it out.
Oh my god.
But we know
vote for
it's
me.
you.
Vote for me.
Okay, this technique won't work. 3, 2, 1.
It was me.
You could actually get it with the guesses we gave.
I don't know the word. Gojo.
No, it's Nezuko.
GG's.
Anime imposter. For my first word, I'm gonna say box. Bang.
Already know who it is. I'm gonna say growth.
I like that.
It's important to build your character. I'm gonna go extremely niche from now on, so you don't get the word.
Me too. I like that idea.
I'll say weapon.
Sure. that works in a way that I don't see. For my second word, I'm gonna say family. Now I want you to not contradict anything that I'm saying, because then it gives it away.
Not contradict?
So like, don't give like the clues that lead to this character. This might be unfair though.
I'm gonna say mix. I'm gonna say 6.
Works? It actually does work.
You don't?
Like I'm being serious. It actually does work.
You don't get it?
For my last word, I'm gonna say axe.
I'm gonna go field.
That is such a good one. It's niche. But like, if you know the character, you get it instantly. You get it.
I'm gonna say fade.
For the cut? Or the...
Sure, both.
Sure.
Honestly.
Guys, listen. Great round. Everybody's words, fantastic. But
I'm ready to vote.
I'm ready to vote as well.
Do you have anything to say? Whoa.
We're gonna drag out the video.
What was your first word?
Bro, really?
My first word was growth.
You just want to figure it out.
Oh my god. Go.
But we know
for
it's
me.
you.
Vote for me.
Okay, this technique won't work. 3, 2, 1.
It was me.
You could actually get it with the guesses we gave.
I don't know the word. Gojo.
No, it's Nezuko.
GG's.
Anime imposter. For my first word, I'm gonna say box. Bang.
Already know who it is. I'm gonna say growth.
I like that.
It's
I like
important
that.
to build your character. I'm gonna go extremely niche from now on, so you don't get the word.
Me too. Me too. I like that idea.
I'll say weapon.
Sure. That works in a way that I don't see. For my second word, I'm gonna say family. Now I want you to not contradict anything that I'm saying, because then it gives it away.
Not contradict?
So like, don't give like the clues that lead to this character. This might be unfair though.
I'm gonna say mix. I'm gonna say 6.
Works? It actually does work.
You don't?
Like I'm being serious. It actually does work.
You don't get it?
For my last word, I'm gonna say axe.
I'm gonna go field.
That is such a good one. It's niche. But like, if you know the character, you get it instantly. You get it.
I'm gonna say fade.
For the cut? Or the...
Sure, both.
Sure.
Honestly.
Guys, listen. Great round. Everybody's words, fantastic. But
I'm ready to vote.
I'm ready to vote as well.
Do you have anything to say?
Whoa. We're gonna drag out the video.
What was your first word?
Bro, really?
My first word was growth.
You just want to figure it out.
Oh my god. Go.
But we know
Vote for
it's
me.
you.
Vote for me.
Okay, this technique won't work. 3, 2, 1.
It was me.
You could actually get it with the guesses we gave.
I don't know the word. Gojo.
No, it's Nezuko.
GG's.
Anime imposter. For my first word, I'm gonna say box. Bang.
Already know who it is. I'm gonna say growth.
I like that.
It's
I like
important
that.
to build your character. I'm gonna go extremely niche from now on, so you don't get the word.
Me too. Me too. I like that idea.
I'll say weapon.
Sure. That works in a way that I don't see. For my second word, I'm gonna say family. Now I want you to not contradict anything that I'm saying, because then it gives it away.
Not contradict?
So like, don't give like the clues that lead to this character. This might be unfair though.
I'm gonna say mix. I'm gonna say 6.
Works? It actually does work.
You don't?
Like I'm being serious. It actually does work.
You don't get it?
For my last word, I'm gonna say axe.
I'm gonna go field.
That is such a good one. It's niche. But like, if you know the character, you get it instantly. You get it.
I'm gonna say fade.
For the cut? Or the...
Sure, both.
Sure.
Honestly.
Guys, listen. Great round. Everybody's words, fantastic. But
I'm ready to vote.
I'm ready to vote as well.
Do you have anything to say?
We're gonna drag out the video.
What was your first word?
Bro, really?
My first word was growth.
You just want to figure it out.
Oh my god. Go.
But we know
vote for
it's
me.
you.
Vote for me.
Okay, this technique won't work. 3, 2, 1.
It was me.
You could actually get it with the guesses we gave.
I don't know the word. Go.
I'm gonna secretly live under my friend's base until he notices. And I'm gonna do it by using item frames and a map that looks like a wooden plank. But it's actually just glass underneath it. And I'm there watching his every move. I even made a secret tunnel to access it easily. There's no way he's gonna realize. Yo, what's going on? Oh, you're not at your base right now?
No.
Okay.
Are you there?
No, I'm
You
not
want me to meet you there?
No, it's okay. I was just
okay.
wondering. So did you get your base done like you said you were gonna get?
Oh, dude, yeah. My base is looking awesome right now. Have you seen it yet?
No, I haven't seen it. I just been at my base, man. Chilling at my base. You like anvils, bro?
All right. What?
I said I got an anvil, bro. I just made an anvil.
Oh, that was weird, dude. You said that right when I opened my anvil. I thought you were like here.
What the heck?
Dude, that scared the heck out of me. Dude, I need more levels to upgrade my armor. This is so annoying.
Yeah, bro. You like chest?
Okay, bro. Come on. You're at my base.
Bro, I said, do you want to play chess?
Do I want to play chess? Dude, you're not doing this again. I know what you said.
Dude, I literally...
I'm
No,
stupid,
wait.
bro.
I'm being serious, bro. I just said, do you want to play chess?
Bro, am I hearing things? There's no way. Dude, I
Bro,
could
I
have
just
sworn...
said, do you want to play chess?
Bro, I don't play chess, dude. I'll play poker.
Yeah, bro. I just got done enchanting all my stuff.
Dude, this is crazy. I'm literally enchanting right now.
You're enchanting, bro?
Yeah.
Go back.
Bro! What do you mean go back?
Bro, I said stupid cat. The cat jumped on my lap.
Okay, come on, bro. You are not. I swear to God, I'm gonna find you. You're somewhere invisible in here.
Okay, bro. I think you're just tripping
Behind
out.
a painting?
Bro, do you want proof that I'm not by your base, bro? I can literally
Yes,
fly.
Yeah,
Okay.
actually prove it, please.
Okay, I'm coming.
You got a screenshot?
What was? Did you hear that, bro?
Hear what? I didn't hear anything.
Wait, hold on. I'm on
I'm looking. I can see it from my window.
Bro, I'm climbing up the mountain right now.
Oh, hey.
What are you?
How's it going? Can you see what I'm doing through the window?
No, bro, you're going crazy. Okay, just I don't know what's wrong with you, bro.
Okay, I'm tripping. I must be tripping.
I'm gonna secretly live under my friend's base until he notices.
You've got to be kidding me.
What?
The third person in line, that is Todd Shelf.
You know him?
He's a serial bank robber.
Maybe he's just here to make a deposit.
No, he's here to rob this bank. I need you to say the word grout.
The bank is about to be robbed.
G-R-O-U-T.
Okay.
Gender, race, over, under, task. It's how to quickly describe suspects in a way that cops will understand. Try it on Todd.
Male, white, black jacket, dark pants, and his task is killing us.
Close enough. There by the door, number 2.
Also male, white, black jacket, gray pants, and taking out security.
Todd always runs a 3-man crew. There's someone I haven't made yet, but we are running out of time. Go outside and wait for the cavalry.
I'm not leaving you.
But you will, because you know that I have got this. I am Detective Nyla Harper. Your bank is about to be robbed. I need you to hit the silent alarm now.
Bank robbery! Everybody down! On the floor now! Cell phones on the ground! No! All right, no one moves, no one gets hurt.
Get down! Fill it. No die packs or you're dead.
Get out! Safe deposit room, now, come on. Come on!
Silent alarm now.
お前には世話になった。おかげで白眼の資格もその有効範囲も大いに修行させてもらった。
赤丸、あん時はすまなかったな。俺が弱えばっかりにお前を入院までさせちまって。ああ、分かってる。見せつけてやろうぜ、成長した俺たちの力を。
お前ら生きてる人間舐めすぎなんだよ。確かにお前らは不死の体とかもらって生きてた時より強くなってるのかもしれない。だけど俺たちはもっとすごいな。俺の
チャクラを塊で投げつけたのか。こんな術をし。なくはないはず。こいつはすでにお前ら。
And in this corner, weighing in at insert net. Do they have what it takes? Let's find out. Ring-a-ding-ding.
We've got another squad arriving.
How did they run away so fast when they've got cold feet?
Attention. First blood. Round 1. Countdown.
We need to get inside the ring.
There's two teams here.
Opponent's shield.
1 second, we got this.
Refueling my shields.
I saw a team win there too.
Healing.
I don't know if that's do y'all wanna like go now or do y'all wanna fight now? I bet.
Oh look, someone wandered into our safe space.
In progress.
We're already in the ring. Time for a break? Spaß. Shield is kaputt. They're shooting at me.
Wow, look who it is. It's you.
Charging up my shields.
Can anyone summon the
Package.
Charging up my shields.
Our squad mates stalled out. Stay close to me.
Wow. Look who it is. It's you. Can anyone summon the courage to face this contender?
There we are literally surrounded. What the fuck?
I need help.
Care package over there.
Challenger, ladies and gentlemen. We're in for a fight now.
Enhance my weapon. I have an upgrade to install. I've upgraded myself. Überraschung. We
Watch yourself. There's another squad attacking.
competitor down. Und tschüss.
Regroup there. Charging my shields.
I'm low on ammo. Should find more. I'm crafting. I got back our teammate's banner. Pick up the pace. Ammo reserve. Repeat, I am down.
Enemy shield broken.
Move there.
Void running.
I'm gonna pop up that and get you.
Setting a portal.
A competitor, look here.
Are you safe? Like, there are people everywhere, bro.
Replicator delivered.
Does enemy thinks they can heal here? I don't think so.
I downed an enemy. Getting shot at.
Catching myself up. Patching myself up. The ring's closing in one. We're not very close.
Yeah. 奴のらえないと意志は実体化する。急決まる。攻撃が。俺の勝ち。
神出鬼没とはまさ油断もすそうか他にマーキングを契約封印これからキュービを引き上がるこれでキュービは
closer to end users so that we don't have to make requests across the entire world. I just realized this picture with our client being so close to the origin server isn't good. I'm gonna move this. Okay, so now our client is over here. They're a little bit farther from the origin server, but they're still, I guess, floating in the water over here. Let's assume they're on cruise or something like that. Maybe not.
Phasing. Arcstar out. Patching myself up.
Dude, do you have any heroes?
Plane. Here you can see we have a bunch of servers distributed around the world. One of these is the origin server, and the rest of these are CDN servers. The idea, as I said, is to bring the content closer to the end user. So we might have all our servers in a single region in the world somewhere, but our users are probably all around the world. So we'd like for all our data to be as close to users all around the world as possible in every region.
Void jumping. You're being aimed at. Getting shot at. 45 seconds, rings close. Healing up. Eyes are open though. We're close to the ring. 30 seconds left. Need to recharge my shields. Arc star out. Thermite grenade out. 10 seconds. The ring's close.
Don't come here. I think both teams are. No, they're not.
Opening fire. Reloading. I've reached max level. Only one way left to go. Heads up. Care package coming in. Path's chosen. Got an idea where it leads.
Now here I've drawn it pretty simplified. We only have a single origin server and about 5 CDN servers. In reality, we could have hundreds or thousands of CDN servers all around the world. So they really should be pretty close to the end user, at least the majority of our end users. The downside though is that we can't put everything on CDN servers. CDN servers are pretty dumb. We can only put static content that is not changing. We can't have application code running on the CDN servers. There's sort of a new thing called edge servers that are being worked on right now and being introduced. These are newer, so we won't be covering them. They can actually allow you to run code on sort of like CDN servers, on servers that are distributed around the world close to end users, but that's going to be on the scope of this. And this is a very, very new development, so we're going to not be covering that for now. So if we can only put static content in CDNs, then what's the point? What kind of static content would we actually do anyway? Well, sort of what we talked about earlier was the JavaScript. In the caching example, we talked about how that JavaScript is not changing. For every user, it's going to be the exact same. And unless I actually update the original code, the user is fine to access one of the CDN servers. So that JavaScript that we looked at in the last lesson actually is hosted on a CDN. Because it's not changing, it doesn't need to hit the origin server every single time. But there's actually all kinds of static content like images or videos. Videos aren't changing, images aren't changing. If people want to see a picture of the Eiffel Tower, for example, it's going to be the same for everybody. We don't need it to be on the origin server where we're running code. It's okay to put copies of that image everywhere around the world so that when a user wants to access that image, they don't have to go all the way to the origin server. That image is already on a CDN. They can travel a much shorter distance to get that data. So it's faster and it lowers the demand on our origin server. We're distributing the data in CDN servers, which decreases the latency because it's a much shorter distance, but also increases the availability, because what if one of these CDN servers goes down? It's okay, we can go to the next closest CDN server. So we increase the reliability and the availability of our entire system. Now there's a couple different types of CDNs. We can have a push CDN or a pull CDN. So let's say we're building an application, let's say Twitter, for example. We have our server that's going to be handling requests like creating tweets, deleting tweets, and doing all kinds of stuff. Now,
30 seconds left. Need to reach grenade.
one component of a
Whole squad's down. We made the right choices. Recharging my shields.
An invitation? Come on, get in the ring, compadres.
Back in the race.
Down that one. They're not getting back Sniper's down. One spawn closer to win.
We will not let off the gas.
No kill leader. Getting shot at. Care package over there.
An opponent's shield.
I'm going in. Faster, faster, faster. Jack. There's another squad. Yo, cracked an enemy shield. Recharging my shield. I'm down. Follow the tunnel. Enemies right here. Photo's ready. Give me the help, please. 1 second. You got this. One more squad. Charging up my shields.
Reloading. Refueling my shields.
Frag out. Yo. Charging on my shields. Shield broken. Down that one. Rings around the corner, and we've got 30 seconds. Crack the bad news.
This should
You are the Apex champions.
A Twitter profile is the profile picture, right? It's an image. So this can be hosted on a CDN. This image is static. It's not going to be changing unless a user changes their profile picture. So what we're going to do with a push CDN is as a user uploads this image, it's going to be on our origin server, but we're also going to actually spread it out. We're going to push this data to every single CDN server immediately after it's been added to the origin server, because now we've split it up, and when clients access it from anywhere in the world, clients will be reaching the closest CDN server. They don't have to go to the origin server. So that's pretty simple. Now, poll CDNs are a bit different. It's more similar to the traditional caching example that we looked at, because with this, if a user uploads a profile picture, it will be on the origin server. We're not going to immediately push it to all the CDN servers. With poll, a user is going to make a request, and maybe they load somebody's profile and they want to see that little, circle profile picture at the top left of that user. Well, first, they're going to hit the closest CDN server. They're going to check, is that profile picture already cached at my nearest CDN server? No, it's not. So then the CDN server is going to act as a proxy. I know we haven't, gone super in depth into that, but this is an example of a proxy. The CDN on behalf of this user is going to say, well, this is a cache miss. I got to find that image. I'm going to go to the origin server. It must have the image if it exists. And then the origin server is going to return it to the CDN. And then at that point, the CDN will cache the image, and then this user will be returned that image, of course. But then any other user close to the CDN that's making requests to the CDN will also get that image. And the next time a user requests it, it will be a cache hit, because now the CDN has that data. But at the same time, maybe users in the other side of the world over here, they don't care about that same profile picture. Like people in this side of the world, maybe they don't even care. They never request that same profile picture. So we never had to push that image to all these other servers on the other side of the world because it wasn't necessary. Users over here, maybe they do access the CDN, but they don't look for that exact same profile picture. So this CDN server will only have the copies of data for users around it that are actually using that data. We don't want unnecessary data. So a poll CDN would be better if users around certain regions of the world have different interests and they're using different data of the origin server. So at a high level, CDNs are this idea of moving data closer to end users, just like how in farming, maybe certain countries can farm a lot of bananas, but then those bananas are shipped to end users, aka grocery stores, where people actually can just drive down to the grocery store and buy some bananas. They don't have to go across the entire world where bananas are actually grown. Now let's take a look at a quick example. Let's go to twitter.com, and once again, opening up the dev tools, though this time we're going to actually, unless a user changes their profile picture. So what, for example, next close, it's faster, and it's everywhere images and servers. So that JavaScript that we looked at in the last lesson actually is hosted on a CDN because it's not changing. It doesn't need to hit the origin server every single time. But there's actually all kinds of static content like images or videos. Videos aren't changing. Images aren't changing. If people want to see a picture of the Eiffel Tower, for example, it's going to be the same for everybody. We don't need it to be on the origin server where we're running code. It's okay to put copies of that image everywhere around the world so that when a user wants to access that image, they don't have to go all the way to the origin server. That image is already on a CDN. They can travel a much shorter distance to get that data. So it's faster, and it lowers the demand on our origin server, we're distributing the data in CDN servers, which decreases the latency because it's a much shorter distance, but also increases the availability, because what if one of these CDN servers goes down? It's okay, we can go to the next closest CDN server. So we increase the reliability and the availability of our entire system. Now there's a couple different types of CDNs. We can have a push CDN or a pull CDN. So let's say we're building an application, let's say Twitter, for example. We have our server that's going to be handling requests like creating tweets, deleting tweets, and doing all kinds of stuff. Now, one component of a Twitter profile is the profile picture, right? It's an image. So this can be hosted on a CDN. This image is static. It's not going to be changing unless a user changes their profile picture. So what we're going to do with a push CDN is, as a user uploads this image, it's going to be on our origin server, but we're also going to actually spread it out. We're going to push this data to every single CDN server immediately after it's been added to the origin server, because now we've split it up, and when clients access it from anywhere in the world, clients will be reaching the closest CDN server. They don't have to go to the origin server. So that's pretty simple. Now, pull CDNs are a bit...
Enemy landed near me. You, out of my tailpipe.
Taking damage, friend.
Shield.
Watch yourself. This time I'm down.
Round one.
Already next. Luck dice. Raising a nitro gauge. We will not let off the gas. Charging shields. Hurt.
Oh!
different. It's more similar to the traditional caching example that we looked at, because with this, if a user uploads a profile picture, it will be on the origin server. We're not going to immediately push it to all the CDN servers. With Hole, a user is going to make a request, and maybe they load somebody's profile and they want to see that little circle profile picture at the top left of that user. Well, first they're going to hit the closest CDN server. They're going to check, is that profile picture already cached at my nearest CDN server? No, it's not. So then the CDN server is going to act as a proxy. I know we haven't gone super in depth into that, but this is an example of a proxy. The CDN on behalf of this user is going to say, well, this is a cache miss. I got to find that image. I'm going to go to the origin server. It must have the image if it exists. And then the origin server is going to return it to the CDN. And then at that point, the CDN will cache the image, and then this user will be returned that image, of course. But then any other user close to the CDN that's making requests to the CDN will also get that image. And the next time a user requests it, it will be a cache hit, because now the CDN has that data. But at the same time, maybe users in the other side of the world over here, they don't care about that same profile picture. Like people in this side of the world, maybe they don't even care. They never request that same profile picture. So we never had to push that image to all these other servers on the other side of the world because it wasn't necessary. Users over here, maybe they do access the CDN, but they don't look for that exact same profile picture. So this CDN server will only have the copies of data for users around it that are actually using that data. We don't want unnecessary data. So a poll CDN would be better if users around certain regions of the world have different interests and they're using different data of the origin server. So at a high level, CDNs are this idea of moving data closer to end users, just like how in farming, maybe certain countries can farm a lot of bananas, but then those bananas are shipped to end users, aka grocery stores, where people actually can just drive down to the grocery store and buy some bananas. They don't have to go across the entire world where bananas are actually grown. Now let's take a look at a quick example. Let's go to twitter.com, and once again, opening up the dev tools, though this time we're going to actually be looking at the elements tab because we want to see the HTML. So scrolling pretty much all the way down, you can see that Twitter is actually using a CDN, a content delivery network. Now what this is for, it looks like it's some JavaScript, and it's for handling Apple authentication. I assume it's for this sign up with Apple functionality that they have. And I'm actually going to copy this URL, this Apple URL, and open it in another tab. So opening it, you can see that this is just some JavaScript code. It's created by Apple. It's not very readable, but it's just code, and it's static code. So we can assume that this is not going to be changing very often. Every user who loads twitter.com is going to be loading this JavaScript. So while Twitter could take this JavaScript and create a copy of it and then host it on their own servers, or they could have installed that package, assuming there's a package for this, they could have installed it and hosted it on their own server. But it looks like they're using a content delivery network that's provided by Apple, so that every time a user opens up twitter.com, they don't have to load this JavaScript from Twitter's server. They can load it from a content delivery network server that's much closer to their own location. So going back to our drawing really quickly, assuming this is Twitter's server, we have to hit that server to, let's say, load twitter.com. Maybe there's no way around it. We have to load our own profile page and we have to log in and do all that stuff. So we do have to interact with Twitter server. We have to go this entire distance. But if there's some data like images and JavaScript and Apple authentication stuff that can be hosted not on the origin server, we can create copies of it, static copies, and put them all around the CDN. To access that portion of data, we can just go to the CDN. So we're basically taking a large amount of data here, breaking a piece of it off. We could have hosted this data all in the origin server, or we can create little copies of it and put it all around the world in CDN server. So now we have a smaller amount of data that has to travel this entire distance, and a little bit of that data will be moved closer to every end user, regardless of where they are around the world. We do this because it's possible and it speeds things up. If we could do that with the entire data, we definitely would, but we can't, because there's going to be some stuff over here on the origin server that's not static. It's different for every single user. Every time a user opens up the page, they see something different. That almost always happens when we have authentication, right? Everybody logs in and they see a different experience. They see a different feed. They see different content. That's what this is about. Now, quickly going back to the dev tools, I went to the network tab and I typed in CDN, and then we saw this Apple ID JavaScript that we looked at in the elements tab earlier. There's one last quick thing I wanted to show you. It has to do with that cache control header that we talked about earlier. So this time you can see that the cache control does have multiple values. There's max age, so 86,000 seconds, and some other stuff, but I want to focus on this public value. Cache control can have multiple values for the visibility. It can have nothing here, which we saw in the last lesson. It can be private or it can be public as well. Public means that this data, this JavaScript, is allowed to be cached on other
I've enhanced my weapon.
Attention, first blood.
First blood. The cycle has begun. Introducing a new variable.
1. Beginning ring countdown.
It's a long ride to the next ring.
Ring close in 1 minute. Run and slide.
Oh, extended light mag here. Level 2.
Adding another gas trap. Spotted a subject over there. The ring is distant. 45 seconds before close. Firing on subjects. Reloading.
This outfit is good.
Spotted one. Crack the subject.
Refueling my shields.
We're all outside of the ring.
Recharging my shields. 1 sec. Enemy nearby.
Charging shields.
I'm down. Victor.
I'll try to get there, Sid. Give me a second.
Got back our teammate's banner. Putting down the respawn beacon. Extended shotgun bullet here. Level C.
I control death. It does not control me.
Attention. There is a new kill leader.
There's a new kill leader.
We will not let off the gas.
I've discovered the location of the next ring. Check your map. Spotted one. Distant.
Uh-oh.
Enemy shields kaput. Refueling my shields.
Put it down, me.
Oh, they're
Full gas.
Spotted one.
peeking.
Subject spotted.
Pull over here.
servers that don't include the user's browser. So if there's some middle layer server, which in our case there's a content delivery network, this JavaScript can be cached by the CDN. That's what this public specifies. If this was private, that's basically indicating that this should not be cached by a CDN server. In that case, the CDN would not cache this JavaScript. But in this case, it's perfectly fine for it to. It's public, and that's the idea. This would be relevant when we're talking about poll CDNs, where from the client we make a request to the CDN server doesn't have the data, then we make a request to the origin server, it does have the data, it returns it to the CDN server, and then the CDN server sees in the HTTP header that cache control is public. Okay, great, I'm going to cache that thing, and then anytime a user needs it, then I'm going to give it to them immediately without having to go back to the origin server. So I know we talked about a lot of things when it comes to caching and content delivery networks, but if you can understand this very basic high-level use case that moving data closer to users is faster, that is the most important part of all of this. So next, let's talk about proxies and load balancers. And these are really, really big topics to be covering in a single video. But the good thing is we actually already know more about these than you might think. And also, as developers and system designers, we actually don't need to go super in depth into these topics, but if you're interested, I would recommend doing so because it can get pretty interesting, but pretty complicated and very nuanced. First, let's talk about proxies. There's two main types of proxies. Let's start with forward proxies, and sometimes proxy just implies forward proxy. If somebody just says proxy, they probably mean forward proxy rather than reverse proxy, but not always, which can get confusing. So if we are clients and we are trying to make a request to some server, but we have a middle server in between, so this middle server in this case would take our request and then forward it to the actual server on our behalf. And not only that, but it would actually act as a user. It would be the middle layer that would do the work for us. It would actually hide the client from the destination server. So let's say we make a request that has our IP address in that request, right? We know that's just how the internet protocol works. But having a middle layer is like having a friend that's going to do something on your behalf. Like you have to, send some information somewhere, and then somebody in between, like the mailman or something, does it for you. Maybe that's not the best analogy because, with mail, your address and stuff is still on the envelope. But the idea here is that the middle layer, the proxy, will hide the user and protect their identity. But since this middle layer is handling that traffic, this can be used for other things as well. Like, for example, maybe your country or your computer or, something with your network is not allowed to access this server. Well, but you are allowed to access the proxy server. So what the proxy does is for you, since you're not allowed to directly go to the origin server, you can't do that. The proxy server does it for you. It will go to the server on your behalf and then respond to you. So it'll bypass that restriction. A forward proxy can also block things like on a corporate network or on a school network. It's pretty common to have all devices that are connected to that corporate network go through some proxy. Now, maybe if you try to access some site that you're not allowed to, like sometimes corporate networks will actually block YouTube, which is kind of frustrating, I think. But your corporate network, your corporate proxy could say, hey, you're trying to go to YouTube? Nope, not going to let you do that. All traffic goes through the proxy, and the proxy decides, it sets rules that can block access to certain sites and certain resources. So a real world example of a forward proxy would be just like a corporate proxy like I talked about, or sort of a VPN, right? That's a very natural thing because VPNs hide the original user from the server. They hide your IP address. You can act like you're from a different country and all that kind of stuff. Now, moving on to reverse proxies. So the simplest way to describe a reverse proxy is that instead of hiding the client or the user, which is what happens with a forward proxy, a reverse proxy actually does not hide the client, but it hides the destination server. Like as a user, we make requests to this server, but this server is actually not the one handling our request. This middle layer, this reverse proxy, is actually taking our request and with all the information that it includes, like the
Oh, now my weapon's enhanced, just like me.
Attention. First.
Vollgas. Oh, nothing does me better than an LMG.
Round 1. Beginning ring countdown.
Next ring's far, no lagging. Rampage here. Sight down, Susie. A minute ticket. We're aiming to lift and best not foul it up, eh? Ring closes in 45. It's a little pop. Enhanced a weapon. Not bad.
Evo harvesters are now available.
Barrel stabilizer here. Level 2.
Ammo reserves running dry. Should do a bullet run.
There's extra supplies here. Extended heavy mag here. Gold. Mind if I take it?
Warning. Movement in progress.
Rings moving and we're all outside. Let's not dive into it.
I've enhanced my weapon. Give me the edge. Upgrade engaged.
Got a care package coming in. Laser sight here. Level 3.
That's mine. My weapon is enhanced.
There's a new kill leader.
Summon us a new kill leader. We will not let off the gas. Forget it. I have. Enemy in sight over there.
Spotted an enemy over here. Gatka, enemy landed near me. Frag out. Tingnan mo. Downed an enemy. Enemy here. Frag out. Broke their shields. Last member of that team. Recharging my shield. 1 sec.
Let me heal up.
Optics here. Mid-range.
My weapon is enhanced. My weapon is enhanced.
Yeah, right next to me.
Okay, I'm getting shot at. Here's a nitro gate. Pick up the pace. Charging shields. Reloading.
Throwing an arc star.
Let's get the zone.
Right, got a fix on the next ring. Check your map. Frag out. Tingnan mo. Lay down, James. Let me back up before you can say, bababa ka ba? Bababa din ako. Getting shot at. Enemy's shield broke. Enemy taken down. Recharging my shield. 1 sec. Heads up, mate. Another.
There's 3 teams. There's 3 teams.
IP address and everything, which it doesn't necessarily have to do, but usually it does. And then it takes that request and forwards it to some other server. And then that server fulfills the request. It goes back to the reverse proxy, and then the reverse proxy sends it back to the client. But the important thing here is that, unlike with a forward proxy, the client actually does not even know about the existence of the destination. It just knows that this reverse proxy exists. Everything we do goes through the reverse proxy, and then we get something back. We don't even know about the existence of all the other servers. And the server, though, will probably know about the existence of the client. Not necessarily, but usually that's the case. And at a high level, it's really that simple. Now, what is an example of a reverse proxy that you can think of? Well, we actually talked about it recently. CDNs, right? Do you think a CDN is a forward proxy or a reverse proxy? Well, as users, we directly go to the CDN. Like, that's our cache. That's where we're going to try to read data from. But possibly that CDN will make a request to another origin server that we don't even know the existence of, right? And we don't care about it. We just interact with the reverse proxy with the CDN, and then the CDN maybe will go to the origin server, get the origin server, cache the data, and then send it back to the client. But the point is, we don't know about the existence of this. The reverse proxy, the CDN abstracts this away from us. We don't have to worry about that. Now, another popular example of a reverse proxy is actually a load balancer. That's what we're going to spend the rest of this lesson talking about. Load balancers are very, very important, but luckily for us, conceptually, they are pretty simple, though implementing them would not be super straightforward in the real world, because there's a lot of like networking details involved with that. So a load balancer is a type of reverse proxy where a user is going to make requests which are going to hit the load balancer first, but we have multiple servers. Reason being that we have a lot of user traffic that we have to handle. A single server can't handle all that traffic, so we actually have multiple servers, doing the same thing. Let's say all of these are running the exact same application, the exact same API or whatever. What we want to do is horizontally scale the servers, which is exactly what we're doing, and we want to distribute the traffic evenly among all the servers, aka we want to balance the load of user traffic. So conceptually, that's it. Like that's what a load balancer is for. And in terms of system design interviews, this is pretty much what people mention, and it's almost laughable in my opinion because load balancers are super complicated. Yet in interviews or in discussions, we just say, I'm just gonna throw a load balancer in front of it and then horizontally scale those servers. Presumably they're implemented with REST, which allows them to be scaled. They're stateless, let's say. So that's great. And now how exactly do we distribute that traffic evenly? Well, there's many algorithms to do it. The most simple is probably round robin, which as the name implies, we go round robin.
Prepare for battle.
Follow me there. Low skids. Don't make me drag you.
Man, I mean, fuck.
Going to loot over there. Never settle.
A foe landed nearby.
Fire. Cracked it, but we steal. Shotgun ammo. Here's a nitro gate. Pick up the pace. Deep losses. Cracked shields on that bandit.
I downed a hostile.
Counting down from 16. The ring's close by. Taking fire. Charging up my shields. Further. 45 on the clock. They're shooting at me. Placing a nitro gate. We will not let off the gas. One sec. Healing up. Shields on that bandit. Crash an opponent's shield. Ring's close, and it's a good thing. Only have 30 seconds left.
Res?
Taking damage. Overtook another enemy.
New kill leader appointed.
Ring closing in 10. It's close. Axel is a new kill leader. Vakla.
Did I tell you to die? Get off your knees.
My shields are strained. I should recharge them.
Ring's moving. Let's not get caught outside with pedestrians. Hold up. Healing. Buffing our damage.
Care package delivered.
Care package coming down. Standout stock here. Level 2.
Marking our surroundings. There was a recent battle here.
Weapons enhanced. Let's leave a mark on the world. Do not stop. Use this nitro gate.
I have enhanced my weapon. Glory awaits.
I've enhanced my weapon.
There are Anscoti to be found in this direction. We should continue there.
Opponent in the distance. Right there.
Ow!
Put a knife blade down. Speed up. This is how we kickstart a
Our
heal
aim
pod.
is clear. Enemies back. Trust in the Old Father. Recharging my shields.
Crash an opponent's shield. Consider it down. Chow chow. Opponent wiped out. Taking fire. Go there.
Taking a moment. Scanning the area. Let us count them on them.
Okay, I'm getting shot at.
Taking a moment.
Guys landing on us. Back up, back up, back up, back up. Put pass down. Back up. Behind you, behind you, behind you.
Enemy shield is kaput. Put an ice skate down. Speed up.
One's one shot, that guy.
Smash the
Crack behind the rock. One shot behind the rock. Dead.
competitor down. I like
Behind us there. They're attacking.
They're shooting at me. Smash an opponent's shield. Overtook another enemy. This should kickstart the pod. Go there. Enemy inside.
Can we
there.
get finishes on you guys? Or maybe?
Competitor spotted there. Taking fire.
Another team.
Taking a moment to recharge my shields.
Over here, maybe back up. Let them fight. These two teams might fight on the corner. Grab me a little bit. These guys need to shoot at them.
Need shield. Eat an arc star. I'm here. Crash is burning over here. Opponent down. Got a bogey here, and they're healing up.
Recharging
Got an opponent here.
Try to run. Guys, should push. I think this other team's pushing.
Only once have I failed to kill it.
Go, in a cycle, the first request will hit the first server, the second request will hit the second server, the third will hit the third server, and then the fourth request will start all over. We'll go back to the first, we'll go back to the second, then the third, and just go in cycles just like that. So this will mean that each of the servers will get an even amount of traffic. Now, a problem could be that one of the servers is less powerful than the other ones. Like, we have 100 servers, some of them maybe just happen to be less powerful. In that case, we would have a variation of round robin, which is called weighted round robin. Maybe this server is, a 10, and this server is a 5, and this server is also a 5. Or, in terms of percentages, this server should get 50% of the traffic, this server should get 25%, and this one should also get 25%. So in that case, we would route the requests like this. The first request goes to the first server, the second request also goes to the first server, then the next one goes to the second, and then the next one goes to the third. So since this server is twice as good as the other two, we expect it to be able to handle twice as many requests. So if this one got 4 requests, these other ones would get 2 requests each. Now, there's many other ways we could also do this. We could load balance based on the number of least connections. That's another strategy. We get a request and we route it to the server that has the least number of connections. Like with round robin, just because we're evenly distributing the requests, maybe some requests just take longer to process. Maybe this first request asked for a lot of data, so it takes a bunch of computation to do that. Maybe even though it was first, it takes longer to process. Like this second request is finished, and then we are making another request. Where should we route it? Well, this server is already taken. It has a connection, so we send that to this server, which does not have a connection. So this is load balancing based on the server that has the least number of connections. So that's another valid strategy. If these servers are located in different locations, we could also load balance based on user location. Maybe this server is in North America, that's where the client is, so we route the request to this server. Maybe this server is in Asia, this server is in Europe, and if European users are accessing the site, we route those requests here. Asian users, we route those requests to this server. There's another variation that we'll probably talk about later on, which is called hashing. So we actually take that user request and use some field, possibly the IP address or the actual content of what the user is requesting, and we take a hash of that, or maybe hash the user ID. We could do anything, but hashing has its own benefits that we'll be discussing later on. I also want to quickly mention, but not go super in depth into this, there are a couple types of load balancers, layer 4 and layer 7. Layer 4 is at like a lower network layer. You can think of this as being the TCP layer. This is the transport layer, and layer 7 is the application layer. You can think of HTTP, like an HTTP server is the load balancer here. Now, the benefit of a layer 4 load balancer is that it's typically going to be faster because all we do is look at the IP address to determine how to balance. So we could use location-based balancing, or we could just use round robin. But we can't really be smart because with TCP layer we don't actually have access to the application data. We can't decrypt that. We can't see exactly what resource is the user using. So while this is faster, it's less flexible. With layer 7 load balancers, we can look at the application data. Maybe one of these servers is handling certain types of resources. Maybe this server is all about tweets, for example. Maybe this server is all about a user profile, and the third server is all about authentication, or I'm just making this stuff up. But they serve different purposes. With a layer 7 load balancer, we could intelligently route user requests. We could see a request and see it's based on tweets. It's related to tweets, so we route it to this server. Another request could be related to authentication. We route that request here. So layer 7 is more powerful, but since it's layer 7, we'd have multiple connections. Like we'd have a TCP connection established here and another one established over here. So it's more expensive because we are going to be decrypting every request and then creating a new request. Whereas layer 4, we'd actually just be taking a request and then forwarding it to another server. We're not doing anything with the application data. We're just taking the IP address of that request, and its destination was this server, but we're going to replace that IP address with one of these servers' IP addresses and just forward it there. And then when we get a response back, we just return that response back all the time. This is a very high level overview. Most likely the distinction between layer 4 and layer 7 won't come up at all, but simply put, layer 7 is faster but less flexible. Layer 7 is slower but much more powerful. Now you might be wondering, if we just have a single load balancer like this one, what happens if this load balancer goes down? This is sort of slow at all, but simply put, layer 7 is faster but less flexible. Layer 7 is slow at all, but simply put, Layer 7 is faster but less flexible. Layer 7 is slower but much more powerful. Now you might be wondering, if we just have a single load balancer like this one, what happens if this load balancer goes down? This is sort of a single point of failure. Yes, we horizontally scaled our server, so we increase the availability, increase the reliability. If one of these goes down, it's okay. We can still route requests to these other servers. Load balancers are capable of doing that.
Lendare, I don't beg. Ah! Yelling is good for focus.
Let's go over there.
Safety's off. Enemy landed on me.
Does this enhanced weapon make me look scarier? I bet it does.
Cracked an enemy shield. Putting lead down range.
Broken enemy shield.
I've enhanced my weapon.
Shots fired, and they're hitting me.
We're inside the ring. Cracked an enemy. Spotted. Double timing it.
Recharging shields. Throw my grenade out.
Reloading.
First blood.
Shots fired, and they're hitting me. Give him my shield to recharge.
Attention. Evo harvesters are online. Tango near me.
Bamboozles for the boozles.
Okay, shooting at me.
Back out over there.
Refueling my shields.
Enemy spotted. Near me.
Enemy shield cracked. I got a bad guy.
Cracked an enemy shield.
Throwing our shot.
Tango down.
Recharging shields.
Good work. We're inside the next. Smoke out.
Broken. Shots fired, and they're hitting me. I think that was the whole squad. Last guy.
Gas given.
Healing. Watch my back. Attention. Care package incoming. Let's get you out there. Attention. There is a new kill leader.
Someone's got a... I got you a present. The next ring location. Check your map.
I need heavy ammo.
Survey beacon here.
Placing a night brigade. We will not let off the gas.
Wabam. Enemy positions marked on your map.
My weapon is enhanced.
Evo harvester spotted near me. Survey beacon over there. Let's reposition there.
I've enhanced my weapon.
Shotgun.
Use this night brigade.
Both increased rate of fire. Weapon enhanced. Ain't that pretty?
Placing a night brigade. We will not let off the gas. Care package there. Let's steer that way.
Look at the chart. We're spread too thin. Got extra supplies here. Arm up.
Level up. An upgrade will give me the edge. I've locked in an upgrade.
Level 3.
I see a competitor over there.
Let's go that way.
Positions marked on your map.
Not that area.
Reloading.
Pushing that fight.
Champion eliminated.
That's some champion, huh?
Okay, they're shooting at me. Smash an opponent's shield. Refueling my shields.
Getting shot at. Bad news. I'm down. Hostile right here, right in front of me.
Just us now. Gotta watch each other's back. Come on in. Old pants is waiting. Giving him the chimney.
What?
But what if the load balancer itself goes down? Well, in that case, the easiest thing to do would be to have multiple replicas of the load balancer. So we'd actually have multiple load balancers, and then user requests would be going to each of those load balancers, or maybe we just have a backup load balancer, and if this one goes down, then requests would be routed to the other. Typically, load balancers can handle a very, very large amount of traffic and handle really, really high throughput. So it usually doesn't come up that a load balancer would be overloaded because they're not actually doing anything. Typically, they're just forwarding the request to other servers. But if you're really, really interested in load balancers, I'd consider reading a paper by Google. You can search for maglev. It goes a bit more in depth into how load balancers can be implemented. And if you're looking for some open source implementations, the most popular one is Nginx. It's a very popular open source load balancer, and it can be used for a lot of other things as well. It's really, really powerful. There's a good chance you've already heard of it. But in the open source world, if you're going to be implementing your own load balancer, you're probably using Nginx. Though it's a lot more easier to just use a load balancer provided by a cloud provider like AWS or GCP. That's much more common because these are pretty hard to implement because these are really, really powerful. And if you can get it out of the box, that's probably preferred. So now let's talk about consistent hashing. And actually going back to our load balancer example, let's just talk about basic hashing for now. We talked about how we can balance user requests a pretty simple way using round robin, just going in order from all the servers and then just cycling through all of them. Another way we briefly mentioned, we can actually use hashing to balance the requests to the servers. In this case, we have 3 servers, and let's say we want to hash based on the user's IP address. Like we have to take user requests and hash them in such a way that they land at some server. And an IP address is some integer value. We're going to oversimplify this. Let's say one person's IP address is 6. So we can take that IP address and mod it. This is a math function, basically taking the remainder of 6 after dividing it by the number of servers that we have. We have 3 servers. So we mod 6 by 3, we get a remainder of 0. So we know that this IP address 6 should be mapped to server 0. Well, which one of these is server 0? Let's just label them like this, 0, 1, 2. So an IP address of 6 is always going to be routed to this server. And if we took an IP address of 7, we would get a remainder of 1, so it'd be routed to this server. If we took an IP address of 8, it would be routed to this server. And assuming that the IP addresses are roughly uniform, which they probably will be, we can assume that this is a pretty basic way of balancing the load between the servers. Now, one
Attention. First blood.
Ah, first blood. Some aren't. You have to survive to get to the after party. Da geht's ab.
Phoenix Kid here.
Okay, they're shooting at me. Down. Cut down an enemy. We're close to the ring.
I might be.
We have 1 minute.
That's what you say, right? Friends, please.
Another enemy falls.
Hold on. Let me help you.
Caught with no way out. Recharging shields. The ring is near.
I knocked it over there, by the way, for the resin.
to the afterparty. Use it well. That gets up.
Sky, instantly.
Kill leader. Entirely expected. Reloading.
Anyone got any light ammo?
We'll be caught outside
Ammo
the ring
reserves
if we
running
don't
dry.
move.
Should do a bullet run. Shield. Competitor down. Hold on. Let me help you.
Care package being delivered. Care package incoming.
I was in a support res.
Heal, heal, heal.
My weapon is in here. They're shooting at me.
Recharging my
Shield. Reloading. Time to push max level to its breaking point.
I'm in trouble. Just stopping off my shield. Enemy shield crashed. Another enemy shield broken.
Overtook another enemy. Look here. Fini. Hold on. Let me help you. 50% of this. Hold on. Let me help you.
Recharging shields.
Refueling my shields. I'm low on ammo. Should find more.
Weapon enhancement complete. Now for some field tests.
Hey, so far we low-key fucking them.
My
We
weapon
give
is
12 kills
enhanced.
to the squad, which is crazy.
I now have an enhanced weapon.
I've enhanced my weapon. We've got an evac tower deployed there. Get full gas. Care package there. I've enhanced my stop. Use the nitro gauge. Follow me there. Don't make me drag you.
Examine your map. I have found the next location of the ring.
Opponent in the distance.
Beginning ring countdown.
positioned there.
Hey, good shit.
Attention. I have the banner. We must correct
I'm trying to get him up real
failure.
quick.
Care package incoming. Shield battery here. Recharging shield.
I see it. Recharged.
Head that way. Reloading.
I can alter somewhere if they need.
Taking fire.
Replicator's coming down.
Shields are depleted. Recharging. Unacceptable.
I got
One full
fucking
minute
Kraber.
and the ring is close. Let's go. I don't like stalling. Out.
We're a team of two now. 25 seconds until ring closure. I'm in trouble. I'm bleeding out.
No, he's not. He is not. He is not.
We will not let off the gas. We're already in the next ring. Don't get comfortable. Luck dies, winners don't. Got back our teammate's banner. So slow. Use this nitro gate.
Round 4. Beginning ring countdown. Attention. Delivering replicator.
Got a replicator incoming. Care package there. One full minute and the ring is close. Let's go. I don't like stalling. Ring's close, with 45 seconds to burn. said the ring closes.
But I keep coming
Let's stay
back.
that way.
I feel recharged.
The care package has touched down over there.
Is it safe to get that Kraber?
The ring is moving. Let's not get caught outside with the pedestrians. I've enhanced my weapon.
I got that
Eyes
shit.
on an enemy here.
Optics here. Close the range.
Enemy pulling up here. Getting hit. Charging shields. We've got another squad coming.
Time to bind you.
One full minute. Let's go. I don't want to stop. Things close. With 45 seconds to burn.
Not working.
We have 30 seconds.
Refueling my shields.
A second squad.
I'm crawling.
Enemy shield is kaputt.
Benefit of this hashing approach compared to round robin, the same user with the same IP address of 6 will always be routed to this server, even if this server is not the one with the lowest amount of traffic. But what could possibly be the benefit of this user always going to this server? Well, if our servers are REST APIs and they're stateless, then it doesn't really matter, because whether this user goes to this server or this server, it doesn't matter. The servers are identical. There's no difference between any of them. But what if each of the servers had some little Redis cache attached to it, and this is not a shared cache? I'm talking like this is a Redis in-memory cache, so that it belongs to the server. If they all had a shared cache that they were all talking to, that would be different, but each of them has their own individual cache. And let's say that these servers are not stateless. They are caching something for the users that they're getting, but this server would only be caching the requests for this user or any other users that are routed to it. And this server is never going to cache anything for user 7 because those requests don't go to this server. They go to another server. So this works with hashing. But if we were doing round robin, sometimes user 6 would end up going to this server, and then maybe we'd cache some information for them. Great. But then that same user might go to another server the next time they make a request. So then this server would check the cache. Well, I don't have anything, so I'm going to have to reprocess all that work. But if that request had instead gone to this server, it would have already seen the data in the cache. So hashing is more suited if we want user requests to be mapped consistently, right, to the same server. We want an individual user to be mapped to the same server, because then we can do more complicated things like caching at that server level. And this is where, as you can guess, consistent hashing comes in. So while this very basic hashing approach is a good start, it doesn't solve everything actually. And I'm going to tell you why. I changed the example a little bit so that it better illustrates the point that I'm going to make right now. But functionally, this doesn't change anything, because 9 divided by 3 would still be mapped to 0, 10 would be mapped to this one, 11 would be mapped to this one. And this is, of course, an oversimplified example. Your IP address isn't going to be such a small number. So now assume we've been taking requests and balancing them, and we've been able to take advantage of the caching because requests are mapped consistently to the same server. But a problem is going to arise when we remove one of these servers. Let's say I take server number 2 and just get rid of it. Maybe it crashed, or maybe we couldn't afford 3 servers anymore. Or maybe we don't need 3 servers. Maybe 2 is enough for us to handle the remaining traffic. So what's going to happen now? Well, ideally, this user and all existing users going to this server will continue to be routed to this server, and all existing users being routed to this server will continue to do so. But all of the other users, maybe 1/3 of our users over here, will have to be routed to one of these other servers. Maybe we split them 50-50 between these two. That's the ideal scenario, because then all of these users still get their requests cached because they access the exact same server. It's consistent, but these users, we can't really do anything about that because this server went down. We have to move them to a different server. So that's the ideal scenario. That's what consistent hashing would actually do. But watch what's going to happen now, because and all we couldn't afford 3 servers anymore, or maybe we don't need 3 servers, maybe 2 is enough for us to handle the remaining traffic. So what's going to happen now? Well, ideally, this user and all existing users going to this server will continue to be routed to this server, and all existing users being routed to this server will continue to do so, but all of the other users, maybe 1/3 of our users over here, will have to be routed to one of these other servers. Maybe we split them 50-50 between these two. That's the ideal scenario, because then all of these users still get their requests cached because they access the exact same server. It's consistent, but these users, we can't really do anything about that because this server went down. We have to move them to a different server. So that's the ideal scenario. That's what consistent hashing would actually do. But watch what's going to happen now, because
Go there.
I've enhanced my weapon.
Attention. First blood. Yikes, first blood. Imagine crashing and burning on takeoff. Got an enhanced weapon and a smile on my face. Round 1. Beginning ring countdown.
The next ring's far. Extra supplies here. I'll share.
I have 4 bats with overflow, so you guys can have some.
In a minute, and it's pretty far.
Shield battery here.
Barrel stabilizer here. Level 3.
Calling dibs.
45 to go. Fortunately, radar shows the ring's close.
Evo harvesters are now available.
Pick up the pace.
The ring closes in 30. We should get moving. Don't want to get toasted.
Extended energy mag here. Level 2.
Oh, dibs. Everyone's got favorites, and that's fine.
Ring closing in 10. It's close. Extended light mag here. Level 2. We're outside the ring. Move, unless you want to get barbecued.
That would have been great like 30 seconds ago to have that blue light back.
Hey, thanks. Thanks. Great thinking ahead.
Ultimate's ready. Who wants to fly?
Attention. Delivering care package.
Care package coming down.
My ultimate's all charged up and ready. Oh, now my weapon's enhanced. Just like me.
Ampere. Power booster.
Calling dibs.
Shield battery here.
I got an enhanced weapon and a smile on my face.
My weapon is enhanced.
Bogey's on radar. There's a clueless bogey out there.
Speed up.
Go ahead.
Hey, thanks.
This is amazing. You are amazing. Thank you so much.
Do not stop. Use nitro gauge.
I'm hearing enemy activity this way.
I'll come with.
Just so you know.
enhance my weapon.
An opponent. They're far away.
And in this corner, your #1 contender for the World Heavyweight Championship. What's your name, Jake? That doesn't matter. You won't last around anyway. Give him a hand.
I'm coming to you.
Champions out. Opponent there.
Reloading.
It's gonna come out sooner or later. Pretty sure Doc's third partying.
Head that way. Bogey in my crosshairs.
I've spotted an enemy.
Bogey's on radar. Check your map.
Jammer's launching.
Bogey over there.
I'm over there.
Taking fire.
Competitor, right here.
Cracked shields on that bandit. Fox 3 launching missiles. Reloading.
Half the squad still cling to hope. That's cute.
Rival right here. Getting shot at. Broke their shield. I'm down.
One's super low. Watts is super low.
Enemy close.
Cracked shields on that bandit. Recharging shields.
Refueling my shields.
That's the full team, but no one's coming.
Taking fire. I'm here. Defend here. Recharging shield.
Opponent wiped out.
Impressive. Glad you're my wingman. Replicator incoming.
I'm down.
I got fucking sniped in the back.
I'm here. So let's get you a do-over, huh?
Care package over there.
Hey, you
Taking damage.
suddenly.
I'm down. Repeat, I'm down.
Cracked bogey's shield.
Minus one opponent.
Running up your left side. Running up your
Fox
left
3,
side.
I got radar lock.
Here we go. Jammer time. Rings far and closing in 1 minute. Oh, living the dream. Not today, kapatid. Got people depending on you.
Throwing frag. Need a thermite grenade.
Stand up.
Refueling my shields.
Enemy there.
Bandit bought the farm.
Ring is far. Can you cover that distance in 45 seconds?
Fox 3, visual clear.
It's amazing.
Reloading. Confirmed kill on whole squad.
Opponent there.
Refueling my shields.
Ultimate's ready.
Amp here. Over armor.
I said we go this way, because if not, we're gonna run into 3 teams.
Posted by the ring if we don't move.
Alert 5, Valkyrie actual. Ready for burn. How copy? Go for burn.
I've enhanced my weapon. I'm healing. Care package falling. Should we risk it?
Setting up an evac tower.
1 sec. Healing up.
So it's 5 o'clock somewhere, right? Optics here. Mid-range. 45 seconds until ring close, mga kapatid. The ring closes in 30. We should get moving. Don't want to get toasted.
My weapon is enhanced.
I think we should go here. It'd be a good idea to go there.
Rings close. We only have 10 seconds. Give Vollgas. Care package there. A short run for me. Inactivate. Give Vollgas.
Ultra's ready. Who wants to fly?
Incoming care package. Let's see who gets there first.
Ultimate accelerant here.
Shield cell here.
My ultimate's all charged up and ready.
We will not let off the gas.
I hit him.
Round 4. Beginning
Reloading.
countdown.
Fast 3, dumping the pods.
Care package there. A short run for me. Get in the ring. No cheap losses.
Replicator being delivered.
Replicator's coming down. Laser sight here. Gold here.
Grenade.
Smashed an opponent's shield. Competitor down.
Enemy shield broken.
Refueling my shields. All up here.
Throwing thermite. Throwing thermite.
Down. But the entire down.
Charging on my shields.
Not today, kapatid. You've got people depending on you.
Throwing thermite. Tossing frag. Healing. We got another squad attacking us.
Don't worry about ring fry. We're in the next ring. Recharging my shield. Don't worry about me.
Awesome. Getting hit.
Taking shots here. Recharging my
I
shield.
stuck one in there. Cracked both of them.
Opponent wiped out.
Messing up like a champ. Throwing a thermite.
Under fire. Throwing thermite.
Snapped up. Deploying jammers.
Put an activate down. Speed out.
Pin down.
I hit concrete for 125 on the roof.
Enemy close.
And we have a minute to reach it.
Let them fine, I'm visible.
You have to survive to get to the after party. 45 seconds. You could call
Not
it
now,
down.
about to be first to me.
I always get what catches my eye. Today that was you.
we now have not 3 servers anymore, but we have 2 servers. So our hashing function is actually going to change. So now we have to mod by 2. So we take 9 modded by 2 and we get 1. So actually user 9 is not going to be here anymore, and user 10 is not going to go to server 1 anymore. They're going to go to server 0. So we basically swap these 2 guys. So user 10 will be here, user 9 will go here. User 11, it doesn't really matter which one of these they go to as long as we do it roughly evenly. The remaining users, maybe you have user 14 here, user 17, which in this case actually would not be distributed evenly. But continuing this example, user 11 would be moved to server 1. So what we wanted to happen did not. In this example, the exact opposite happened. So this would be very inefficient because now user 9 is going to go to this server. All their data that was cached on this server is now useless, and user 10 had all their data cached on this server, but now they're going to the other server. This is distributing the traffic evenly, but this is not an intelligent way of doing things. If we could do things more intelligently, like I mentioned earlier, it would be much more efficient because then we could actually make use of the caching that we're doing. In many cases, if we didn't have a cache for each of these servers, consistent hashing would not matter. It's not always universally going to be the best solution, but in this example, it is beneficial, and it can be beneficial in a couple other examples as we'll discuss later on. Now that we already kind of know what we're trying to accomplish with consistent hashing, let's briefly talk about how we could actually do it. We're going to focus at the high level because this can get pretty mathematical, and that's not really useful when it comes to system design. But the idea is that our servers are actually going to be placed on some type of circular space. I've shown this pretty oversimplified because each of these servers still has that 0, 1, 2 number, but in reality, this is a circle. It could actually be that this is 0 degrees, this is 120 degrees, this is 240 degrees, and that's how we take user requests and we map them somewhere onto this circle. But I'm going to be continuing to show this with an oversimplified view of 0, 1, 2, but we're going to be taking user requests, and instead of directly hashing and mapping those to a server, we're actually going to be mapping each request somewhere onto this circle using our hashing function. So we could take user 9 and map them somewhere. Let's say they go directly to this server. We take user 10 and map them to this server, and we take user 11 and map them to this server. But in reality, each of these, for example, 11 could be mapped somewhere that there is no server. It could have been mapped here or somewhere in this region. But the idea is that
Let's steer that way. To that area.
Scouting has landed close by.
I've enhanced my weapon.
Fire cracked shields on that bandit.
First blood.
My weapon has been enhanced. Now we hunt.
Let's go here.
The ring is close. Time graces us. I must find more ammo. I am almost out.
Cracked shields on that bandit. Reloading.
Scanning the area. A lead to our enemy. Let us follow it.
Rings just a little further. We could jet over there.
Marking our surroundings.
Evil harvesters are now available.
Got an enhanced weapon?
Multiple squads. Marking our surroundings. A lead to our enemy. Let us follow it. Reloading.
We should head that way.
Warning. Movement in progress.
We're outside the ring. Move, let's want to get barbecue.
Go back to Val.
Recharging my shields.
Take the place, stop crafting.
Bless me with sight. Reloading.
Care package being delivered.
Care package falling. Should we risk it?
On radar.
Taking a moment to recharge my shields.
Padlock the bandit. Care package over there. Another bogey. Bogey there. Taking fire.
I downed a hostile. I have fallen.
Thanks, two squads.
Help here.
wherever wherever this is mapped, we're going to go from that on the circle. We're going to keep going clockwise, and this user will be assigned to the first server or node that is on the circle going in the clockwise direction. So anything over here would be assigned to this server, anything over here would be assigned to this, anything over here would be assigned to this server. But to keep it oversimplified, let's assume that 11 just goes here. So far, this is exactly as our basic hashing algorithm was. We're distributing these requests roughly evenly across these servers. Now, the difference is going to be when we take one of these and actually remove them. Now, you might be thinking, well, if now we have two servers, isn't our hashing function going to change? Aren't we going to take 9 and instead mod it by 2 and mod this by 2? No, I've oversimplified this. Our hashing function is actually not going to be so simple as just taking the IP address and modding it by the number of servers that we have. Let's say that's n. It's not going to be that simple, but let's take another pretty simple algorithm. Let's say we actually were modding by a integer, 360, so we were able to map each request somewhere on this circle, and we decided to intelligently place each server at a location where these would be evenly spaced, evenly distributed apart, so that each of them get a roughly even amount of requests routed to them. As you can imagine, there's a lot of math that goes on with doing this, which is why I've kept this pretty simple. But the idea is that now our hashing function is actually not going to change. 9 is still going to be routed wherever it was. Let's say it's routed exactly to this server, or it could have been routed somewhere over here and then moved over to this server. It's still the exact same. 10 is still going to be either somewhere here or exactly to the server, and all of these are still going to be routed over here. The only difference is with this region over here. All of these requests were originally being routed to this guy over here. But now, since this server doesn't even exist anymore, maybe it crashed, maybe we intentionally got rid of it, now all of the users that land over here are going to continue going clockwise until they find a server. At least our consistent hashing is going to do that on behalf of the user. And all of these users originally going to the server are now going to land at this other server. And this is really the best we can do. We want all the original users going to these two servers to remain the same, because if we have a cache on these servers, we want those users to be able to read from that cache. We don't want that cache to go to waste. We definitely don't want to swap these guys, but all the users going to this server, well, that server crashed, maybe its cache went away with it, so there's nothing we can really do about that anyway. Might as well take these users, move them to a new server. Ideally, we would want it to be distributed evenly. With this diagram, we can see that all of these are going to just this server, and at that point, this server will be the one handling about 2/3 of the traffic, whereas this guy will just be handling 1/3. I'm not going to go super in depth, but as you can imagine, there are solutions for this. There are optimizations we can make to minimize this amount and to evenly distribute the traffic. And while we mostly focus on what happens when we remove a server, as you can imagine, the same thing would happen as we add servers as well. We want to keep users consistently going to the same server. So what would happen if we added a new server over here? Well, all of these requests would still be routed here. All of these requests would still be routed here. All of these would still be routed here, but all of these now would go to the new server. There's not really anything we can do about that either. We could choose to route these requests still to this server. Maybe the server does have a cache that these users can use, but if we're adding a server, we probably did that for a reason. Maybe we're trying to handle a larger amount of scale. So maybe instead of just adding this server, we added a few more here, and we do those intelligently so that this gets a roughly even amount of
My weapon's enhanced. Take the upgrade rate. Wingman here. Sniper mag here. Level 3. Release. Ring closes in 45 seconds.
Backpack here, level 3.
The ring is near, but keep an eye on the timer. Just 30 to go.
Grappling.
The ring is near, but it closes.
My weapon is cooler now.
Follow me there. Don't make me
like
die.
You're welcome. I love
here.
you too.
Level 2. You're only as good as your gear. And skill.
If we let this ring catch up to us, we're done. And I am never. I've enhanced my weapon.
Contact.
Go ahead.
Competitor down. Ciao, ciao. Charging shields. Flash an opponent's shield.
Oh no, there's another squad.
Different team.
Giving my shield to recharge.
First blood spilled by our opponent in the distance. Buffing out damage.
Reloading. Getting shot at.
Down
Oh, he's still low.
Moving here.
I got you, friend.
Yeah.
Reloading. A whole team
Okay.
right. Not today, Capatid. You got people depending on you.
Refueling my shields.
Yeah.
Yeah. I got through them.
Shields are in rough shape. Need a beat to recharge.
Attention, the champion has been eliminated.
The champion is out. Do they give this title to just anyone?
I'm healing up. I need energy ammo.
My weapon is cooler now because it's enhanced.
Refueling my shields.
Oh, now my weapon's in hand. Just like me.
Pick up the pace.
I found the next ring location for us. Check your map.
I think we should go there.
Let's check out that way, friends.
This is amazing! You are amazing. Thank you so much.
Thanks.
Oi, my ultimate is ready. Checking this area for gear. Yell if you need me.
Care package there. A short run for me.
It'd be a good idea to go there.
Using a nitro gauge. We will not let off the gas.
My weapon's in hand. Take the upgrade where you can.
Round 2, beginning ring countdown.
Time to push max level to its breaking point.
Thank you.
Thanks, Dad. This is amazing.
I've upgraded myself. Überraschung. Replicator's coming down.
Let's say rift. We can go straight to rift.
I think we should go there.
Here I
Let's
go.
hit the this bullshit on portal.
I've enhanced my weapon.
Guys, give me crash.
Follow me there. Don't make me drag you. Forget it.
The enemies
I
are
have.
shooting at me. 1 minute. I am down.
Firing!
Just
Enemy
us
shield
two.
broken.
Follow me. You will honor the spirit. I recovered their banner. Let's give them a jump. Rings close, with 45 seconds to burn.
Reloading.
We will not let off the gas.
I have come to save the day. Maybe.
The ring closes in 30. We should get moving. Don't want to get toasted.
Repairing my damages.
I'm
Half the squad remains. Let's keep winning.
Ring close in 10. We're nearly there.
I have been down.
Not today, Governor.
Competitor down. Down. Repeat, I am down.
Getting shot at. I'm down.
solo.
Don't revive me.
You here, boy.
Don't worry, I'm here.
Care package being delivered.
Incoming care package. I love loot.
day, Kapatid. You got people depending on you.
I'm healing.
Pin down.
Don't worry, I'm here.
Let's get you back on your feet, Kapatid.
Take the portal? Yeah.
Long ride to the next ring.
Replicator there. Are we using this or?
Repairing.
Oh shit. Go to portal.
Back here. It's gold tier. You're only as good as your gear. And skill.
Giving my shields a recharge. Repairing. Care package over there.
Zipline there.
There's a squad coming in, and they're not friendly. Reloading. Recharging my shield. 1 sec.
I got one, I got one.
Enemy taken down.
Yeah, I got one.
Lucky us, we are already inside the ring.
Difficulty's pushing now. I think they're gonna get finished.
Package falling. Should we risk it?
We down and one dead on this side.
Got an opponent here. Navigate down. Speed up.
It's 2 games.
Enemy shield broken. Getting shot at. Enemy killed.
Pushing us. Refueling my shields.
Replicator coming down.
Just go, guys. Alright.
1 minute. The ring isn't far.
Dude, he's fucking hiding over here. Oh my god. Just got jump scared, bro.
Just us two. Follow me, and we will honor the spirit. Refueling my shields.
Yes, it's all those. I can't remember chasing.
In close proximity.
Down. Repeat. I am down.
That's him.
traffic as the rest of them, then there's not really anything we can do. At least we know that we're minimizing the amount of users that have to go to a new server. At least all of these are still going to the original server. It's just this small portion that's not. But at a high level, that's really all there is to consistent hashing. It can get a lot more complicated as you get really in depth, but at a high level, this is really all we need to know as developers, that consistent hashing is a tool in our toolkit that can help us in certain cases. We kind of talked about the popular example of doing load balancing, but only when it makes sense. If each of these servers don't need to consistently map user requests to these individual servers, consistent hashing doesn't matter. We can use a more simple approach like round robin, because that's the downside of consistent hashing. It is complex, and we may not actually need it in most cases. There are other cases where it can be helpful. One example we talked about is CDNs. You can imagine that routing requests to different CDN servers, we would in some cases want to keep them that consistent. So consistent hashing is also used to route requests to CDNs. It's also used heavily in databases, which we haven't talked a lot about yet, but imagine that instead of these being servers, these are actually database nodes. So we've taken our entire database and split the data up into 3 nodes, and we keep a third of our user data on this node, a third on here, and a third on there to be able to handle more traffic. So when we get a user request, we know that an individual user really needs to go to this node. This is where all their data is anyway. So routing them to this node would not be useful. Maybe all their profile information is not on this node, it's on the other node. So consistent hashing would be pretty useful in that case as well. There's another hashing algorithm that's very, very comparable to consistent hashing. It is rendezvous hashing. It's conceptually pretty similar. It tries to accomplish the same thing. In some ways, it's a bit more simple. So if you want to learn a bit about that, it could be useful, but I think consistent hashing is enough for system design interviews when it would come up. The difference between these two wouldn't really be huge in my opinion. And to quickly summarize the main components of consistent hashing, we have our hash key, which in our case was the IP address, but it could be something different. It needs to be something that can identify a user and then consistently map them to a node. IP address is a pretty easy way of doing so. We have our hash function, which would definitely not be as simple as modding the IP address. It's probably going to be some industry grade hashing function, something like SHA, which stands for secure hashing algorithm. It's going to be some variation of this or some other industry grade algorithm that we don't really have to go in depth. And lastly, we have our nodes. In this case, they were servers and we were doing load balancing. They could be CDN servers, they could be database partitions or shards, but we use the general term nodes. We have a certain number of them. That number of them is changing. They could be increasing or decreasing, and that's when we need consistent hashing if we need to consistently map requests to the same node. And that really is all there is to it.
We will not let off the gas. Get in the ring, no cheap losses. My weapon is enhanced.
Enhance my weapon.
Attention, Evo harvesters are online. Warning.
Got this weapon in progress.
I've enhanced my weapon. Sniper stock here. Gold tier.
I've enhanced the weapon.
I'm so slow. Use the sniper gate.
Let's see. I like that.
Care package being delivered.
Incoming care package. Let's see who gets there first.
I say we move there.
Stop. Use the sniper gate.
We should probably meet up. Let's just spread out. I say we move there. Strike out. Care package over there. Let's explore this way.
I'm going. Yes. Ignore enemy in sight over there.
Punching a tunnel. Portal plate.
That's the first of many lights to go up.
They spotted.
Enemy shield is kaput.
Need to recharge my shield.
Seems walking up the left side.
The left? We're toasted. I have a jump tower if you want to use it.
Refueling my shields.
Throwing an Oxstar.
Using tower.
think it'd be better than taking this fight. I don't know. What do you think?
I need help. Care package over there.
We could push this fight that's happening in front of us. After getting the Evo. Yeah.
Speed up. I leveled up. Choosing an upgrade is the only choice. I've locked in an upgrade.
Syringe here.
Health
Four
is
on
a
there.
key. Better top up.
No shot up from another squad.
Broken enemy field.
I'm healing.
ISS down.
Competitor down. Ciao, ciao. Maybe in another time or space you killed me, but not this one.
Damage numbers. What is happening?
Enhance my weapon. Countdown.
Got my weapon enhanced. Danger. Gibt Vollgas.
1 minute. Ring's not far.
Ring's close, with 45 seconds to burn.
Less than 30 seconds. Bye.
Attention, Evo harvesters are online.
My weapon is enhanced.
Ring closing.
Rings coming in. Targets have been in that area.
Ah, first blood. Some aren't made for this.
Someone's got a shot on you, pretty sure.
Dang.
Getting shot at.
Avoid that spot.
Opening pad.
Incoming care package. Let's see who gets there first.
Recharging my shield.
Broken enemy shield.
At me.
He's the gate for any crashers.
Strike out. Strike out.
Stand my out.
So far.
Setting up a fallback.
Keeping my eyes here. Broken enemy shield. Reloading. Getting shot at.
Toggle landing.
Go there.
Putting out a gate.
This time I'm down. Let's go this way.
Getting healthy. I'm done.
Just us two. Follow me, and we will honor their spirit. Down. Kaput. Reloading. Replicator there, if you need it. Big shot.
よせ、お前たちは援護に回れ。てめえは終わりだ。こいつ、俺の着吸い取っている。来るな。こいつらは俺が守る。螺旋丸。
Well, Asian Bunny, how are you?
How are you? Hi.
How was the sleepover last night? You know what I'm saying? You went to the sleepover, the face sleepover. Did you like it?
It was dank.
Oh, it was dank? Are you excited for the what are you nominated for again? I forget.
I'm just presenting.
Oh, you're presenting. What award are you presenting?
Rising Star.
Oh, you think Arky's gonna win? Those are my guys.
Arky.
Wait, do you know the winner?
No.
Are you lying?
Not lying.
After taking down
We need to play together. We cannot be playing loose.
On me?
Enemy shield is coming.
And I'm just dead. This nigga's gun does so much. There's another one. And a gibby. He's rezzing.
Ring closes in a minute.
No, bro. Requeue that.
After taking down Gen G in a tense showdown, Pays reveals T1's true strength. After an emotional victory over Gen G, Pays could not hide his happiness as he helped T1 successfully avenge their earlier loss while also claiming the POM award. For him, this was the deserved result of T1's intense preparation and the team's enormous determination against one of the strongest opponents in the league. Pays especially emphasized that the true turning point was Game 2, a long, exhausting battle that demanded T1 maintain absolute focus until the very final moment. As the game reached its most nerve-wracking stages,
탑이 걸리네?
어둠에 빠진 자들을 사냥해볼까?
스페인 선픽? 개인 상대로 뭐 해야 되지? 드레이븐 이런 거 해야 되는 거 아닌가? 뭐 안 돼? 왜? 뭐냐? 이렇게 따도 되는 건가? 아 이런 거 어떻게 하냐? 그냥 해. 여행이 어디 갔어? 이거 미아핑 찍히는데 나.
Without a challenger.
Backpack here. Level
Shotgun bolt here.
Don't worry, it won't
Level
slow
C.
you down.
We will not let off the gas.
Will any brave soul step up to them?
Optics here. Close range.
Attention, Evo harvesters are online.
I need an extended light mag.
Ooh, a contender. Come on, folks.
Pick up the pace.
Care package being delivered.
Care package falling. Should we risk it?
Backpack here. Level 3.
I got some bad guys here.
I'm in trouble. Engaging the enemy.
Attention.
First oh, that hurt.
That enemy.
I'm down. I actually got hit. I got some bad guys here.
Use this nitro gauge.
They're landing near me. Maybe I should twist them?
Together.
탑이 걸리네?
So we must make our way along. Oh, go back. Oh shit, get back out. I see you. What? Oh my god, getting distracted.
Run into her. Run.
Oh my god.
Run.
I'm safe. I'm to the map. Come join me. No. What did they do to my boy? I will curse them for 1,000 years, only showing the small pebble of my head. They will never be able to hit me. I'm too fast for them. Too fast.
They can't even imagine it. Oh. Wait,
They noticed the dust. They noticed the circle. They will never be able to hit me. They will never be able to hit me. Ever. I'm too quick. I'm too fast. I'm too fast for them. I'm far too fast for them. They will never be able to hit me. I'm too fast. I'm like leopard. They will never be able to shoot me. I'm like leopard. I'm so fast. They will never be able to shoot me. I'm too fast for them. I'm way too fast. I'm like lightning. They'll never take you alive. No.
Bitch.
What the hell?
Fucking depressing to hear. Oh my god, I almost fucking got cracked on. You're not gonna hit me. I did not die. Fucking depressing to hear.
Taking my time for the next 3-4 years.
Jake, if you're going to Florida, who just got up and left there and to your right? Who got up and left?
That was my mom. Taking my time
How did he dodge the robot?
Ring countdown.
Get in the ring. No cheap losses. I've enhanced my weapon.
And ready to die.
Use this nitro gauge.
And in this corner, with your pounds, insert name here.
Enough time for the ring. Half a minute.
got half a match, folks. A contender in this corner, but it's not about the challenger.
Rings moving.
Shields are recharging.
Got another squad. Arm up. Just giving my shields a recharge. Fasten your...
Bleeding out.
Attention.
Enemy there.
I don't know why you got the fucking push here every time.
Kinetic Bobcat, I think.
He's pushing.
Oh yeah, baby. Well, Seki, I'll just wait. Suck the ball. Gotta suck that robot.
What's up, bro?
Yeah, defib.
No, this is a PvP lobby, bro.
No, I mean the guy down there just looted together.
Oh shit.
Cum Slayer.
Oh, the Cums?
Guarantee you don't. What you stroking for,
The
bro?
Cum Slayer. Yo, Keezy, what's good?
Yo, what's shaking, my nigga?
You got a fucking defib for this guy or what?
Yeah, defib.
Nah, I don't got a defense.
Shit.
What happened? What happened?
I killed him.
What you kill him for?
Well, I thought this was a PvP lobby, bro.
Nigga, you don't understand the concept of unwritten arc-rated rules? Kill him for it.
Well, I thought this was a PvP.
You don't understand the concept of unwritten arc-rated rules?
What's the unwritten?
Update, bro. Listen, bro, when it's an update and it's new quests, bro, everybody be coming out here just to do the quest and shit, bro. All that backdoor PvP shit. We got enough problems with the fucking new arc machines that they done put.
He's kind of spitting facts right now.
Be an asshole, bro.
Nah, bro, I actually kind of I agree with you, bro. I agree with you. I agree with you.
It's just real shit, bro. Like, I'm not out here on that right now. I got a free kit, you feel me? Because it's shit like that, you feel me? I'm just out here trying to do my quest so I can get the good shit that they giving us now. You feel what I'm saying? They finally giving us some good shit for the quest that we doing, and we out here killing each other. Come on, bro. That shit don't make no sense.
Oh, you're right, bro.
I'm dead.
Oh shit. Oh.
A hard character compared to Boyle? No, he's not. Well, yeah, but out of like all of his FNCS, he's played with Boyle.
Take the upgrade where you can.
Besides Bila.
We're already in the ring. Time for a break? Spaß.
Yeah, but he had Cold. That's another all-star player, bro. We're talking about Peter Pot.
Use this nitro gauge.
So, talking about bro. Peter Pot and Brian.
My weapon is enhanced.
That's pretty crazy.
Attention. Sisters are on.
Yeah, that's crazy. I'm pretty sure like Poyo is better than Peter Bar right now. I think he is, bro. He's literally been out fragging people like every tournament.
I've enhanced my weapon. First blood.
Yeah, but at one point, Poyo.
Looks like we've spread out. Run your map.
Yeah, but I don't know. At one point, I guess it's not the same. But I don't think like Peter Bot's necessarily a good idea though, because like their end games are like pretty terrible. They're just so good at fighting. Is like. Like most of their points and everything is literally solo clutches. That's how good they are. But like. Yeah. You know what's crazy? If Peterbot never died to Teeny, bro, after killing Shark, they would have won. Bro, imagine the world where Peterbot won that shit, bro. That would have been insane, dude.
I've enhanced my weapon.
They literally almost pulled a Vino, bro. They were in 10th place at the start. You think they should let like their coaches be there? Yeah.
I've enhanced my weapon.
Let's go here.
I don't think you should be able to necessarily have a live coach, but like if you had like a coach like in between games.
There's a competitor in sight over there.
Yeah.
Brother, are we gonna come with us, bro?
Activating jump drive. I see an opponent.
Yeah, there's a fight right here, gang.
The world doesn't revolve around you, bro. It's a team game. How bad, bro? Minus 10 team count.
Attention.
Yo, how you heard that, bro?
New kill leader. I can't wait to meet them.
Bro, he's raging, bro. He's raging, bro. Look at that. Think so?
Taking shots here. Right out. I grabbed him.
1 HP.
The whole squad is out.
You'll have to show me that
Oh,
move.
let's see the last one.
Open up shop and shut him down.
There's a golden alternator here. I'm not gonna lie, bro. The snake
Competitors have been by here.
Yeah, they're here. They TP'd back.
Beginning ring countdown.
I'm getting
Shit. We're getting shot. I see. Yeah.
Replicator incoming.
airstrike inbound. Taking damage.
Yo, they're literally right here in front of us.
I'm down. Wait to revive me when it's safe.
Frag out.
Dude, this kind of scared.
I require help.
Yeah, they're a couple knocks back here. I see you.
Loading. That kills an opponent. Enemy spotted. Over there. Getting. Empty. Jump drive activated.
Is that not TP?
Activating jump drive.
I feel like my ult feels like it's way slower. Probably tripping.
Half the squads are gone. Good. More treasure for me. They won't stand a chance
Can you just
against
go in
you,
the open so I
beautiful.
can buy you?
I looted our teammate's banner. We're already. Good. More. Activating jump drive. Lucky us. We have a mobile respawn beacon.
Attention, delivering care package.
Back in the race.
Saw my whole life.
Here's an activate. Pick up the pace.
Yeah, they're pulling up here. They're pulling up heavy. You might want to back up here.
Up. An airstrike.
Head that way.
Taking fire.
60. They're blowing.
Recharging shields. Jump drive out.
I'm back. Alright, never mind. I guess third off the map.
Round 3, beginning ring countdown.
We're already in the next ring. More time to look.
I'm back. You guys good?
Engaging. Reloading.
Yeah, Gibby's 1 AP.
Some shopping. Replicator on its way. You are coming home with me tonight. Enemy nearby.
Down.
Yeah, keep coming. There it is.
I cracked it.
Crack them.
Reloading.
Can you crawl back? Oh shit.
Quick, here.
Can you rest him off the body or
I
no?
grabbed their teammate's banner. We'll see them soon.
He popped bubble. Wait, he's running over Jordan. I cracked him. He's one.
Enemy down. The ring
Can
is
you go
near,
back to
but
trying to
I can't
rest?
pretend. Anish,
Dead.
took care of that one. I
cracked him. One dead.
Reloading.
Yeah, those guys are terrible. Yeah, there's another team. So am I. I backed up. I'm gonna die. Fuck. Yo. That new character's so fucking shit. I literally TP'd. Yeah, bro, that character's so fucking retarded, bro.
Hey, you've changed. I'm a changed man after that speech, bro. Appreciate you. Don't look at that hero going out into the fucking deep right there.
We're here. Are you any good at infiltration?
Oh, this guy's cheating. He's cheating. He's cheating. He's
Oh,
cheating.
whoa, whoa.
But he's cheating. He's cheating. He's cheating. He's cheating.
You get him, my whole shotgun. You gotta get him.
Yeah. Hey, big crack, big crack, big crack.
Hey, kill him.
Is that the cheater or no? No, that is.
I'm pulling around the corner. Whoa, he's shooting me through the walls. Wait, he's shooting me through the walls. Wait, new cheat. There's a new cheat. What? Oh my god.
Oh, this guy's cheating. He's cheating. He's cheating. He's
Oh,
cheating.
whoa.
But he's cheating. He's cheating. He's cheating. He's cheating.
You get him, my whole shotgun. You gotta get him.
Yeah.
Not a rat. I'm a PvPer.
It's like hell. It's like a... We got two medicine. No, you're my buddy. I like this guy.
GG.
This guy.
No, not the wasp. How many people did I just get, dude?
There's no fucking way that you killed all of us.
I did. I just killed like 8 people. What?
You killed
I just killed like 8 people. Why are you so mad? It's just a game.
Your granny's in that casket. She's dead as shit. Damn, you do not want to team up with your ass.
Where you going?
Get your bitch ass away from me. Your granny died. Your granny died.
People say pretty nasty stuff, but they're just mad they got insanely destroyed right there. Woo!
Round 1. Beginning ring countdown.
Next ring's far right. Come on, no fighting about. Ring's far, closes in 60. Ring was way more fun when I was messing with it.
45 seconds. Pick up the pace.
Ready to just push everyone? Okay, you got a mega, I bet.
Weapons fully enhanced. Nothing stopping Salvo's middle finger now.
Right.
Attention.
Barrel stabilizer here. Level 2.
Going up.
Warning. Movement in progress.
If we let this ring catch up to us, we're done. Enemy over there. Nothing suspicious.
Okay, where is that?
First blood.
Let's steer that way. First blood. The race is on now. Taking damage. Refueling my shields.
They fighting. The what? Okay.
Care package dropping in for dinner.
I'm healing.
Oh, we tried.
Awesome.
Don't kill me!
God.
I'm on his way. I ain't want to be over here. There's some bugs.
Oh my God. What happened? Oh my God. No. All right, you can go. I got low on ammo. I had to get out of there. That was crazy.
Oh my god, they're in the elevator. Oh my god, dude. Oh my god, they're in the elevator.
When you're trying to take a quick nap on your 15-minute break, what in the? What in the? Oh my God! When you're trying to take a quick nap on your 15-minute break,
Round 1. Beginning ring countdown.
We're already in the ring. Time for a break? Spaß. Optics here, mid-range.
My weapon's enhanced. Take the upgrade where you can.
Evo Harvester.
hostile over there. Reloading. We have the benefit. We are inside the ring. Scanning the area. Grenade.
Taking damage. Recharging my shields. One sec.
All father, give me sight.
Reloading. Competitor down. Und tschüss.
At least to our enemy. Let us follow it. Healing my
Smash an
wounds.
opponent's shield. Reloading. Competitor down. Unchiss.
My weapon has been enhanced.
Rifle here.
Now, we hunt.
Opponent wiped out.
Medkit here.
Scanning the area. Fire. Broken enemy shield.
All up here.
Raise the iron drain using a Phoenix kit.
Enemy shield is gone. I'm down. Repeat, I am down.
I bathe in the heat.
That's it, Captain.
Our
Got
aim
people
is
depending
clear.
on you.
Enemies right up.
Down. Repeat, I am down. Recharging my shield.
You'll be alright. The same thing happened to two of my aunties, and they're fine. Enemy, run. There. Don't revive me. It's not safe.
Opponent is close.
Charging shield.
Enemy here.
Down. Repeat, I am down. Right here.
Sight.
Enemy close. Rival right here.
Your time is not over yet.
Let's get you back on your feet, Capatid. Recharging my shields. One sec. Get here.
Ultimate accelerant here. The faster, the better.
Round 2. Beginning ring countdown. Attention. Delivering replicator.
Replicator on high.
I see a competitor over there.
Marking our surroundings. Reloading.
Okay, they're shooting at me.
Epic shields.
Grenade.
Shield cell here.
Half squad still cling to hope. That's cute.
Taking a moment to recharge my shield.
There's a new kill leader. That's a target on their back.
All Father, give me sight.
Opening. Enemy shield is kaput. They're shooting at me.
Throwing it up far. Break
Reloading.
out. Tingnan mo. I'm throwing a thermite.
Hurling a frag grenade.
I'm throwing a thermite. Enemy there.
Go there.
Good shot here. Recharging my shields. One sec. Alright, another squad is here. For the line. Recharging my shields.
So much damage. Punch. One. Literally.
package. Let's see who gets there first.
Extended light mag here. Ordering. Taking a moment to heal. Bless me with sight.
Avoid here. Let's go here.
Hostile over there.
We have a minute to reach it.
Shield battery here.
Care package there.
Elise, ring closes in 45 seconds. I think we should go here. An opponent over there. Ring close in 30. Nearly there, though. Backpack here. It's gold's here. You're only standard stock here. Level 3. Ring close in 10.
Firing.
We're nearly there.
Reloading.
We're gone.
The ring is moving. Let's not. A nitro gauge. Give full gas.
Care package coming down. Helpful if you need gear or a top up.
Care package there.
Healing my wounds.
Another squad is pushing us. Be ready. Kick-starting strike. Enemy, way out.
There's an enemy by me.
Refueling my shields.
Tito, meet me here.
Gas geben.
Reloading.
Shots here.
Replicator on high.
Enemy spotted. Over there. Recharging shield. Don't worry about me.
There are Scotty to be found in this direction.
Competitor there.
1 minute remains. The ring is close.
Recharging my shields. 1 sec. Enemy here.
The ring is close.
They're shooting at me. Firing. Refueling my shields. Care package over there. 30 and the ring closes.
He's over here.
Smoke, far. Surroundings. A leaf to our enemy. They are attacking.
Ring close in 10. We're nearly there.
Split him.
here. Here come the jammers.
Setting a nitro gate. Gas gauge. Smash an opponent's shield.
Hostile spotted.
Ah, so slow. Use this nitro gauge. Okay, they're shooting at me.
Down a squad mate. Already missed on the shaft.
Marking our surroundings. Taking a moment to charge my shields. Taking a moment to heal. Trust in the All-Father. There are unscotty to be found. We took a victory and slaughter. 50 seconds. Safety is advantage on the way.
Healing.
Taking a moment to recharge my shields. Scanning the area.
Minus one opponent.
Recharging my shield.
Using your shields. We'll be toasted by another rival down. Opponent is close. I killed an opponent. Moving here.
Marking our surroundings.
This is what happens when your unit goes AWOL.
Good shit.
Safety's off, folks. Enemies here.